The first thing is obviously when you're connecting, if you guys have any connection problems, just to talk about that, Windows loves to turn the firewalls on. So make sure your firewalls are always off. Okay. Sometimes when the Windows does an update, it'll basically say, hey, we're gonna turn these firewalls back on, and then you won't be able to connect. So if you go to the control panel, I'll just show you this real quick because unfortunately this happens all the time because you guys are doing real networking. Like this isn't some fake Bluetooth or some other, what people claim. Like you literally have a real Ethernet jack on the ECU. So Windows sees it as another computer, right? So it really doesn't like that, and especially if it doesn't know where it's coming from. So right here, system, Windows Defender Firewall, and basically you want to just make sure that right here where it says turn Windows Defender Firewall on or off, you want to, oh, sorry. You need to turn off the Windows firewall. Okay, so make sure that's always off. And then restart your software if there is an issue with that. Because after you do the firewall changes, you know what I'm saying? You're going to want to make sure that you restart it so it then will try to sync up again. Okay, it's because the connection itself, it's the BigStuff software. Like right now, we actually have two Wi-Fi connections on this computer. We've got a Wi-Fi to out to the real world and out to our engine stand over there. So I've got two Wi-Fi's going at the same time, but I had to sync everything up. Now it's locked in place. You know what I'm saying? The BigStuff software knows, okay, this is Wi-Fi 2.
Wi-Fi is going into one software.
Exactly. I have two Wi-Fi's on this computer. It's actually hidden behind here. So Wi-Fi 1 is going to the real internet out, and then Wi-Fi 2 is what the BigStuff's talking over. So I had to sync all that up. Okay. Most guys won't have two Wi-Fi's. Like you guys will only have a single Wi-Fi or the Ethernet. So you won't have to fight that, okay? But typically the firewall is what I see guys getting, kicked in the what about most time when it can't connect, okay? Cycle initially a couple times, and then once it syncs up, it'll stay, okay? So that's going to be your little issue there. Typically is the firewall though, okay? Let me close this out. It's okay. So this is the whole thing is we only have so much time today, and this day is going to fly by. So I really want to answer the questions that you guys have per se, because you guys are the ones that are here. But in this data logger section, you got to replay config, and this is literally how you just said exactly how you want the logger to start. And there's literally an infinite amount of ways. Most guys, if you're racing, will do this application of three-step, and in our world, the three-step is what starts everything on our race timer. Okay, so like MSD days was two-step. In our world, it's three-step. So if you hit the trans brake, and if you go above that TPS, we're starting a log.
Got it.
Okay, that's all that it is. But you can set it so that when the release the three-step, when you drop out the three-step, it goes. But like for turbo cars, we typically will start it. We want to see it spool up. We want to see everything that we're doing, right? That way, when we apply it, we're starting that log. Okay. So, but there's something called advanced apply, advanced release we can get into later if we need to. But that's literally how you can set up to where if you make a certain amount of boost, you're going a certain speed, like anyway, infinitely, basically, you can program that out. Okay. So that's how that works. Yep. So basically, when you guys log in to the screen, there's a few things I always want to make sure that you guys look at here. Okay, so the first thing is the system's got a built-in baro sensor. Okay, so this is measuring barometric pressure right now of where we are. So inside here, it's measuring the air pressure that this is feeling. Your map sensor should always be somewhere around there. Okay, so your map should always be within this range. So right now it's 0.2 psi of boost, which is just a calculation, by the way. We're actually reading that. Everything's in kPa. Okay, so 100 kPa or so, about atmospheric, right? These need to be the same, similar. If they're not, something's wrong, stop. It's amazing, unfortunately, how sometimes wiring or sometimes sensors can go bad, and this isn't close, okay? So just always make sure that that's close, okay? If that for some reason is not, this is okay. It's going to be something with the map sensor.
Even alcohol?
It doesn't matter the fuel type.
Okay.
This is just the map sensor itself. Okay. Always make sure that's within.
Okay.
And it's a 2-second check. It's just a quick little visual, starting the day. And if that's okay, because what happens here is that if this is wrong, the engine runs off this sensor. Okay. So with the ignition on and we're not doing anything, it's going to read about the same as the built-in baro. That's the whole point. It's a quick little visual check. Okay. So just make sure that that is very similar there. Okay. On the coolant and air sensors, again, if you're not in pro mode, which we'll talk about, these are very important to your fuel calculations because we use volumetric efficiency, which we'll talk about in a minute. just make sure those read too, okay? Because if this is reading negative 20 degrees, the volumetric efficiency calculation is going to go, oh my God, we got really cold, dense air. We're going to add a ton of fuel, right? But if it's reading 250 degrees, it's going to go, man, I got hot, I'm sorry, I don't have very dense air at all. I'm going to pool a bunch of fuel. Hopefully got O2 correction turned on. It's going to add a bunch of fuel back in. You know what I'm saying? So we've had guys over the years, oh, I'll just unplug this, unplug that. It's like, no, we need that data to run it correctly, you know?
You're saying the coolant and coolant correction should be the same?
These sensors here. So it's funny, they're actually reading a little bit. Well, actually, I ran the engine a little bit this morning, but that's why it's reading a little bit warmer. But these sensors just have to read. Just be in the ballpark.
Oh, intake air temperature.
Yeah, exactly. So this is intake air temp right here. This is your coolant.
But if you're running it in full mod mode, you don't need.
These will both show 100, right? And the reason why for alcohol guys, we don't care about these values because we want to basically, we're running so much alcohol. Alcohol is a completely different fuel. We don't care about those temperatures. This is basically just a quick safety check. You're turning the car on for the first time in the morning, just doing some quick glances. Okay, literally just takes 2 seconds to verify those 4 things. Okay, just make sure that you're okay there. Because if for some reason you're not, your car's not gonna run right. And you'll be fighting, what the hell's going on? But you can literally just look at this stuff. Now, for you guys that are probably in pro mod mode, you don't have to worry about this. You don't have to worry about these sensors here. But you'll still care about the map and the barrel, okay? Because that's a quick check just to make sure that sensor's okay, all right? And then again, if that sensor's not reading okay, the engine will probably barely even run because it doesn't even know where you are manifold pressure-wise. Okay, does that make sense? Okay.
With the dash, the new dash, pro mod mode, it reads coolant.
Correct, it will. So you still will be able to read the values. We're just plugging in the background 100 degrees for air and water. That way the volumetric efficiency calculation is basically fixed. So we've taken that variable out. That's why we plug in the 100. So no matter what these sensors show, because we recommend to basically make these like head temperature sensors, right? That way you can still measure temp with them. They're not just dead. You can still use them, but we lock out the volumetric efficiency calculation itself. That's why we do that, okay? So you're starting the day, everything's looking okay. Obviously, just make sure that those are lined up. If you're not in pro mod mode, just make sure you're reading something there, okay? If you're not, you're on your own, especially if that right there, like it's amazing how many cars over the years I've seen these guys just unplug them or they're literally just cooking it next to a header. It's 240 degrees and it skews your fuel map just totally by doing that, okay? Because if you're reading really cold, well, now you're pulling, your V map is so small because naturally it thinks your air is always negative 20 degrees, right? So your V map is gonna be really small because it's pumping in so much fuel because it thinks your air is negative 20. It's doing its job, right? And I'll look at this table, I'm like, why is this fuel table so small? And it's just because of that. Or vice versa, their V map is huge, it's high because they're reading such a high temperature all the time. Okay, so you just want to make sure, just quick 2-second checks just to make sure that you're okay there. Okay, the other thing is whenever these engines run, okay, you may get an engine RPM, but that has to go green right there. Okay, sync. Okay, and the reason why that's very important is because however you have the system set up, okay? So in the olden days in the Gen 3, we had that dealer configuration, right? So we got this guy. So it was hidden. We don't hide it anymore. So basically, this is how the system is set up for your ignition system, okay? So you go system, and you go dealer configuration, okay? So when you go in here, how you have this program is what it's going to look for when it's starting the engine, okay? If it doesn't have any of this stuff, you ain't going to go sync. Okay, so this will go, you'll see this will go green. Right now we have it set up for a continuous coil unplug system, which is what most of you guys are. I've got it set up for Hall effect sensors. We'll talk about that in a minute, fine. So I have this set up. It sees that stuff while we're cranking, goes, oh, okay, I know where I'm at. Now I'm gonna try to fire off, okay? If I'm missing a crank or a cam though, you're gonna see that not go green, okay? So a quick little funny story about that is that we were racing. No, good.
VR. So what is that? What's the VR?
That's a 2-wire inductive pickup sensor, like the MSD crankshaft sensor that's been around forever.
Yeah, that's okay. That's what you got mine on. Right?
Yes, that's what you're running.
We're running.
That's fine. That's okay. That's fine. So that again, that's where we'd have set up for VR.
Okay.
So we're on a 2-wire inductive pickup, but you can also that's a stalker LS out there. So it's a 3-wire Hall effect, which we'll go over here in a minute. Okay, but again, that's how this is programmed. If it doesn't see that, you're not going to go sunk. Okay, so that's the biggest thing is if you're cranking, if you don't see that go green, just stop. Something's wrong with either the crank or the cam.
Something definitely required like a Chevy.
Exactly, exactly.
Total LS. It's got LS cranking wheel, everything on it.
Yep, 24X,
24X.
and it runs great. It's just, but if we don't see what we're looking for, you won't go sunk. Now, real quick about the coil on plug is that we only use the cam sensor to actually start the engine. Once the engine's running, the cam is gone. And a good little quick story about that is we were in Colorado racing with Sean Fink. He made a 7-second pass up there and he came back and the car wouldn't start. And he knew, I gotta check sync, So he saw it wasn't going green. Long story short, his magnet actually flew out of his cam. And I don't even know how it happened, but it got stuck on a steel screw right next to it. So it didn't see the cam, it wouldn't start. But it runs fine. Because once we start, we lock in, you can unplug the cam sensor, you can cut the wire. Like him, he lost his cam sensor. It didn't matter. The car was locked in place. So once the engine actually starts, we're done. All we need is the crank at that point.
So the crank sensor is the only thing kicking the timing.
That's it. Yeah, all we're doing is saying, okay, the cam is saying, okay, there's number 1 cylinder. We look at the crank reference angle, we fire the engine up, now we're done with the cam. Okay, that's how that works. So it's a safety factor to where if the cam for some reason goes out, like in the old Gen 3 days, that's where we had what's called that cam crank advance. It'd always be looking at the relationship of the two together. We don't do that anymore. Okay, it's just the crank. So we fire off, we drop the cam, now we're only running on the crankshaft and that's it. Okay, so just something to look for. That is your friend also as well. If why isn't my car starting or this or that? If that ain't going true, something's wrong. And you'd be amazed all the problems. Like for the factory stock shed-on guys, they get those 24X wheels mangled up back there. The pins get bent, you know. Wheels are wobbly. I mean, it's just there's been a few times to where the wire's gone chafed on some guys with their bell housings back there, you know, and the signal's going in and out. You know what I'm saying? So anything can happen on the cranking cam. It's just that if it doesn't see what it's expecting based on what it's programmed for, start looking at your cranking cam sensors if that ain't going true. Okay, so this is just troubleshooting here of knowing what should happen every time when it starts. Okay, so sync. That is what you want to look for there. Okay, let me close this out.
So Ben, if the car's cranking, but not firing, it will show a green or on the sync there if it is synced?
Yes.
Okay.
Yeah, so
while it's cranking but not running.
Correct. So you can unplug, like for example, when we first do a startup, like we'll do with yours, you unplug the fuel, get a timing light on it, and then we're synced. Now we should be setting out an actual ignition signal and we can just check, cranking timing, right? That way the fuel isn't going. But as soon as it goes sync, it's going to light everything off. Yeah, so however the system's set, once it sees that, it's going. So that's why with test modes now, we have to worry about, like in the old days, you had to run everything to test everything, right? Now with test modes, we just test everything and go from there. But once we see this, the system goes, okay, let's go. And it fires everything off. Okay. So that's the biggest thing to look for is that. Again, we're just trying to make sure that troubleshooting wise, you're not going, well, gee, where do I start? My engine doesn't want to fire up right now. You know what I'm saying? So these are like the most basic of basic things to just look at. And also battery voltage too. We've had guys, I mean, I've worked with guys that have had 8, 9, 10-year-old batteries. I said, man, your battery's probably had it. You know what I'm saying? So if you're cranking around 8, 9 volts, that's probably a little low too. So, and if you have a 16-volt battery, you really shouldn't be any lower than around 14 while cranking. Those are not meant to go very low.
260.
Perfect. Good. Yeah. I mean, it's good to have that. You know what I'm saying? Especially if you have like electric fuel pump. But if you have a manual fuel pump, you can typically get away with just 116. You know, so it's better to have it though, especially if you want the weight back there too. Exactly. No, you definitely want the weight. So those are just some quick little checks here as far as what to look for in the very beginning. The dash will display this values, the values as well that we're talking about here. Okay, so it'll show sync. If you're looking at the dash and not going sync, you don't have to have your laptop out every time. You just, again, you may see engine RPM. That's where guys are, I got engine RPM. Well, that don't matter. Okay, if you don't have this, then it ain't gonna try to fire off. Okay, just something just to really look for there. Okay, so once you got all that done and everything is set up, okay, I'm just gonna breeze through these sections here. So basically, you can see here that all these different sections pertain to all the different areas of where you're going to want to go into. So in this system section here, okay, this is where firing order, injector opening time curve, there's all a bunch of stuff as far as configuration. Once you're basically done, you really shouldn't be in here too much except for the rev limiters, okay? So everything else in here basically is done. You have a test mode feature in here for setting up your engine calibration, everything. And this is really cool. This is actually our latest software, which is not published yet, but we actually finished doing everything. There's a test mode feature we have right now, which doesn't cover everything, but we actually added everything now. So every output now can be tested. So the 9th injector output, which is basically just a batch fire mode for anything. You can do water methanol injection, like our Mount Pro Stock guys, that's what they use. I mean, it really is amazing. I don't know if you guys follow Mount Pro Stock, but like John DeFlorian and Powers, they're running a 20-year-old BigStuff box and they're just kicking butt. And that's basically what this 9th injector is. You got a bunch of injectors on top, fogging the manifold. It makes really good power. Okay, so that's what that guy is. And then we've also added every single other output as well.
Will you be able to download on that?
It's coming out soon. It's coming out soon. Yes, yeah. So every output, all the PWMs. We also added the CO2 boost control solenoids. So now you can just simply hit the fill. It'll just fill. You can also dump it. Same thing for the IAC as well. So I don't know what it is about IACs these days, but man, they fail like crazy. So because we do a lot of streetcar guy stuff, and now we made it to where you can actually open up the IAC just manually. You can actually look at it. Okay. Be careful with the LS ones because there's a little spring, and if it goes out too far, you can mess it up, But if you have a way to look at it in the housing or something, you can open or close it. I don't know what it is about the IAC. Sometimes they open up enough, sometimes they don't. They're just, I don't know, they're just not the same built anymore. But you got to spend the money. Like Amazon has like $8 IAC motors. It's like they don't work very well. Get like a genuine GM one and they're good. Okay, but we've added those as well. But everything now can be tested. You can test the bump output. That's what that PWM05 is right here. Okay, you can.
Scramble mode. I still haven't got scramble mode through. Where is that on this?
All that is just that is not here because remember that's just an input that then applies extra CO2. So we'll go to the pin configuration next and talk about that. But in the test mode, especially when we're doing troubleshooting here, you want to make sure that when you're doing this here, just real quick on the injectors and the coils, don't be that guy that tests his fuel injectors with fuel in the rails and fills up his cylinders and then goes and tests his coils next. Yes, exactly. Unless you want to blow your intake manifold off, okay? Unfortunately, it's happened a few times, but if there's fuel in there, it's going to go in the cylinder, and if there's spark in there, it's going to light it off, okay? So don't be that guy. But we've had plenty of guys. What I recommend is if you're just testing coils, just take the coil off, ground the spark plug, and just test your coil on the outside. Okay, that way there's no way it can blow up your engine or burn any fuel. You know what I'm saying? But that's what all it is. And depending on your firing order, it'll just run through everything. So if your firing order is small block 4, 1, 3, 7, 2, so you'll see it 1, 3, 7, 2, 6. It'll bounce around your firing order as well. So again, for guys first building stuff, or if you got a dead hole, EGT shows a dead hole, well, let's check the coil real quick, right? Or let's check the fuel injector, If you have, I always say have a spare injector. That way you can just simply test the injector real quick, put a spare on it and just see if it clicks, put a Noid light on it or something. That way you don't have to actually test your own fuel injector there. You know what I'm saying? Just to see if the output physically is working okay. Usually that's always the case. Usually it's physically an injector solenoid going bad, the injector getting plugged up, but it's all the stuff is testable now.
Check my EGTs. I put it on the dash. I put EGTs on.
Absolutely.
Everything's good, dude.
Absolutely.
The dash, we're going to go through right around.
Exactly. That's again another quick check. If that's the biggest thing about EGT. Everybody's like, well, do I really need them? I said the first time you see something, when you're troubleshooting, you will kiss the ground that you're walking on, because without that data, you're just in the dark. You don't know.
Now, what's the percentage that you would not run an injector, like 10% less than the other one? Because I've had them clean before, and I'll get 10% less on one, on the 700s than the other one. I'll get 10 to 12% flow difference.
The bigger injector, a lot of times you're going to have a variance like that because they're so big.
Gotcha.
So, really goal is to be 1 to 2%, but if you're not within that and that, you can do the individuals, which is this guy right here, and you can pump more fuel in that cylinder if you need to, right? That's what you can do 100%, but they shouldn't be that far off though. You know what I'm saying? They shouldn't. So
meaning the other day, I had a couple that were a little bit different, and they're a little bit different on, when we measured the CCs on the liquid, it was a little bit off.
Oh, yeah. So, I mean, I would try to tighten them up if you can, but obviously you can just come over here and just simply, okay, I'm going to choose that hole. And that's what this is here. You can choose whatever hole that is,
Okay.
and then just simply add the fuel in, and, you know, over time, just do whatever it is you want to do here. Okay. So just as a quick fix. But you know, you try to get DGTs to match up at least, that way, you know, the same amount of fuel.
Green lines, they're all the way across, really.
Exactly. That's what you want to do. That's what you want to do.
That ICF table,
Mhm.
it starts at 1,000. I think mine starts at like 4,000 and goes to 10.2.
Yep.
Does it work below 4,000?
Yeah,
Or
good
it
question.
only starts at 4,000.
Really good question. So let's just talk about this real quick because we're in a table, okay? And we're gonna be bouncing around because you guys got really good questions. But in these tables here, whenever you guys have a table open, it's all gonna look the same. Whether we're on an ICF table, if I pull up a fuel table, okay, you can tell by the icon here what these things are. That's a table, all right? So if I open up the fuel table, you'll see here that I got the same up and down black arrow. I got the same, you know, minus plus sign. Like all the tables are the tables, okay? So for example, if I wanted to change the axis and talk about what Dana's talking about. So right here, I've got a box that's at negative 11 inches of vacuum and 1,000 RPM. That box is always on, okay? So if I'm at 800 RPM and 12 inches, it's on.
Taking or adding fuel, taking or adding timing.
Correct.
When does it change when it gets to the, so if your first box starts at 4,000,
Mm-hmm.
you interpolate it all the way to 10.2,
Mhm.
and it's that big of a gap
Yep.
between the RPM, it'll still fill in
Yep.
RPM.
That box is on. That this table in this application, because this is just the base individual fuel table, that number is always working.
That high, 1,500.
Absolutely. Even though you're starting at a 4,000, it's still on.
And does it hold that plus or minus 2 until you get to 4,000?
Yeah. So then whatever you have programmed past, then it'll start doing. The ellipse will start moving through and doing whatever you want to do.
So it's that first box until it hits the second box, and then it
Exactly. So, right. So for example here, so if I come over here and let's just say in Dana's application, he's got that nice coyote. So we're going to say, you know what, starting at 1,000 is just dumb. So we're going to start this at 5,000 RPM now. Okay. And then I'm going to go up to, let's just say 11,000 RPM. Okay. So now once I've got that, I can left click, highlight, and just hold it over, right click, and I can do interpolate selected values. Okay. So now I'm going from 5,000. And if you want to geek out, you know, you can always say, okay, I don't want 5857. I want to round up and make that, you know, 5,900, right? Same thing for 6714. I can make that 6,700. So again, you can spend all the time you want on the stuff to fine tune it, right? So now I'm gonna apply this change. Okay, so now it's updated. Okay, so now I've just taken that table. Now you see how it just went blew away up there. Okay, because I'm nowhere near this RPM. So now this box over here is going to be what's hot, and this is a good time right now. If you see this box red, hit the box. Okay, if you're making changes, the project on your computer, okay, where this thing lives is always trying to sync up with the ECU. We have not actually matched up the project yet right now. So if you're going through and you're making changes and if you see that's red, hit that box, okay? Hit it, it'll go gray, okay? That box being gray means that everything on your computer, your physical laptop, is the same as what's in the ECU, all right? That way there is no differences. If you see that box red, there's difference somewhere. Something's changed, okay? Now, if you have going through and you're making a bunch of changes, you don't hit that button every time. Whenever I hit that button, it sends everything and syncs up. So you don't have to do it for every table, okay? So if you're going really fast for whatever reason, you keep forgetting to hit that box, when you finally hit it, any changes that have not been sunk up get sunk. That's how that works, okay? So if you don't do that, what'll happen is when you turn off the ignition, you fire this back up, your project's gonna go, hey, something's different. We have differences on my laptop versus what's in the ECU. What do you want to do?
Will it come back as the program that's in there, or are you gonna have to write another one, another name for a new one?
The software is going to ask you, what do you want to do?
Okay, got
Do you
it.
want to send what's on, it's called your local machine.
Yeah.
We'll go over that. Or do you want to take what's in the ECU? Because you got to do something.
Yeah.
Or do you want to work offline? You know, you're gonna choose something, okay? So unfortunately, a lot of guys get mixed up, like, well, you know, what do I do? What do I do? Well, it's because they never actually sent those changes down. They never hit that button to get everything sung up together. So you got to decide, okay, I'll just take what's out of the computer and make those changes again, or I'll send what I did down, right? I never hit the burn button itself. Now everything's sunk up. You understand what I'm saying?
You don't sync on a certain page, you'll sync it all up.
It'll all be done. But you have the way the terminology is, some guys get messed up on the terminology, okay? And the terminology, again, we'll do this one time. It's gonna say controller settings. The controller is the ECU, okay? So Alex, can I get you for a second, please? So what I'm gonna do is here, I'm gonna make a change here, and I'm just gonna take this box and I'm just gonna go 1. Okay, so now I've gone 1. Go ahead and just turn off the ignition out there, please. And then Alex, after like 10 seconds, turn it back on, okay? So I've made a bunch of changes. I'm not gonna hit that. Okay, we're gonna turn off the ignition. So now we're not even, okay? The computer tune-up is different than what's out there on the ECU. Okay, now what are we gonna do, okay? Well, here's how we're gonna go over it and we'll show you, okay? It's gonna say, uh-oh, okay, you didn't save it. Okay, so now it's going to get pissed off. It's going to keep trying to write. It's going to keep trying to write. It's going to keep trying. That message is going to keep coming up. Okay, so don't worry about it. Everything's fine. It's just saying, hey, you didn't save the changes to your laptop to what's going on with the ECU. Okay, so it's going to keep trying to write. So she's going to turn the ignition back on. We should see all the data come back up, and now you're going to see what it's going to ask you. So this is where you have to decide, okay, shoot, I meant to send it down, or you know what, I'll just take what's in the ECU and use that for now and just kind of start over. You know what I'm saying? But you just don't want to, you don't have to worry about what's about to happen, because either way, you've got your data. It's just saying, hey, what do you want to do? You know what I mean? Do you want to use what's in the ECU, or do you want to use what's in your PC? Did you put it back on? Okay, so, all right, here we go. Okay, so now it comes back up. Again, don't worry about it. This is just simply saying, okay, check it out. We have a difference here. What do you want to do? So in this difference report, this is available if you pay for the full $100 for the full version. If you guys don't have that, I really recommend doing this, because otherwise it'll just be a little box and it'll just say, hey, this is different. With the full version for the $100, you get this really nice graphical representation. Now you could have multiple pages of stuff if you had gone through, right? Right, and it'll say, hey, I got all this stuff that's different. What do you want to do? Okay, so this is really important. This is where I want you guys to 100% understand this. And I want to change this terminology in the next software update. I'm going to see if we can. The controller is the ECU. Okay, so this is saying I'm going to use the ECU settings, or do I want to send the current BigStuff Gen4 settings? That's your laptop. That's your computer. Yes.
Can you do each individual page, or is it?
It's all or nothing. It's all because your project's done that way. You're right. Your project has had XYZ done to it, but you didn't send it over. So that's where, yes, you technically can. If I go offline, I can go back and do things and put it back. But you know, you've got 3 choices here. And unfortunately, guys get dyslexic all the time and mix this up. This is where I'm just trying to say, so yes.
That is confusing. I wonder if you put like send new BigCom settings or send new computer settings.
Yeah.
And the other one says not controller settings, says like you said, use ECM settings.
Correct.
When
exactly.
you first started, I'm like, shit, I don't know which one to hit.
Exactly. That's where I'm trying to reinforce this, because I see this all the time, and it's
$100 is well spent on that too, because when that pops up,
Yep.
you know what you changed. Because when you get in that, you're looking at that. I don't know what I changed.
exactly
I get that message and I'm like, shit, I didn't hit anything. What did I change?
right. And that's the thing. It's like, unless you're taking very good notes, which in the full version there is a notes tab, it's kind of hidden, but this is really good to have, so that graphically it'll tell you the difference in tables. So here it's obviously very simple, right? There's a 1 and there's not a 1. So here it's very simple, but you may have a fuel table that you altered and spark tables. It doesn't matter. I literally did one thing and it popped up and said, hey, you know, what do you want to do? All right. So the controller is the ECU. ECU is the controller. Send current Gen 4 settings is your PC. Okay, so here's where you have to decide, okay, what am I going to do? Or I don't want to do anything. I just want to go offline and maybe do something else. Okay, so if you're pretty confident in what you did and you're just like, oh, I forgot to just send those, you know, sync the changes up, then just send it. Okay, and then it'll sync everything back up and you're done. Okay, does that make sense? Okay.
Controller settings will change back to
Exactly. So if I choose that, now it's going to load back in what was in there originally. But you may have done like, 10 pages of stuff, and for some reason you were just whacked out and you forgot to hit that freaking button.
That's cool, because it'll save everything, show everything you changed, and in graphs like that, individually to show where it was. And what
Correct.
you changed.
Yeah,
Correct.
Now your car won't start, you gotta.
Yeah, I mean but that's what I'm saying. There's no need to freak out. It's all there. You just have to remember, okay, yes, I meant to send that down. Cool. Let me just sync everything up. Or shoot, actually, I made those changes. I don't want to use them. I just want to use what's in the controller.
What's that new update then?
This is part of it. This is all part of it. It's what Danny was saying about it's that word. It's the word. It's the word I think we need to fine tune that a little bit, because that controller, I understand that is the ECU, right? But if you guys see that, well, what's the this PC is a controller.
Yeah, see, I didn't know what.
Yeah. So that's really where, like, the goal for today is to beat into your heads what I know you're going to go across when you're not here. So that way, I remember we talked about this. So just understand the controller is the ECU and this is the laptop. Okay. And again, you only will get this if you spend the $100, which I totally think you should do to get the full version. And again, there's other things with the full version that you will get as well. Okay. So just make sure that you understand this controller ECU or send it. So what I'm going to do is, as an example, okay, I'm going to send it down because I actually do want to use that 1 degree. Okay. So I'm going to sync everything up. Okay. So what'll happen is it'll send it down. It's going to say it sent it. And now your button's gray. So it does it for you. Okay. So now we're starting from where, if you had hit the button before, now you're back to that. Okay. So just, again, you don't need to get lost. Don't get panicky. Just know, okay, what I've done is here, it's saved versus what's in the ECU. Which one am I going to use? Okay. Does that make sense, everybody? I just want to make sure we're all on the same page there. Okay. Yes. Just a really important part of what's going on, because again, you guys don't do this every day. And when you see that message, you're gonna be like, well, shoot, what do I do right at this point? Because you may just forget to hit that, because other systems have different ways of getting that data to, sync up together. And all we need is that. If you're just remembering to hit that, it'll always be together. Okay. So that's the biggest thing. And when you open up these windows here, again, I'm going to just make this a 2 now.
I'll find it. I'll mark it as whatever I did and then put a new program in, but that can make so many, if you keep doing that.
That's fine, and that's totally fine. You can do that. That'll work. It's just remembering, okay, yeah, here's the calibration. I edited offline.
But I don't know the change difference. I mean, because it doesn't show that.
Correct. And you can do the compare with the full version. You can actually run a comparison, and it'll actually show you what the differences are between the two files.
I can't show myself unless I open up the other program and go look back what I have to what I redid.
Correct. You get the full version, you can compare it. It'll tell you graphically, hey, these tables are different, and it'll have the next page. It'll show you exactly.
Different programs to see which boost controls and which ones have been changed on either one to see how close they are.
Exactly.
It's about just like that.
Yeah.
Build table, it'll have
Yeah.
the old one and your new one.
You have this. I don't have it on my-
Correct. Yeah, we'll get it today on your computer. It takes 5 minutes to do. So that way you'll have all the data.
Friends here, bro.
You're gonna get a lot. You're gonna get a lot out of this. So here's an example of, I just made that 1 to 2. Okay. As long as you keep this window open as well, you've got an undo. Okay. So now you can just come back over here and say, you know what? I made all these changes. I can undo the last change that I made. So now it goes back to 1. Okay. So as long as you have that box open, okay, you know what? I want to throw that stuff back in. I'm going to hit the back button. Okay. So as long as you have that window open, it's going to save it. But if I close it, all that stuff's gone. So as long as you keep this window open, if you're like, tuning on some stuff and you're making some changes, you can undo and go back and forth. But as soon as you close out that window, it's done. Yeah. Well, it keeps whatever changes were in that window when you exit out of the window. So if it's something you want to play with, don't close it out. You know what I'm saying? So this is a good example of this. So if I send that down, let me close this out. So over here in this section, okay, the gauge cluster section, okay, this is basically to where we're just looking at data. Okay, so this is just a group together, a bunch of tabs coming over here where it just shows a bunch of stuff, all these different sensors and everything here that, you know, that we're reading. It's all just sensor data you can read, okay? In the tuning and Dyno section, though, this is where you could actually go into and actually start tuning on stuff. But you'll see here, there's no undo button. So if I'm in here, it's taking it, right? But a quick little tip is that if I'm on fuel table 1 here, right? I'm on fuel table 1. If I open up fuel table 1, okay, and if I want to grab it and just make it smaller, okay, if I stuff this off to the side, and let's just say down here, I make this box 80, okay? All right, well, you know what, I don't want to do, I want to go back. What was that number before? Well, because I got this fuel table 1 actually open down here, I've got a back button, okay? So now I can go back because this table and this table, same exact thing, right? But now I can go backwards because I got this little one off to the side. So if that's important to you, just shove the window open, and that way you can go back.
So keep your original settings, then you just go back in.
Exactly.
Doesn't the cursor, when you go back over it, tell you what the original setting was?
No. So, oh, you mean right here if I hover over it?
Mine tells you
Yes.
beginning map.
Yes. You can hover over that too, but if you keep making changes and who knows where you were, you know what I'm saying? It'll, as long as this window's open, it'll go backwards and undo and everything that you do. Yeah, you just got to stuff it off the side. There just wasn't room to shove that button in this version. But again, also, you know, again, that's red, so it's telling you, hey, you know, make sure you sync everything up before you close everything out. Okay, so if I was to hit this back, you'll watch that 80. It'll go back to a 78. Okay, and it changed. Okay. Yep, because we changed something. It doesn't know it even though it's back to what it was. We've touched it. So
you gotta hit burn again.
Yep, yeah. Whenever you're done, it's just a good idea. That way, everything's just synced up. And down here, lower left-hand corner, when you're online, it actually states basically what's going on. So if you actually hover over that, it's showing everything it's doing here as you're going along. So that's just a quick little text doc of like a log that's actually happening when you're online. Okay. So again, the whole point is, don't worry about it. Your data's there. You may get a little mixed up where you're at, okay? And again, that's also at the beginning of the day. It's always a good idea too, just to come up here to file and just do a save tune as. Just save the file. You know, you'd be amazed how many guys just keep editing the calibration and don't actually save files too much. So it's always a good idea just to save a file, even if it's just the default date and time, or if you want to just put a file name in there, okay? This is just something you just want to do. Just save some files every once in a while. Okay. You'd be amazed how many guys actually don't do that. All right. So speaking of which, now that we just did a file, we've got a backup. We've loaded that calibration in. Just so you understand, if I minimize this, just so you know here, okay, just so you know where all this stuff lives, if you go to documents, okay, inside here is where all this stuff lives. So here's your projects. Okay, here's the ECU I'm using. Here's the date and time. Okay, and then inside there is going to be where all the data is for this ECU. Okay, that's where all this stuff lives. All your data logs are going to live inside that folder. So whenever you're taking data logs here, okay, everything stays inside here. Okay, so just so you know, file structure wise, where all the stuff's going. Okay. So documents, Gen4 projects, your ECU serial number, then everything is inside there. The reason why I'm just telling you that is because I have guys that have issues all the time. Okay, well, email me a data log, or they're like, well, how do I get it? Okay, here's how you get it. Okay, it's very simple. Go to your documents folder, grab your ECU, and then just send a calibration or a log, whatever. Okay, make sense? Let me put this back. All right. So, you guys doing okay so far? We're hanging in there all right now. I know it's a bunch of crap. So, to learn and to go over. So I think right now is what I'll do is we're going to fire this thing up. So a couple things that you're going to want to look for here is like I said, when we actually start the engine, this doesn't have the sync on it. Okay. So we'll just go back to the old faithful, just the main dashboard here. Okay. So basically, Alex, if you can, just go out there and fire it up. So what'll happen is we're gonna crank, you're gonna see it crank for a little bit, and then as soon as that goes green, okay, right there, then everything will just light off and go, okay? So it's holding 50 pounds of fuel pressure. It's not reading any oil pressure right now. But the biggest thing here is that you'll see that just go off and just sink, okay? And then from there, we can just start talking about everything else is actually running. Okay, so there we go, okay? Sunk up immediately, okay? So now the cam is gone. We're just running on the crank sensor. Everything's good, okay? So the other thing that I really want to talk about right now is this gross pulse width number, okay? This is literally the most important number on the fuel side you're ever going to look at inside, okay? The reason being is because carburetors have jets, okay? We have fuel injectors that use that number. That number is your jet, okay? So with everything being the same, I know you guys have to turn around a little bit. But over here, if you actually come over here, sorry, Chris, it's kind of hidden over there for you. Basically, when we're talking about that crank, the fuel injector pulse width right here, okay, it operates in milliseconds, okay? 1 second is 1,000 milliseconds, okay? The engine right now is running at 2. Okay, this is how small of a time frame we're running on. 1 second is 1,000 milliseconds, and we're controlling at 2 milliseconds right now. Okay, so we're dealing with a very, 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 very small amount of time. Okay, if this number gets out of whack, if something's going on with your fueling, if that number looks different from what you're usually at, something's wrong. Okay, so it's just a good indication. It's a good number to look at to know, okay, something is either off or something's wrong, because I'm usually at around 2 milliseconds at idle. All of a sudden I'm at 1 millisecond.
What would usually cause that though?
A air temperature reading.
Okay.
So for example, right, on this engine, we're actually using the air temperature sensor. So if this was 250 degrees, if it was whacked out, this would only be like maybe 1 millisecond, because the VE calculation uses that sensor, right? But with it running, I'm around 2 milliseconds and all is normal, okay? So this number, whether you're methanol, E85, gas, it don't matter. When you get your engine running, you'll see in logs what everything's running at normally. If for some reason your injector duty cycle starts going crazy, if that number starts going crazy, whether high or low, that's a very good indication something's wrong on the fueling side.
So fuel injection either way, it should be around 2.
No, what I'm saying is in your application, you have to learn. But most systems, when they're idling, big fuel and methanol injectors are a different story. You'll probably get around 1.5 to 1.7 because they're so big, right? Now, you get a big Hemi Pro Charge deal, you may be around 3 milliseconds or something high at idle, because it actually consumes a lot of fuel at idle, right? So it's driving those big injectors because it needs it, okay? But this is a stock engine. It's got stock injectors, 24-pound injectors, I think. So we're actually tugging on these things pretty good, because it's a small injector. It's what you want, okay? But this number varies depending on the engine combo that we're dealing with, okay? But most engines typically will idle between 1 to 3 milliseconds at idle, 1 to 3 or so, around there. Again, generality speaking, okay? And then when you're going down the racetrack or you're under full throttle, 10 to 20 milliseconds, somewhere around there, okay? A lot of guys talk about injector duty cycle. There's nothing wrong with that, but that's just a calculated number. But that is the physical tugging on your fuel injectors right there. That's how much we're actually opening them.
Your injector, then would it be way high on that?
Yeah, so you'll actually have over here on the fuel injector side, you're actually going to have 1 to 5% injector duty cycle is going to be basically idling. 50%, 50 to 90 is okay. Once you get past 85 to 90, you're just wide open. So that's a static number. That's the number you look at to say, okay, I'm wide open. That's not going to tell you the injector millisecond is going to be the number I'm physically applying, time-wise to open it. But the duty cycle itself is going to be, I'm done, I'm out of injector. Okay? So that either you need more fuel pressure, you need bigger fuel injectors, all that kind of stuff. Okay? So but this is just a calculation based on what you have plugged in. But this is the big one here as far as that millisecond time. Okay? And again, it's just, that is the jet opening and closing. That's your amount of, that's the hole actually squirting in bringing the
Is there-
fuel in
is
here.
Like a blow through, like a fuel injected blow through style, is there, you know?
Yeah,
I know he's running a filter, I don't know if you're running a carburetor or a blow through on that.
Blow through, we don't care about the fuel. We just do the spark.
Okay,
So we don't give it, we don't care about that number.
okay.
We just care about
That's why I was
spark.
wondering, like, hey, he's got a blow through, were you gonna blow through or inject it?
No, he's fuel injected. He's got a whole Gen 4 and everything. Yeah. But no, that
Blow
number.
through, you wouldn't even care then, huh?
No,
Okay.
we don't care about that. We only care about the spark, which you do all the time. Okay. So I just like having the numbers. So you can see here, I'm at 1.5% duty cycle right now, idling. Okay. That's right where I should be. Again, it all depends on the fuel injection and what you're running. What you got to be very careful about is that if you start getting too low on this, okay, then the injectors will start getting pissed and they won't actually start working, very good at all. Because every fuel injector has a certain amount of time that they want to be running at time-wise. Okay, these stalkers can get really low. They can go to 1, maybe even 0.8, 0.9 milliseconds, and they'll still work. But again, think of how much time that actually is tugging on the fuel injector. Okay, so what I recommend to guys is if especially with race car stuff, okay, like we're spoiled here. If I was to go to my Lambda tab here, okay, you'll see all my O2 sensors reading here. Okay, so I know exactly what's going on per cylinder because we're spoiled. Now, what's cool here is that the O2 correction is actually live right now. So you can see here that on cylinder 1, I'm pulling about my set point's about 13.5 to 1. What's that? What's going on with 7? Let me look at 7. Yeah. So again, that's the magic of this stuff, right? Idle, for some reason, with this intake manifold and the way the fuel's going somewhere, this thing's getting more fuel for whatever reason, right? So who knows? So it's trying to pull 10% out of that cylinder. So right now in real time, because again, the reason why we're in closed loop per hole is because we're talking Ethernet, okay? So the ECU has multiple what are called CAN buses. This is one of them. So because we're talking 100 megabits a second, we can do this. That's one reason why, okay? Everybody else for their CAN buses are around 500 kilobytes a second. We are 100 megabits. Okay, it's real networking. That's the power of the stuff, why we can correct in real time per hole. All right, so you can see your cylinder 8's adding 1.3%. Cylinder 6 is taking out 5. I mean, it's just literally fine-tuning itself here per cylinder, okay? And the beauty of this is, so when we're on the dyno, when you're on the racetrack, you make a pull, it'll tell you what it's doing per hole. Well, then you take this, you apply it individually, and you're done. I mean, we can cal a motor so fast, it's ridiculous, right? Instead of pulling the plugs out or just looking at the O2 sensors on a dyno, this will tell you per hole what to do like that. So the wear and tear on an engine is just saved immediately, okay? And then if you're ever making a pass and all of a sudden one hole's adding 10%, wait a minute, why is that hole adding 10% all of a sudden, right? Is that injector getting plugged up, right? Am I misfiring on that hole? You know what I'm saying?
So
Something's going on, Dana, in your application, right? And it's gonna be the same thing with you. It's gonna be the same thing. It's like, what's going on with this hole? And it tells you right there because it's trying to add a bunch of fuel to it. So it's at 14.5 to 1. On my target's 13.5. It's doing exactly what it's supposed to do.
So on the bottom, it says right bank AFR primary.
Yep.
And over it says right bank. Where's left bank?
Oh, that was me. I was messing around. That's a good call. So the right bank is this guy right here. Okay, that's 2468. Yeah, so this is actually a good indication. So whenever you're on the software here and you're palling around, if I right click on this, okay, a menu is going to pop up and I can put anything I want inside that box. Okay, so if you're on any of these screens like, oh, I don't want to have this in there, you want to change something else, you can load whatever you want. So I'll just go down to O2 sensors. I'm sorry, base system IO. And I'm going to go left bank AFR secondary. Okay, and then it loads up. So you can populate anything you want in any of these boxes. Okay, you can build it however you want. Same thing with, with this box down here. Totally just do whatever you want with the software. So now, that was a good catch, Dana, is that now everything's reading. So you've got the bank O2 sensors doing their thing, and you've got the individuals, okay?
So what sensors take priority? The cylinder sensors? Because mine, when it's idling, you'll be running and it's idling a little lean, say 13 to 15. But my main O2, my left or bank is 20, 25.
Yeah, the reason why is because your collector is almost wide open atmosphere. So you need to put an extension on your exhaust so that you actually are reading the true exhaust from your engine, okay? Or else what you do is ignore the number altogether. And that's where learning, hey, I need to be around 2 milliseconds at idle.
So during racing, will it and still lean it out, will it still show lean?
When you're racing, get all the exhaust going past, you're gonna be fine.
It's fine. Okay.
Yeah, it's
But
fine.
idling, I was wondering why it's running 25, it's running 20, 22.
A lot of times when you're tuning these engines, you ignore everything at idle.
Okay.
Now this is a stalker, so it's small cam, small duration. We can trust all this. But you have any kind of camshaft or anything really going on, any decent overlap, you're gonna have air mixing, EGR going back and forth and stuff.
So you're gonna pay more attention to the 802s than you are to the two.
If you have
in
it.
the collector.
Exactly. Because now I'm literally reading that hole.
That's right, you're reading now.
I am reading that hole. I don't really care about anything else. This is an average of those 4 holes, right? I'm reading that exact hole.
I'm just wondering why the main 02 was so far off.
Yeah, it's going to be.
You can't get it.
Now you'd be surprised. I mean, minimum is 12 inches. If you don't have that 12, you got like 6, the air will just go like that and it'll just get real air. Exactly. It's going to pull it back. Yeah, and you'll see it. So now with these systems, you can be either on individual or you can be on the bank. So if I come back here, and again, I know we're kind of bouncing around, but you guys got really good questions. If I go,
that's not auto tune pulling 2.8 out of cylinder 3. That's you pulled the 2.8 to get it.
You're
to the
manually doing the
13.5.
tune for the cylinder right now.
the ECU is, I set it up with limits.
So if you didn't pull the 2.8 out.
I'm not pulling 2.8 out. The ECU is.
Right. Oh, so it's doing it on auto tune.
It's doing it in closed loop.
Close. But you could also open that loop and tune it yourself per cylinder though, right?
Absolutely. Yeah. So if I come over to AFR and I go to
You
O2,
don't use closed loop until it's wide open. You're
Well,
open loop.
well, for a street car, you can trust this most. You can get it close. You know what I'm saying? You can do this. But in the AFR section, it's going to tell you, okay, when do you actually want to go closed loop? And just so everybody knows, obviously closed loop is basically the parameters have been met for temperature and RPM. Okay, now it's going to allow the correction to happen. Okay.
Can you run it on closed loop at an idle like my car, run it on closed loop and then look at what it's correcting and then go back to open loop and then take that out of your ICF tables?
Absolutely.
At that minus 13 or whatever.
Absolutely. But again, for what you're doing, you may kind of be chasing your tail a lot of times just because I really wouldn't worry about it too much.
If it's idling, it's idling.
You got a decent camshaft, you got some overlap. The main thing that I can tell you right here is, so what I'm going to do is right now we're in closed loop. I'm going to go to open loop. Okay. So now you see all the corrections just all turned off. Okay. So now there's no closed loop correction going on. Everything right now is just running on my fuel table. Okay. So a good test for any of you guys when you get anything running, you can see I wasn't that far off. I was around 2 milliseconds. Now I'm at like 195, 194, 1.2. So it wasn't a crazy difference the closed loop correction was doing, right? So for any engine, it doesn't matter how big or small it is. You can calibrate any engine at an idle because you can literally just start playing with these numbers. And when the engine starts getting pissed, it'll tell you it doesn't when you're low enough on fuel. So you can literally fire it up and be sitting here and go, okay, I'm just gonna start just taking some numbers out. So I like looking at this better. So if I come over here to fuel table 1 and I'm looking at all my O2 sensors now, okay. So I'm just gonna keep it small so we can see it. So right here, I'm just gonna highlight this entire row. So I've highlighted everything where it's sitting. It's really small, but it's what we're doing. Yeah. So now what I'm gonna do is, I don't want to add it. Okay, so let's go here. So we're going to watch that DD cycle and we're going to watch that injector gross pulse width. Okay, I'm going to go down just by two number variations to the VE table. Okay, there's 2. Okay, we just lower it a little bit down. Now look at everything's almost all in the 14s now, right? Okay, so that 2 number change made a pretty big difference, right?
So you went from 20 or
28.
So it's just 2 numbers.
I just did 2 number change. Remember, we're at such a small amount of time that 2 number change makes a big difference, right? Correct.
Like that one.
Yep. So now I'm going to go down 2 more. I'm waiting for the engine to get pissed off at me. Okay. So now I just went down another 2. Okay. Uh-oh. Now I'm seeing some 15s, right? Now for race car guys, you ain't going to have this data. Okay. The engine's actually still running pretty good. Okay, I'm waiting for the engine to actually start getting pissed at me right now. I want to see, that's what I want to see because we're race car guys, right? So let's just keep going down. Okay, we're gonna keep taking 2 out. Now we're seeing some 16s. All right,
Outside.
there we go. There we go. But it,
All lighting up.
exactly. So now I know, okay, now I'm pissed, right? So either I'm at the bottom of the injector or, you know, it's just too lean right here. Okay, I'm all pissed, right? But you ain't hurting anything. This is just how you learn the engine, right? So now I'm going to put the 4 back in that I was at before. Okay, I just put the 4 back in and there we go. It's back to normal, okay? You can cal any engine this way, all right?
Can you also just do the back button?
Yeah, yeah, absolutely. Absolutely, yeah. Good point. I could have in the back button. Exactly, yes.
That's why I bring them.
Exactly. Exactly. But that's why I do. But like literally, it doesn't matter what the 4,000 horsepower Pro Mod or it's a stock LS. It'll tell you what it wants. You don't have to use any. You can do that with any O2 sensors, right? Because the engine just told you, hey, I don't like this.
I'm gonna
Give me some more.
50-gallon drum of fuel just
You totally can. You totally can. But like literally,
Well, now the plugs are clean, so the fuel like
it'll be clean because you'll figure out, you know, where it wants to be, right? That's the beauty of idle is that you can't hurt anything, right? So now if I start going the other way, okay, so now I'm going to put 4 in, okay? I'm going to go back. I'm going to add 4 now to these cells and let's see what happens here, okay? So I'm going to add 4, okay? Now it's at, now I'm getting down to the 12s, right? Now I'm 12.5 to 1. So, but look at how small of a change it is, right? I mean, we're not making very big changes on the injector gross pulse width because that's the number that we live and die by. In reality, that's what the injector time-wise is being tugged on right now, right? It ain't the duty cycle, it's that. So, okay, let's just go up another freaking 4 more. So I'm gonna hit plus, hit 4, okay? There we go. Now I'm in the 11s, okay? Now the engine necessarily isn't pissed because it's still actually idling okay, right? But it just shows you that you can still keep going up and up and up. Now with methanol, guys, you actually want to run fatter anyways. If you're all at race car, you may have a cooling system. You may want to run. But look, I only went up a tenth of a second on the milliseconds, and look how much fatter I just got.
You can hear the back up to it's not.
It's exactly. So you can literally take all this away and just watch that. You just learn how to tune an engine from idle for anything. Okay. So obviously we're data geeks. We love it. We're going to have you guys, what a minimum will have these sensors to work from. And you can say, okay, I'm in the ballpark. But again, that is your number where most engines are going to be somewhere around, you know, especially what you guys are doing, at least around 2 milliseconds. But you can see here how much time. Oh, I know him. I got to admit him, man. Hold on. So you can see here how much time is actually going up and how much of a change it makes. We're not talking big changes here, right? It's very small.
Little changes.
Yeah. So what I'll do is I'm doing back button this time. So what I'm going to do is I'm going to open this up a little bit so you can actually see it. All right. And so now what we're going to do is we'll just watch this bank here. We'll go backwards with the back. Okay. I just went back now. Okay. Now we leaned out a little bit, right? So now 36 is right there, 42, whatever. So let's go back again. Now I'm down to a 32, and now we're going right back to where we were. Okay. So literally you can just sit there and just play with it all day. You can fine tune your idle perfectly. It doesn't take much to get there. Okay. Once you the hard thing is just getting it running, just getting timing set. Once you're there, this goes really quick. Okay. Does that make sense? Okay. So just play with it, figure out what, now again, I'm assuming that everything fuel pressure wise, mechanically wise. Okay, so does that all make sense right there? That makes sense, right? You can literally tune any engine you want now. Just watch that number. Again, you'll have O2s that over here at a minimum. You won't hurt anything at all, okay? One of the big things, just because we're talking about idle here real quick, is you see this number moving all around right now, okay? That's a spark advance, okay? A lot of race car guys, you may just have this fixed. That's no problem. But for street car guys, you may want to have this jumping around. So if I come over here to my startup idle section here, okay, let's go here. Okay, I'm going to have an idle RPM curve, okay? So right here, based on this coolant temperature, is where I want to be. Okay, so I want to be somewhere between 860 and 700, okay? So I've got my spark advance running around to basically keep me right around there. And even if you're a race car, I don't mind doing this at all too. I mean, if you're a big blower car, you're going to be a 13, 1400 either way. But if you're a nitrous car, turbo car, whatever it's going to be, this number actually works really well. So if you look at your base spark map, which is this guy right here. So in this case, okay, we're sitting at around 20. Now, one thing you'll see here is that I've got 30 everywhere, but I've only got that at 20, okay? Remember, at idle, you're probably going to be somewhere between 10 and 20, okay? There's no reason to have your max timing numbers that you're going to have everywhere else. This is very common. If you actually look at it in 3D, okay, look at that. You know, it's way smaller, right? You're going to have way less timing typically at idle. It just depends. Methanol is different though. You're probably going to have more. So it just really depends though on what your car wants. Methanol, you need a lot of lead, right? Because you're blowing in a lot of fuel. Street car guy, E85, you may not have nearly as much taken out. Okay. So you can see here that the spark advance is booming around, it's bouncing around. If I was to put 30 in it, so if I was to make this 30, okay, so now it just went up because now it's got 30 degrees. I can't keep it there anymore. It's still trying, but it can only just take out so much spark advance, okay? So idle spark's still trying, but it can't get down low enough to actually control it down lower.
So because I'm still having issues getting my car idling,
Mm-hmm.
I tried building that idle spark map where on the low side, when the RPMs drop down, I give it more timing.
Mm-hmm.
And on the high side, where the RPM's coming up, I take timing out.
Yeah, that's fine.
But I couldn't get the car to start that.
That has nothing to do with starting. So this is only when the engine's running.
Why that affected that?
It shouldn't. Maybe we can go over that, the calibration. There's something in there, but that shouldn't have any effect with that. Okay. So what we'll do is I'll just put this back to 20 and you can see it'll just take it down and then it's sitting happier here, right? We're sitting right in the middle of those cells. Okay.
You're doing all your changes in the matter of your closure open loop. Okay.
No,
I know you manually put it in open loop.
yeah, I'm just in open loop right now, but again, we can go back here, the parameters, and then what we'll do is we'll go back to here. And you'll see that we'll go to closed loop and they'll all just take off and go. So it really is, in a sense, just cheating because, you know, you'll have guys out there with magnifying glasses and they'll pull every plug out and they're looking at a fuel ring, you know, where literally in one pass you're done. You know,
He's running his idle when I was running mine at before too, and I said, dude, all I do is put a couple in there on the methanol and it cleaned it right up on the hit.
Yeah. Yeah, and again, it just every motor is different, but this is where if you get a 50-gallon barrel of methanol and just go out there and just move it around. I mean, you're not going to hurt anything at all. So, yeah, so that's basically what you want to look for. Again, we're at 1% duty cycle or so, about 1.9 milliseconds. If anything starts walking away from this, either way down the road, what's tugging on it? What's wrong, right? Just get to know what you're working with. That way, because you guys aren't changing camshafts, intake manifolds all the time. You'll know what the engine wants, okay? So it just helps for troubleshooting because I'm on the phone all day long working with guys, and when I see this, okay, well, what's it at? I'm not sure. Well, I'll have to go back. Hopefully they have some logs we can look at, you know what I'm saying, and say, okay, here's where it's supposed to be, or we'll just figure it out real quick, okay? But you can see here, like that cylinder's got either a little bit of a misfire, right, or something's pissed off. Now, quick little story about this engine. This is actually an engine out of one of my test vehicles, and we were doing a bunch of nitrous development on it. And long story short, I ran a 300 horsepower spray. There was no jet basically in the solenoid. So I ran a completely stock engine with a 300 shot, and it lived. It lived perfectly fine. Now, that plug came out a little nipped though in that hole. So I think that hole is actually a little hurt. But the truck made 176 measly horsepower of the tire complete stock. The motor's got like 280,000 miles on it. 50 shot, 100 shot, 150. We just kept up and it kept making more power. And finally I said, well, I don't care if we build this thing up. We'll just take the jet out. So it put down 480 to the tire without any nitrous jet at all. It was cool. So it ran great and it still runs great. It's just that hole, I think maybe a little burned up, but besides that, everything else runs fine. So, but that's why that hole, but see, that's where the O2 sensor, I can see that. right? If I didn't have the O2 sensor, then I couldn't see that. But it corresponds perfectly with the plug I pulled out that was a little burnt up.
But it's self-correcting itself.
Exactly. But it's probably got a little misfire, a ring maybe a little bent or something, maybe something happening. Something's going on with that cylinder probably a little bit, but yeah, but it still runs great for what I do with it. It's perfect, you know? So, but anyways, that's where, this guy, that's where, again, having the O2 sensors really is nice to have, because I mean, it really just gives you so much data. And again, we're the only ones on the market today, even with all the other big boy brands out there, they don't do this. And it's because for $2,000 we have that. You know, the next ECU next to us that has that communication protocol is probably a $5,000 to $6,000 ECU. So, you know, this really is cool technology. And you can take your methanol deal and use something like this too. It's totally versatile. You're not stuck with that at all. You know what I'm saying? That one ECU can do anything. Okay.
But your Wi-Fi connection is the same as well?
Oh yeah. Oh yeah. It's all the same. Yeah. So because this is true, though, this is a true 100 megabit connection, it doesn't care about what it's talking to. So I've been in SoCal before working on trophy trucks, and I'm literally in my rental car, and I'll have trophy trucks out there bombing around. I'm just tuning on their stuff because they have an extended range Wi-Fi plugged into the ECU out there, and as long as I can talk to it, we're hooked up.
I haven't picked up my extended Wi-Fi yet. I got it all plugged in. So I haven't used it.
We'll just get on the phone. We'll do it. So, and then that's where
I go 800 miles.
you can go as long as it can talk to it. It doesn't care.
Yeah, it's that little yellow box.
Yeah. So you got this guy right here, right? So it'll set up a Wi-Fi network, but for the more race car guys, these are the ones that we do. This is the in-car routers that go on the battery. You'll have a network and a password and stuff, but this is the one like for the guys when I'm just tuning on their stuff from the car. You'll need something like this, or you'll need the extended range antenna so we can talk. But I've been in the stands before. Just watch make the whole pass. I've been on the golf cart before, and you can make the changes in real time when somebody's going on the track if you want. I mean, it's not like it's advisable, but may not be 100% legal, but you're talking to it. You know what I'm saying? There's no reason why you can't, you know? But you can do all that though, you know, because again, it doesn't, the laptop doesn't care. The router doesn't care. It's just talking to another computer. It doesn't know. Right. Yeah. So, you know, that's the thing is like, you know, other guys want to say they got Wi-Fi. Well, it's like Bluetooth, or it ain't real. It's not real Wi-Fi. Like that is real friggin' Wi-Fi. It's an IP address. It's an internet protocol. Like it can't get any more real than that guy. Okay. It's encrypted. No, we're fully encrypted here, so we're okay there. So just to make sure too, guys, make sure also we just want to make sure that the burn button before she turns it off, right? So burn button is obviously gray, so when she turns it off, everything's going to be good. Okay. So now you can also turn off the engine if the ignition still stays on. That burn button can still stay red. It's just when the ignition's turned off to the ECU. If that is not the same, that's where issues can pop up. You got to remember also the box has a built-in gyro and G meter.
Yeah.
So you don't have to run anything auxiliary. When this thing launches, it'll show you your actual G meter curve and everything. So that's your Bible right there. That and your dry shaft sensor is what you need to stare at, because if your G meter is going up, if your dry shaft's hooked up, theoretically you should be able to apply more power. Right? If the dry shaft's spinning, your G meter's falling, okay.
That's where we the SRT. We don't really understand any of that. That's what we're killing it. I see all those guys doing it, tuning it by that.
Well, we'll talk about that, but I mean, that's what sucks. I wish we could spend a week together, but there's just so much to this. It's just one of those things to where
These kids are geniuses on the tuning part, you know, and they're just great with the SRT setup, and they're great with the traction control setup, and
yeah,
you know, and sometimes man, I just keep it floored, you know what I mean?
yeah. We're actually working on some. Actually, Alex, can you just put the ignition back on real quick? We're actually working on some stuff right now. This is going to be next. This is going to be pretty cool. We're going to actually have some advanced dry shaft control to where basically right now you have to build curves to ride curves. We're having a strategy come out to where no curves are going to be necessary. We're actually going to monitor the acceleration rate of the dry shaft, and it's going to go, oh, we're spinning. It's going to pull power out for you.
That's what I need.
It's going to be awesome. So yeah, that's coming out. That's what this is. The advanced dry shaft control is. So you're basically just going to build no curves and just watch that thing pull it out for you.
That's what I need. Right now it's hard because I'll try to see, look at the graph where it's spinning a little bit, you know, and
Yep.
see what we just laid down, and then
Yep.
I'll try to pinpoint how to make it to where I'm not, but sometimes I'm screwing myself in it and I lose power and I go slow.
Right. Well, we have a front to rear wheel speed comparator, which is nice for like street car guys, and that's actually what yeah, the roll race, that's actually what this little connector is right here. You know, you're looking at the wheel speed and we can compare, oh, the front wheel is not spinning as much as the rear. Okay, we're going to pull some power out. But now we're going to be able to actually monitor the acceleration rates of the drive shaft. We're going to go, oh shit, we're spinning. Yeah, and it actually works amazingly well. So that is going to be this guy, which will be coming out in this next software release. So, well, unfortunately, we've been working on it since last June, but it's just more of we set a goal to accomplish, and all of a sudden we're done. Now we got to add a couple more things. So we finally stopped, and it's a huge update. So we're probably about 4 weeks away. 4 weeks away from it. It's very close, but it's a monster update. And then also included in the update, which everybody's been asking for forever too, is you can rename all your inputs and outputs now. So all the default names that are in here, you know, you can now custom name anything you want. So for pressure, fuel, whatever you want to plug in there, you can then basically just say, okay, it's going to be pressure, fuel, you know, whatever. You know, 90. It doesn't matter. It can be whatever name you want it to be. So now in your logs, okay, and your replays, everything will just be the name of whatever you name that sensor. So you're not stuck now. Like if you have something on the nitrous pressure sensor, you can name it to whatever you want now.
Can you use the trans oil temperature sensor for your intercooler?
Absolutely.
Change it.
You'll
it's TO, I think in here it's TOT.
TOT, transmission temperature, correct.
Change that.
Correct. Yep. Exactly. Yeah. And that's actually where, so again, this is going to be part of the next release here. This is going to be our expansion module here, which is actually going to go on to our CAN bus. And again, this thing it's got, I think, over 5 CAN buses on it. So the same CAN bus that the dash talks over, okay, is what this is going to ride on. And this is going to provide 16 more 0 to 5 volt inputs, 5 digital inputs, 5 resistance, and 5 frequencies. So you'll be able to take like the low dollar or the motion, like the resistance sensors, you can put 5 more sensors on here now that are just resistance based for temperature and stuff. Okay, and you're also going to do 16 more 0 to 5s for whatever you want to do. Okay, and you can come over here, and if I close this out, let me close this. If I come over here, down here to system expansion module configuration, okay, you can name these guys whatever you want it to be. So these are the 16 more inputs you're going to have available to you. And at that,
is this what we're talking about? The scramble?
No, this is just this module.
Oh, that one.
So right now we have a fixed amount of inputs between the big bands and the ECU and stuff. Well, now it's a whole nother world because now you can bring in 16 more 0 to 5s, 5 digitals, 5 frequencies, right? 5 resistance. So that's what this guy is.
You have to require the whole car, and you just piggyback that.
No, it's its own harness, okay? And then it just simply plugs into the 2-wire CAN bus, the same one as your dash. So it
still use the modem for the 8.
Yeah, exactly. You'll still use that. This is just simply adding on more 0 to 5 volt inputs, pressure sensors, you know, shock sensors.
You have to have that to do the drive shaft.
This doesn't do Hall effect or VRs. This is just simply if you would, just basic, you know, analogs. Yeah, analog, resistance, frequency, and some digitals. That's what this is for. The cool thing about this is it's not going to be in the software version, but you're going to be able to stack 3 of these. So you're going to be able to, like, if you have 16 0 to 5s, that's going to be almost 46 additional 0 to 5s that you can put on the system if you want. So I don't want to hear anybody ever complain again about not having enough inputs. If you want, sure.
Right now they're through this though.
Yeah. Okay. Yeah. It's however you want to do it. And you can rename any of the inputs here to be whatever it is you want to be. So you'll see here, the reason why it's not out yet is because if I come back to this guy, expansion module, I got analogs and digitals are done. Well, I haven't finished the resistance of the frequencies. So once we finish that, then we're going to be good to go and we can get this thing released. We're just finishing up that part of the code. So, but this is going to be a game changer for us because we understand that especially on the, I mean, the ECU was built to maximize obviously the amount of inputs we had, but it was also meant to replace the Gen 3. So we were stuck in the world of these pins, right? We were limited to what here we had. We only had so many inputs available. So now with that guy, you can literally put on up to almost 50 more 0 to 5s. Yeah. I mean, again, you're gonna have I mean, if you can't get that much, you can't get everything covered with 50 more 0 to 5s. You know what I'm saying? I don't know. I mean, you may be flying an airplane at that point or something. You know, I don't know. But for now, it'll just be the 16, which I think, coupled with all the onboard I/O that we do have, you know, because if you do look over here, these are basically, you know, your base 0 to 5s. All this stuff's still going to be here, right? We also opened up the pan vac sensor as part of this update because not everybody runs a pan vacuum sensor. Well, now it can just be a regular 0 to 5 volt input as well. So that's not stuck as crankcase pressure if you don't want to have crankcase pressure there. It's 0 to 5. Whatever, any type of universal 0 to 5 input, you just enter that scaling in there. So if they have it set up that way, yeah, you can just do it 0 to 5 as well. So that's part of this update. So it's a big one. That's why it's just taken so long. It's not only the software improvements, but we're also bringing this out finally with the support for that. So that's why it's taken a minute. But yeah, we're getting there. We're getting there. So
there was a tab in the Dyno view that did not work,
oh, okay.
and I emailed the EFI Analytics.
Yep.
And they said that would take an update to fix and
Ah.
an update soon.
Okay.
So would that be like a separate update that they would do?
Yeah, that's a good question. So we have firmware updates, right, which we put on the box. That's this firmware. And then up here where it says help, check for update, that's the interface update itself. So yeah, so there's two different softwares, if you would, that's running, all right?
So the one that's we can change all the names and everything, that's a firmware.
That's correct.
So the software is just like anytime it could happen here and there.
Exactly.
Okay.
Yeah. So what we'll do is we'll work with them to put together an update. That'll just update the interface here. I'm writing everything for that. So that'll be a code update. All these enhancements that I'm talking about here, we're writing for this, but you see it all through here. And then they will also have improvements, like you said, oh, there's a glitch in somewhere viewing something here. They'll fix that part of it as part of their update. Yeah. So we're working together with them to get that done. So that's how that works.
Yeah, automatic update check, and you shouldn't have to, it should just tell you.
Every time you go on the internet, it's going to check it. Yeah. So if you go to help and you go, you know, check for update right there, if that's checked, then it'll try to find it every time for you. So, but yeah, these software updates for the interface come out typically about every 6 months or so, typically. But I know we're due for one here in a little bit. But yeah, no, that's a good way to put it, though. That's a good something good to understand, because our firmware updates, they're on this SD card right here. If you guys never updated the box before, basically the update file goes on that guy there. Okay. So the reason why we do it this way is the update file goes on there. There's no loss in translation. Like, it's our firmware directly loading onto the box. There's no cables. There's nothing that we're trying to transmit the data down to. Like, really, it's not that we don't trust it, but we just don't trust it. So this way, the update file is here. It can't mess up, right? Because it's hard coded on this card. You fire up a 12-volt pin, and then we actually load the software in, okay? So that's how that works. And the good thing, again, about the Gen 3 to a 4 is your data is saved indefinitely on this guy. So remember back in the Gen 3 days, oh, I got 20 minutes to get the data out.
He's over here telling me we're throwing the draggy out of the car.
Right? Yeah, exactly. But that's the thing is, you know, it's all saved on there indefinitely, and we'll go over that here shortly. So, Alex, can you fire up the engine again for me, please? All right. So, where are we going now? Let's finish this up here. So, you guys have any questions then about the whole fuel thing, idle thing, all that's making more sense, right? That's all good. Okay. So, a couple more things I just wanted to make sure you guys all understand here is when you're first initially setting this up, system hardware config, this is all pretty self-explanatory as far as, you know, how many cylinders, how many, you know, the type of pressure you want to show, whether KPA map's basically going to be if you're VE or not. Okay. Chevy, Ford. So again, this is all basic stuff you're going to want to set up. Make sure that the stoic is plugged in correctly, because this is, again, part of the volumetric efficiency calculation. Okay. So it's system hardware config. And again, this is all stuff that once it's pretty much set up, you're pretty much done. Okay. So again, most of the stuff you're going to be working on over here, once all this stuff is set up, it's just going to be the rev limiters down here. Okay. And this is where, again, the 3-step is what we use in our world. Okay. So everything, if you're a race car guy, all comes off that. You've also got a 2-step. The 2-step is a 12-volt input, 3 steps, 12-volt input. The half-step is kind of like in the MSD days, you have that burn rev limiter. That's if there's 12 volts on both the 2 and the 3. You can have another rev limiter there if you want. Okay, that's what that is. Okay.
Like if you're going into a burnout box or something.
Yeah, if you want to just have, if you put the 2 and the 3 on, you can have another rev limiter. So, for example, you got a top sportsman guy making, a 3,000 horsepower Pro Charge deal. He's racing a 10-second street car. Okay, so he doesn't want to sit at 5,000 for 10 seconds while the guy's going to track to catch him. You know what I'm saying? So he can put on both the inputs. He can sit there at 3,500, right? And then as soon as he releases off the 2, it then goes to 3 at a second left. Now he's only at 5,000 for a second. But he can still use his 2-step just for a burnout, though. See what I'm saying? So he burns out on the 2-step. He holds it with the 2 and the 3 at a lower RPM on the line. Then he goes to the 3 right before he leaves, and then everything goes.
So the 3-step is, the 2-step works out the 3-step, right?
They're completely different.
So 2 different switches.
Correct. It's two different inputs. Yeah, 2 different 12-volt inputs. Okay. So
All right, can I ask you some questions?
yes.
All right, so I got mine set up that both are on the clutch switch. So it's one switch, activates both. They're both on all the time or off all the time together.
Okay.
So can I use the on-off thresholds to have them do different things at different times? Like I want the 3-step to be a launch rev limiter.
Mm-hmm.
And then if I want the 2-step to be like a power shift where
Mhm.
it's set to like 6,000 RPM.
Yeah.
So I don't lift, I just leave that, I want to put the clutch in.
Right. That's
Then-
what. But
Then the 2-step will work because the on-off won't, the 3-step will never activate, correct? If I have the on-off threshold to, can you set it to mile per hour or no?
no.
Okay,
It's 12 volt in.
yeah,
If that TPS is met, whatever it's targeting is, it will try to target in that box.
so then is there like a hierarchy of, if you have both on?
No, if you have if you have 12 volts on the 2 and the 3, half-step is energized.
Okay,
So you probably won't have a switch maybe on the 3-step
so,
to block it from going in. That way it can be on the 2-step and on the 2-step, right? And then if you want to be on the 3-step, you can, because that's really more for like a race timer starting, something like that. You know what I'm saying? Correct.
and then, so then once it's going down track,
Yep.
if the 2-step threshold is above my launch RPM,
Mm-hmm.
so the threshold for the 2-step RPM is above my launch RPM, then once I'm going down track,
Mm-hmm.
and I put the clutch into shift above 6,000,
Mm-hmm.
then the 2-step will activate, but the 3-step will not.
You'd have to put a relay so we could activate some custom programming so that you'd have a relay in place to say if the race timer started, ignore, turn on that relay output so the 3-step can't go through. That
Okay.
way we're just using the 2-step. So we'll just take a relay to do it.
And so if I didn't want to use the 2-step, I would need some kind of relay no matter what, because the 3-steps activate off the clutch.
Correct.
So when I'm using the clutch to shift,
Correct.
it would either way, it would restart the timer every time I shift here.
Correct.
Gotcha.
Yep.
Okay.
Because that's every time that goes on and goes off, it resets the race timer. So we just simply have an output going to a relay that says, hey, if the race timer's running greater than 80%, right? We'd activate that relay. Now you can bang, it'll open up that relay so the 3-step can't go through, and then it uses the 2-step and you just hit it.
There's no way around that in like the generic port editor or
Not-
anything like that.
No, the only, we have actually, this is new for this update, is we have, it's actually called the custom port editor now, and we go over here to custom port editor. So over here, we have these rev limiter ports. You can actually activate rev limiters under different conditions, but it's not activating a table. It just simply gives you an ETM number and that's it.
Yeah.
So you can do stuff over here if that's the case. But if that 3-step goes high and low, it's doing its job. It's reactivating the race timer, which obviously you don't want to do because you're actually going down the track. Yeah. So that's where you'll have to block that signal from getting in the EC when you're going down. Just have a relay just opens up that input from going to the clutch, or I'm sorry, back to the ECU in the clutch, and you're done.
Yeah.
That's it. I've done that in the past before, and it works fine. So, so also too, guys, just because we're in this section here, this custom port editor now, this is basically where we can do anything that we want for any output. Okay. Yeah. So basically, like for example, on the spare fuel pump that we have here, okay, right now I've enabled it. There's a little green light here. This is where you can do anything you want with up to 4 different conditions on that pin. Okay. So, you know, we've got guys with lockups, we've got guys with dump valves. I'm just talking just, you know, just in general, servo drag rates and stuff. But again, it doesn't matter what it is. We're just simply turning on an output, but you've got these different conditions that you can set up to actually turn it on. Okay. And then when you get over here, we just want to make sure that these up here are set correctly. So if I enable this output, the power on means if I'm not doing anything, it's going to be at rest, right? So if these output channels aren't true, I'm going to be in an off condition, okay? When these output channels go true, active, I'm going to go on. I could do it vice versa, though. I could have it go on by default, right? And then I could turn it off based on the output conditions going true. That you'd switch these around. Okay, that's how that works. I could also have an active delay. So if I go above 50%, I could program, okay, you know what? Don't go true for 5 seconds, right? Or I could say, I also want to add a 5-second inactive delay. So once I go above this and go below, I don't want this output to turn off for 5 seconds. Okay, so you can do anything you want here. And then with the pulse, if that goes true, I'm just going to pulse out and that's it. Okay, so all these different conditions can be met on all these different pins. You can hit the pulse with PWM outputs. You know, so in this case, for example, there's a water pump and electric fan that I'm turning on. So I basically say when the battery voltage is 10 volts, I'm greater than 3 RPM, I turn on the water pump. That's what that is right there. Just very simple stuff. You know what I'm saying? So all these PWM just go true. Now, on the PWM outputs, I can vary the outputs themselves, okay? And you'll see what I'm doing here, okay? So I've got battery voltage greater than 400, I'm turning on. So let's go to pulse modulated output 08. So I'm doing some custom programming here. So I go to this generic section. I'm going to go to PWM 08. Okay. So you can see here that as the engine temperature rises, I'm turning up the duty cycle output to my solid state relay. This is for the fan. Okay. So as I'm getting warmer, I'm cranking up the duty cycle to keep that fan spinning harder. Okay. But it doesn't matter. This can be anything you guys dream of. It doesn't matter. In this application, I'm just using it to drive an electric fan. So if I got to 150 degrees, I'd be at full steam for the fan. So right now, if you go out there, which we'll go out there a little bit, you'll actually see the fan is not at full speed. It's just coming, you know, humming about 80% right now, but it's not at 100 because it's not warm enough yet. Okay. So that's how this stuff works. The custom port editor, if you would, okay, you basically can program any PWM, any output to do whatever you want it to do based on these conditions here. Okay.
But this isn't where we're going in to find for my scramble.
Not yet. Nope. This is just, I get guys, hey, can I do this? Yeah, sure. Boom, boom. And we'll just set it up and we'll configure. So we'll have guys that'll call and say, hey, I want to turn my nitrous on with these parameters. Okay. And so we'll just come over here. We'll just pick an output. Okay. I want to turn my nitrous solenoid and boom, we'll just do it that way. We'll do it on a switch. We'll do it on a certain amount of TPS. We'll do it, maybe it's a boosted deal up to maybe 5 pounds of boost and they want to turn off. You know what I'm saying? So this is where you'll just configure all the different options in here. Okay.
What cycles the solenoid harder? That's what you're saying?
It's just turning on that output. We're just turning stuff off wrong. But if you do the PWM, then yeah, we
Cycle the solenoid faster, make it blow harder.
do whatever you want to do. Yeah, you can do whatever you want to do.
That out already, that update?
Yeah, that's already part of it. This has been there for a long time. So all this stuff here for the fuel curve, spark curve, so boost curve, all these are basically 2D or 1D tables that you can turn on again to do anything you want. Maybe we turn on a 2D fuel table based on when you make a certain amount of boost, you want to add a certain amount of fuel or do something in that fuel table based on that condition being met. Okay, so I can't spend a ton of time on this. We don't have enough time today, but this is where basically if you dream it, we can do it in here. Okay, there is nothing that we can't do inside here. And again, mainly for drag racing stuff, it's mainly dump valves, it's mainly lockups, it's mainly that type of stuff as you're going down the track. You know what I'm saying? But for street car stuff, you can get pretty crazy because there's a lot of different conditions and certain air temperatures, you know, or when the engine heats up, you know, things can happen. So we do a lot of different things in here based on those conditions itself. Okay. Like for example, on a test truck that I have a fan that turns on based on the transmission temperature. So there's no transmission temperature control. So when the transmission temperature gets above 150, I turn on an output that turns on the fan for the transmission cooler for the fan. You know, very just basic stuff like that. You know what I mean? So you can do anything you want with it. So that's this custom port editor. And there are a lot of options now that we're throwing in here to where basically we can plug in different things. I should say, like all this advanced stuff we're building, you can also make it so those advanced options can also be fine tailored inside here. So like that dry shaft control I was telling you guys about earlier, you could actually set up to where it won't get actually enabled until you configure stuff in your Ford. So it'll be enabled, but you can have up to 4 different criteria it has to meet to where it actually turns on and actually starts manipulating the power management control. Okay, that's how this stuff works. But again, this is just more of anything custom, anything you want to make. That's what this is for. Okay. Close this out. Okay. So over here, a couple things under the startup section. For this version 2, we have something new. It's called a prime shot curve. Okay. So basically what we're doing here is we're giving you a pulse of time that you can pulse the fuel injectors when it first fires up. Okay. You turn on the ignition, you'll actually hear the injector go click, click, and then it'll turn off. That's the injector actually open. So for 0.06, for 600ths of a second, okay, we're going to open up those injectors when it's cold and it fires off instantly. Okay. So for alcohol guys, and that's why if you see that thing, it just fires up. We're just basically squirting a little bit of fuel in the cylinders right there. So it's called a fuel pump prime shot. And then whether you're methanol or street car, it don't matter. When these engines actually heat up a lot of times, there's still a lot of residual fuel vapor. You don't really need this table. Okay. So when the engines are cold though, that's when there's no fuel. It's raw oxygen. You may need to get some fuel in that cylinder, in those cylinders to get it going, or else it's going to be building up fuel pressure, and especially with the methanol guys. You know what I'm saying? But this works really well. So I highly would recommend it'll be part of the update. You'll figure out what it wants. You know, if you fire it up and the engine's kind of blubbery, and then it finally takes off and goes, it's probably just too much, right? If it acts the same without the table on, it's not enough.
That's what electric manual also.
Yeah, a manual will work too. You'll just have to crank on it. You know what I'm saying? But if there's like with the mechanical, it's hard. You may set this for 5 seconds or something. As it builds up fuel pressure, it'll score a little bit in. You got to fine tune it with the mechanical. With the electric, it's pretty much sitting there. Especially if there's a check valve, it's a piece of cake because there's fuel sitting there to spray in. You know what I'm saying? So, but remember, this is not much time though. Remember, it's 1,000 milliseconds is 1 second. Okay, this is 800ths of a second. All right, that's still a lot of pulse width. That's probably tugging on it for about max for about 600ths of a second. Because remember, that's in seconds, not milliseconds. Okay, it doesn't take much on that at all. So a lot of the blower guys that you'll see, like the race car guys, where they'll actually blow in alcohol, if they have electric primer, they can just do this now. You see what I'm saying? You won't actually need the primer to blow in anymore. Just do that. Just do that with a primer. It'll spray in the fuel, and then it'll just light right off. So you don't have to do the spray in mechanical if you're all mechanical. You know what I'm saying?
Your new system gonna do some kind of compensation for like water drain?
No, it's
Tuning, so when you go to different altitudes and different humidity. you
just turn on closed
have to-
loop. Just leave it in closed loop at that point.
Does somebody make an adapter for that measures the water drain?
Yeah, we actually have it. It's not here. We actually have a module. It didn't make this update, but we're actually going to be able to pipe in all that weather data.
So
Yeah, you'll
it'll
see
automatically adjust if you can program it.
if you want to do that. Yes, let's just say as the water grains get higher, you know what I'm saying, then you can actually pull a little bit of fuel out. So yes,
Will
that
it do it automatically? It'll measure the
after you
water
build
drain.
the table, yes.
So you gotta build the table.
Correct. Yeah, there's no magic bullet based on the motor, the fuel, all that kind of stuff, right? So you'll have to still build the table, but once the table's built, it'll be fine.
Next thing, you can go to different tracks, different altitude, it'll automatically adjust, you won't have to pull your laptop out.
Exactly.
and try to tune it at every track.
Yeah, exactly.
Every time you go there.
Exactly. And that's where, again, it didn't make this one, but it will be in the next update to where you'll have to build the tables, but it will do exactly what you want it to do. Exactly. Okay. All right. So in the startup section, there's a bunch of other stuff here too. What I would just say here is, hey kiddo, can I use it real quick here? So there's something on these two guys here, the IX start position curve. Again, this is more for street guys, but this is basically where when you crank the engine, this is what it's going to go to as far as the idler control motor. So you'll see here that based on coolant temperature, this is the amount of steps that the motor's going to go open. So that's wide open. 180 is wide open in our world. So now when we start it, it's going to only go to 145 steps, but this is fully configurable. Okay. So if you're doing anything street, you're going to want to use this. If it takes off and goes, wow, and it takes off really high, this is way too high. If it fires up and it just wants to die, this is way too low. Okay. Just something to follow for this table. Okay. And then the other is the throttle follower curve. And all the throttle follower curve does is it just simply follows the TPS sensor. So she's going to go out there and she's going to whack the throttle. So I'm going to go basically wide open when she whacks it. That's the idler control motor is going to go open with it. And then after she whacks it, it's going to come back down. And then it's going to come back down to around 62. Okay.
Then that's when could you reset it by, let's say it's off, like it says 1 on your gauge or something. It's not totally zeroed out. You know what I mean?
Yeah. So right now, so look here.
Where do you reset it?
Yeah. So right here, you'll see that. So right here, I'm about 64.
Yeah.
So right now, the idler control motor, okay, is about halfway, right? Because 180 is wide open. So we're pretty close, about halfway open right now, which is good because a lot of guys actually are at 5 or 0, but that's basically closed. It's actually good to be flowing a little bit of air through it.
Okay, because I'm sitting at 1 right now.
You're probably using one on your car though, so you don't even care.
I'm wondering. That's why I was wondering if I needed to reset that.
Don't even need it. It doesn't even apply to you because you're not even using it.
The other day I was just tripping out, so I was going, "Wow, man, I'm showing throttles open a little bit, and I'm wondering if I'm even supposed to be there right now."
Doesn't matter.
Okay.
It doesn't matter. And another thing too, in our world, you're going to see here that when she whacks, the TPS is going to move. Don't worry about it. If the TPS dies in our world, in other systems, it's a huge deal. For us, you may cough, sputter a little bit, but the actual engine will still run fine. We don't really care if that sensor actually dies. Okay. So go ahead, Alex, and just give it a quick whack out there real quick. Just 2 or 3. And then this way you'll just see how this moves. And again, this is more for just how the motor is controlling, and you can adjust how fast that moves around as well.
Well, he's saying he's having problems on his idle. Could he change that up on his idle positioning?
If he has one, absolutely. Yeah. If you have one, yeah, that's the thing. It's more of if you do have it or not. But you can see that, as it moves around, it does its thing and it follows that curve right there. And then it'll slowly just come back down and control. But I actually have quite a few race cars that actually run one of these things. For you, you're definitely going to run one. But they actually work amazingly well. Especially the engines don't have a lot of vacuum, these actually work really darn good for race cars. So just something to know, if your engine isn't controlling properly, if you can't move enough air past the throttle body, you can get one of these guys on. They make universal applications and they actually work really well. Okay. So just something to know. Those are the 2 big ones I wanted to talk about though, was just the cranking on it and the actual throttle follower itself. So as the throttle increased, it went to these numbers that are programmed in. Okay. So if you go wide open throttle, it's going to go wide open along with you. All right. And then as you close it, it goes back down to whatever it's supposed to be to. Okay. So that's the startup section. Again, when you're doing a cold start, what's nice is on the system, what I would turn on is over here in this AFR section, we have this heater startup. So if you're running the Bosch sensors, not you guys are on the NTK, but if you're running the Bosch, you can actually have the O2 sensors turn on and just sitting there in free air. They'll just sit there in the exhaust. So you'll have this. And basically when you crank it over, you're seeing exactly what's happening in real time live. So if it goes really fat, you'll see it because the O2 sensor is actually on and reading at that point. Okay. NTK guys, you guys can't do that. And the reason why we do that is for you guys is to protect the sensor. You don't want that sensor that's glowing red hot with methanol getting on it. That's a $700 sensor, right? We don't want to crack it. So we don't do it for you guys. But for the Bosch sensors, we do it all day long. So it'll really help you out. So if you're cranking the engine over and it goes 9 to 1, then you'll see that, oh man, I got way too much cranking fuel in there. You'll have it on yours. You'll see it. It'll just tell you, oh man, pull some fuel out of the cranking fuel table. Okay, that's this guy right here. The startup cranking configuration. I'm sorry.
And that's in the new software, right?
No, it's there. This is all, though this heater startup was part of our last firmware that came out last April. So it should be in there. So if you see it on your current calibration, then you have it. Yeah, so you'll have that. But again, it'll just, it's a quick way to adjust the cranking fuel curve, because this is just simply a raw millisecond data based on the coolant sensor. So depending on the temperature of the coolant, it's just going to hold those injectors open that much time. Okay. Yeah.
You know, on that, timing mode,
Uh-huh.
when we're in pro mod mode, the
Mhm.
temperature. For this fix at 100,
Mm-hmm.
will it still work?
So yes, so this is your cranking curve table, right? So you'll be at 100, which is right there. So in this application, you'd be pulling about 15 milliseconds. Remember, the prime shot, okay, is not cranking. You turn on the ignition, it's gonna and then stop. There is no cranking. It just opens up the injectors for a certain amount of time when the ECU first boots up.
So if we have a pump, along with the mechanical pump.
Exactly.
How do you get it to when you hold the prime button, then to get the prime shot?
So what you can do is we turn on the ignition, just turn on your prime pump, turn on the ignition, it'll spray and then stop, because you're already circulating fuel throughout the injectors, right? So whatever that amount of time is to take it off, figure out what it is, you're done. Yeah, so then you can just turn your primer pump back off, because theoretically it's already sprayed the fuel in for you based on the amount of time you have programmed for. And then it'll just light right off.
On the belt, because
Yeah.
the belt, it takes 2 or 3 cranks. We leave the ignition off real quick, you crank it 3 times, then turn the ignition on, it fires right up.
Yeah, if you can build up fuel pressure, then you're fine. You don't need it.
And I used to prime it with a prime pump, but I took all that weight, all the fuel lines and everything out of the car, because I stopped
Yeah.
racing it one race, and I said, I wonder if it'll just start up easy, and I did it,
Yeah, if you don't need it, you're fine.
Yeah. I thought I needed it.
Yeah.
But this table, this cranking curve table, basically when we go sync, right? That's our magic word. That's when it actually does this. So sometimes some cars just take extended sync times. Well, until it syncs, I ain't delivering fuel.
But if you open the injector up longer and give it more fuel, then it's gonna start right up anyways, right? Without a prime pump.
Not unless we're sunk.
Okay, now let's.
Yeah. So if you're cranking over, real slow or something, or just for whatever reason, but the faster you go sync, the faster it's going to start all the processes. You see what I'm saying? So the prime shot, though, has nothing to do with cranking at all. It's just literally you turn on the ignition, it goes, oh, it looks up the table and says, I'm supposed to spray in for, 60 milliseconds. And then it just does it. Right. And you'll have to just fine tune and learn what it is. Like this engine over there, it sits at like 40 pounds because there's a check valve. It's stock LS trunk, right? So it just sits at 40. So I've learned, okay, at that 40 pounds of fuel pressure wants a little bit, because it's on gas too, stock engine, but it just lights right off. So, but it doesn't matter. If you're race car stuff, you can still use that to help out, because again, the cranking curve, this don't do anything until we have RPM. Yeah, till we start spinning. That's what's nice about the prime shot. It don't care. It's just simply a lookup table that when the ECU boots up, it just says, oh, okay, I'm supposed to just spray it in. And again, when we go out there, you'll actually hear the injector go, we'll hear that click, and that click noise is them actually on and then off, because they're being held open for that amount of time. You know what I'm saying?
A lot of times now, instead of, like I said, run that second pump, I'll just get a little can, I'll take off one of my hoses and I'll spray it on the intake real quick, and it'll fire that thing so quick.
That's the prime shot mechanically.
Yeah. The hoses, the fuel lines and all that.
Exactly. Exactly. It's just an easier way just to go through and just do it that way.
Start up on like while you're tuning the crank.
It's up to you. Yeah, it's up to you. Yeah, I mean, you can leave it on definitely. Like if you actually have the heater start up on, it's
He's on.
Yep.
The O2 is hot.
Yes. And this is not like for the 802 guys, this is not that. It's still only going to do the banks. That's it. So your O2 section will be warm because it's on, just sitting there ready to go. And it's going to read crazy high lambda and AFR because it's just sitting in free air. but it's just reading. It's not doing anything. And it barely draws any current, but it is drawing some current. So, you know, if your battery's kind of weak, it may go down faster because it's pumping those O2s up, you know?
What's the engine bank type for a CLO2?
Yeah, so that's a great question, okay? So remember, if we're on a Chevy, okay, closed loop CO2, I'm sorry, closed loop O2. So if we're on a Chevy, that means that we're going to be 2468 on this bank and we're going to be 1357, right? But if I'm on a Ford, which you can actually look at if I go to a Ford like what you are, Dana, if I come over here, I'm on 1234, right? And then 5678.
But if I go to that other deal, it must be wrong, because if I go to the bottom, it says Ford Indy Lambda.
Yeah, you need to be on Ford for closed loop O2. It's got to be Ford. It's got to be Ford. Yeah, that needs to be that way. So, because what'll happen is the system is set up to base, because we have fuel injection harnesses that go out with these guys, so they're actually hardwired for Chevy or Ford. So we're still the only system, amazingly enough, too, that can actually go. Oh, look at that! I'm running out. Okay, hold on. This is kind of cool. So look. So now I'm going maxed out on all my cylinders right now. Yeah, but it's cool. Yeah, it's only 1 gallon tank. Yeah, but it's kind of cool. I'm looking, I'm going, why am I leaning out so bad? So now I'm pinned everywhere in all the O2s, right? So it's kind of cool. So yeah, and I can tell too that that's also getting kind of low. But yeah, we need some fuel. You want to go out there put some in? Okay. But yeah, that was cool seeing all that go to 10. So when she puts it back in, I'll just tell her to fire it up again. So you can fire it back up when it's full, okay? Yeah, so you'll have to check that though, Dana. You definitely want to make sure that on the AFR.
Yeah, you checked in my thing, but it's 1, 2, 3, 4, 5, 6, 7, 8.
That's just a display. That's just a display.
R.
Yeah, you have to choose this for Ford. It'll skew your data. So I've actually had, you know, guys, they plug in the wrong banks for the left and right bank for the big bands. I mean, they get this stuff crossed all the time. And like, for example, Dana, there we go. Now we got fuel pressure.
No, I just noticed that.
There we go. Yeah. Thank you, kiddo. Thank you. So over here, because you have big bands, this is actually where you actually tell which rim module does what cylinder.
So would that be why my dash deal, when you go to EGTs, is reading Chevy?
It could be. It's possible.
Because for some reason the dash, only under the EGTs reads Chevy, everything else reads Ford.
We'll have to look at that. I'm not sure. We'll look at that dash and see if that shows that.
I'd be upset too if our Chevy said Ford on that.
Yeah. Yeah. We got to make sure all stuff matches up though. But so, like, I've had these guys have these backwards.
That's probably why I think it's a Ford.
No, because I got a Ford that runs all Chevy electronics. He set it up.
It's a Ford that identifies the Chevy. Chevy identifies the Ford, yeah. But yeah, for all this stuff though, you really got to make sure that you got this stuff set up right. And so we're going to get to Steve. This is your question now, okay?
Okay.
So you were talking about an EGT safety. So we're going to stop here for a minute. One thing I just want to breeze through before we get to that is in all these sections here, okay, anywhere you see the word modifier, this is where there's basically stuff you can turn on in the system, okay? So these are basically options, if you would, for the fuel side. If I can turn on decel fuel cutoff, coolant correction, power valve, that's why they're just called modifiers to the fuel. These are things that I can do to basically trim out fuel if you would. So over here, I've got the fuel pump prime shot turned on. And I've said, okay, if I'm over 200 degrees, I'm not going to do it. Hysteresis too, but I've enabled it here. Okay, so Steve's asking for the EGT safety.
Well, I burned up that one cylinder last
Yeah,
time. Well,
yeah.
it's the head gasket.
So, no, it's totally fine.
It was my fault. It was a head gasket, but I wouldn't even heard it if it would have laid over and stopped on me. You know what I mean? Then I just unplugged it.
Yeah, you just didn't know. So what you want to do is, oh yeah. Go ahead, take it. There's a plug right there too. Plug right there. Do you guys need a power strip? You got one? Okay. Do you guys need a power strip? You guys doing good on power, Dan? I can get a cord if you need one too. Chris, you okay? Okay. All right, so over here, down here at the bottom, you'll see here we got the EGT add fuel correction. So I'm going to enable that. Okay, so now it's enabled. There's the old burn button right there.
EGT fuel correction enable, okay,
Okay, so you're going to turn that on.
okay.
Um,
And then where's it gonna go from there?
so now
I'm not online, so it won't go.
it's okay. So now that it's actually online, you're going to come over here. Okay.
Okay.
Sorry. AFR, the parameter section. Configuration, I mean. Hold on.
Watch this.
Sorry, AFR. O2 configuration. Okay, so now you'll see that this is not grayed out anymore. Okay, so now you see here that there's two different modes we can run the EGTs in, okay, for the safety. I can be in a dyno mode, it's always on, right? You don't want to be that way because obviously you want to have it going down the track.
Yes.
Okay, so you're going to come over here, race mode, okay, and you're going to say, okay, how long before I actually kick in that delay is it actually going to work? So in this case, for example, this thing's going to wait 5 seconds. We don't want to wait 5 seconds. Yeah, so we're going to wait 2 seconds, okay? So now after 2 seconds, it's actually going to start looking at these values and start going, okay, what EGT do you want me to start adding fuel at? Okay, so let's just say at 1,000 degrees for this cylinder, I want to add 25% fuel. So if I start getting too hot, we're going to throw 25% fuel in that cylinder.
Let's say 180, put it at 180 temperature. I mean, what cylinder?
No, this is EGTs of the cylinder. So if you start going to 1,000 degrees on cylinder number 1, we're going to add in 25% of fuel in that cylinder alone.
It's the optimum temperature. Those are the things I don't even.
So with the small block Ford, it can be a little different. You can actually run them a lot hotter than like a big block Chevy though. Like 900 to 1,000. They actually want to run pretty cool, big blocks. Small blocks usually can run a little bit warmer.
Okay.
So I would set it to start out though, probably around 1,000, maybe 1,100, just to start off with something. It adds 25% fuel, okay? So if that injector's failing, if the injector's plugging up, if something happens in that hole, it'll start shoving in fuel. But let's just say you get to 1,200, the misfire, okay, is gonna be 1,200, all right? So now, if you get to 1,200, we're shutting off that hole.
Okay, we need to start. I don't have none of that programmed in right now. That's fine.
Yeah. So
Do you have a data log of that run?
Yeah,
Was it recording EGTs on that run?
yeah, so we can figure it out based on that.
I hit the head gasket, stupid dude. You know what I mean? And it was, remember I told you I bought the new style head gaskets. And
Yep.
Stupid me, we're in a rush, getting ready to race them.
This will save it. This will save it. Now, it could also do a false positive. I've had guys where their sensors have gone bad and ruins a run, but it's either one. You know what I'm saying? The system's doing its job. So just be aware of, hey, if for some reason that sensor starts going wonky or something happens, if it reads it, it's going to do it.
Well,
Okay.
Like I said the CSP head gaskets, 3-layer head gaskets, they have the ring inside them and everything, but they don't say front and rear. And my ding dong, I'm used to the MLS-X ones that I put, they say front and rear. So I just threw it on real quick in between a race, real quick, threw it on, put the head back on, took off, and didn't even think about it, but I had the whole back on.
Right. Makes sense.
It burnt through the head gasket because it was the thing where the water jacket comes through on the Ford, you need it blocked off in the front. That's what I did, man. I didn't want to tell you, but that's what I did.
It's okay. It's all right. It's all right. It's all right, man. It's racing.
The gasket did say front and rear, and I didn't even think about it. So I always check the small hole in the Ford to make sure it's
Yeah.
back, or in the front plugged off. And I didn't even throw it. I threw the gasket on, bolted the head down, went and raced, and then after I took the head gasket, I looked at it, I go, where's my shot?
It's all right. It happens. It happens. It happens. So that way now that is set up, okay? And then what's going to happen here is when it misfires, you're going to program in the ETM number because basically it's going to say, okay, it's going to go, brrr, it's going to let you know the safety flag is going to trigger, okay? So let's come over here. You go back to this AFR parameters, and then right here is where you'll actually set it right here, EGT misfire warning. So you'll have it set for a 20. Okay.
What does that 20 mean? What is that?
Yeah, so let's talk about that real quick. When you start getting into power management, when you start doing any kind of rev limiting, okay? So the way that Mini set this up is that we have a table, okay, that over here to system and rev limit air table. So basically how this works is if you actually look at a 4-stroke engine itself, there's 32 total cycles, okay? So it's just the way that the actual 4-cylinder motor, the 4-stroke motor works. So 0 basically means no ignition power at all, okay? So 31 means full power, Okay, 31s means we're giving all 8 cylinders, 4 cylinders, whatever kind of motor you have, you're giving it full power, okay? So if we're at a 31, you're making all the torque, engine torque management, okay? If I'm at a 15, okay, that's half of the power. So if I have a V8, I'm about a 4-cylinder making power as far as that point goes, right? About 4 cylinders worth. So this number basically just cuts the power output in about half. But this is the number that controls the amount of torque your engine's physically making spark-wise. Okay, so the safety is set up for a 20. So you're basically going to be down about a third of your power. It's going to go. Brrr.
Okay, so once that cylinder starts to about a third of the power coming out of the cylinder, it's gonna shut it down.
Correct. Correct. So that's programmable. You could actually have it be a 31. It'll just go full power and never actually do anything. You know what I'm saying? The flag will pop up. It'll turn that hole off, but it won't actually trigger the rev limiter. Okay, so 31.
31, you can still shut the hole down though.
Yeah, it'll still shut the hole down. Yeah. But most guys will actually have it to where
They know.
the rev limiter, brr, it hits it and like, oh, is that? I'm going to get out of it.
Yeah.
So the flag will hit, the rev limiter turns on to program it in around 20. That's not too crazy. But if you went to 0, it just shut the engine off. Like 0 is no spark at all. You know what I'm saying? You got to be careful because it will just turn everything off. It's lights out. Okay. So that's what in the ETM world, in the dry shaft control, the ETM number is king. That's how our system works. Okay. What's that? Okay, thank you. So if you ever see these numbers, and okay, what do these numbers even mean? If you're seeing this, it's an ETM number. Okay. That's how we adjust our rev limiter. So if your rev limiter is crazy high all over the place, the starting line, we'll fine tune this table to smooth it out. Okay, like with CDI 600, sometimes they're just really touchy boxes sometimes, and we can't control the dwell like we can with our own coils. So sometimes when we're using these tables, they'll kind of move around. So we'll have to fine tune them better to actually make them work correctly. That's what these tables are for. Okay, so ETM number is very important. Typically our factory baselines are pretty good, but sometimes they do need some adjustment. Okay, but if you're ever going down the racetrack and you look at a log and something, you don't have 31, something's gone. Something's wrong. Unless it's on power management, it should always be 31. But if you're on a rev limiter, if you're on the max engine rev limiter in the 3-step, you'll see that thing bounce around, all over the place. Totally normal. Totally normal. Okay. So now that AFR safety is actually told to come on. I'm sorry, that EGT safety is set up and it's good. It's going to hit at this 20 degree this E temper at 20 and you're done. Now it stays on until the ignition's cycled. So it keeps that injector off all the time. So the goal is to save it before you hurt it. So that's where you're trying to figure out, okay, I'm going to shut it down before I actually start burning the hole up. You know what I'm saying? So, and again, this really falls more like you guys with the methanol deals. I mean, anybody can use it, but if you got 2 injectors per hole, you lose 1 injector, right? This is the way to actually save the engine. Okay. So.
You said it won't reset until you recycle it.
Yeah. So it's going to keep that hole is going to turn off until you cycle the ignition off and then back on. It just holds it off because there's something wrong. It doesn't know it's wrong. It's just going to keep the hole off. Yeah, exactly. Okay. For this section here too, just again, so we cover everything, you can have the EGT units read in Fahrenheit or Celsius. Please make sure that if you got a Chevy or Ford, and again, this definitely applies. Most guys don't have the 802s, but if you got the left bank and right bank, make sure that closed loop type is correct because we don't want to be backwards on that. Because I've seen where guys have a Ford and they actually shows a Chevy. Well, it's closed loop now on the wrong side. It's reading the wrong sensor. You know what I'm saying? So now it's pulling fuel out because the way our system works is this bank sensor pulls fuel out of this entire bank. Okay. So if I go to dual, which we'll do, we'll fire the engine back up. Okay. You'll see here that now these sensors, you're going to see left bank lambda correction, right bank lambda correction. Okay. And you'll see all these change. Just on the banks, these won't do anything anymore. We'll still see them, but we're just going to be closed loop on each side. Okay. But it's very important though, because we got to make sure this right sensor is on the right hole, because if you have this sensor on this side, it's going to read that side, but then change this side. So you got to make sure that your banks, your O2s are correct. So a quick check I just tell guys to do is fire the engine up, unplug the O2 for that bank, and just make sure that it goes offline. Just make sure it isn't reading anything. That way you'll know, okay, cool, I'm supposed to be on the right bank. I'm supposed to be reading 1, 2, 3, 4, 1, 3, 5, 7, whatever, and now I'm on the right one. Okay. Quick little check. It's the same.
Some got sensors on it, cylinders.
Yeah. So what I do is when they're actually running again, same thing. No matter what, now Dyno one, I always pull each one when it's running. I just make sure it's on the right hole. Nope, not at all. And again, because you have to actually set it up correctly over here. You have to set up what hole goes to what cylinder. So the rims can be backwards as well. So, you know, that's where it takes 2 seconds while it's running just to unplug them and to make sure that each cylinder just turns off, basically goes 15 to 1. And that way you'll know everything's mapped correctly. You know,
I just looked at mine, like mine was on Dyno too, so I need to change it.
What's that?
On the EGT stuff, or mine was on Dyno on the other page.
Oh, yeah.
Mine's on Dyno mode right now.
It needs to be on race mode. So Dyno mode, the reason why I don't work in race mode, obviously you do a burnout, you do anything come out of the rev limiter, you could get close to those numbers, right? That's why for race mode, we just say, just look at it going down track plus your delay.
Yeah, mine's not even on. Mine, I was saying, I noticed that the other day.
Right, because your modifier is not turned on,
No,
correct?
no,
Yeah, exactly.
That's why I don't want to go through another cylinder to burn down.
Yeah, don't want to do that for sure.
So, for like, just street driving, dyno mode would be good, but you go to the track, then you wanna switch it to race mode?
Exactly. Yeah.
So
exactly.
you'd be good for driving it in Dyno mode on the street all day. Okay.
Yeah, because at that point you always do want to see it on.
Do a burnout street somewhere. Then.
Correct. Yeah. Yep, exactly. That's the thing. It's doing its job, right? So again, ultimately what we're doing now is that's a great example of being able to add on. So over here where we're actually over here. So over here, when you turn it on, we're going to enable it to work with the custom port editor. So for example, in the ninth injector, okay, you can have all these different minimums and stuff. You know what I'm saying? So we're going to add on more options to where, okay, I want this on, I want it to always be on, but also maybe I want to have a switch turned on or something, right? That's what we're doing. We're adding more features now. We got killer features inside here, but like you said, what if I don't want it on while I'm street driving it? You know what I'm saying? I want to be able to turn it off. So that's what we're trying to focus on right now is adding more features to what's there to make it more custom programmable. That's what we're trying to do. Because the core is good. We got to add more to, you know, to be able to work with it. You know what I'm saying?
Yeah.
So, because a good example of that is if I come over here, turn this back off. Actually, we can actually trigger this too. Maybe we'll do that. If you come over here now to the roll race, I think we talked about this, Chris, with you. So right here with the roll race now, you can add any custom port editor condition. So if I turn on this now, this roll race mode that's always comparing the front to rear wheel speed, I can have it with 4 conditions to be true. Maybe the switch has to be on, maybe a certain amount of top throttle has to be on. You can program it out however you want that logic to work because we're tying it back to the custom port editor now. So that would be a good example of for UGT safety to have another one there, right?
Yeah.
That way in the street mode, have another condition like that to where, okay, this switch has to be on, this and that before it actually turns the safety on itself. So yeah, that's a good one. We should do that one there too. So we're trying to add, we're adding more conditions to where you can tie it back to that custom editor so you can add in all the custom programming you want for those features. That's how that works. But for the race guys, what's that? Yeah, and that's the thing. That's why we made it to where you had the rev limiters over the custom port editor. So I'm just trying to think maybe that would work in that application. We'll think about that. Maybe that would work okay over there. So anyways, that's going to be in this next update also as well, having this condition for the roll race. And again, all the roll race is simply it looks at the front to rear wheel speed, and we're just doing a simple power management curve here to where it just says, okay, I have a certain amount of air. We have wheel spin. Okay, how much timing am I going to pull? It works really well. So like freeway racing or anything else like that. But if you're going on the racetrack too, it works really well also. You start burning out on the track, it'll start pulling out power. It works really well there. Okay. So AFR is pretty much good. It's all covered. Target O2 table. I mean, again, it's anytime you see these tables here, guys, it's all the same thing. You got your little left-hand arrows down there. You can change the axes any way you want, okay, type thing. They all work exactly the same. One of the things too, which you can do is, which is very handy that nobody else does here, is that you can save these tables individually. So let's just say I want to save this table, okay? This is Lambda table 1. That's what it is, and that's today's date and time, okay? So if I save this now, okay, I now have a copy of this exact table. Well, what if I went over here and I made this all equal to, 9 to 1, 6 to 1. I've blown up this whole table. I hit burn. It's all gone. Oh my God, what do I do now, right? Now I'm totally screwed. I just made the whole thing 6 to 1. Well, you can always just come back and just load in that table individually. So I want to include these dependencies, and then I can put that table right back in that I had actually saved. And this way, because I saved it individually, I can load it, send it. Now my table is right back, which is pretty neat. So I actually recommend with a lot of race car guys coming over here, and like here, for example, for race car guy, here's his desired wastegate pressure curve. You can simply just save these desired curves individually without having to load in the entire calibration. So you can make it to where, you know what, instead of having to keep track of the entire cal, right, for file, save as, right, maybe there's other parts of the tune-up that I've touched. And all I really care about is this curve window for controlling my wastegates. You can just simply just save this table as its own deal, right? So if you go to different racetracks, if you have different tune-ups that you want to save for whatever reason, you can just load these in individually. And a lot of guys do that too with the SR2 Gear 1 curves. You can have up to 9 different curves here. You can just save this window individually also. So, 9 different first gear leave curves as far as timing goes, whatever you want to do, well, you can just save this table alone. And you have to worry about, well, shoot, I'm going to load in the entire calibration from a month ago. What else did I do to it? You know what I'm saying?
But you can come back and then put that one back in if you want.
Absolutely. Yeah. So if you keep track of this, you have less danger of monkeying with everything else because all these windows can be saved individually.
So I do have a question on the target AFR table.
Sure.
How is the computer, you have the target AFRs. If you're running the target AFRs and your actual AFRs aren't meeting your target, do you go into the VE table and adjust the VE table to meet your target?
Mm-hmm.
That's
Yep.
basically what you do.
Yeah. Yeah. And again, we can.
You know which,
What do you mean? What do you mean? How?
well, I guess that's why the dyno comes in, right? Test, read,
Yeah.
adjust.
Yeah.
Test, read, repeat.
Basically, what's happening here is the closed loop feedback is saying, hey, at this moment in time with this error, with the booster ring, blah, blah, I'm pulling 10% in this section of the VE table. And we'll go over that. I don't necessarily pull out 10%. I'll go maybe 3 or 4%. It's not, I don't.
On the correction table.
Correct. Well, no. On the actual VE table itself. So if the O2 correction was pulling, a ton of fuel out up top, say it was maxed out at 10%, you don't want to just simply come up in here where it is and just take out just 10%. Okay. That's a huge jump. I do maybe 3% and see all of a sudden you may be only pulling out 7%. You know what I'm saying? Don't just go exactly what the correction's doing. That's a big jump. That's my recommendation, because you may find that little 3% change all of a sudden is perfect. Okay, it's just the way that it works. Okay, and again, just so we're talking about the multiplier, whenever you're talking about adding fuel or taking fuel away in the system, you have to follow this little method right here. So if you want to add in 20%, you go 1.2. If I want to take 20% out, I go 0.8. Okay, everything's based on 1. All right. And you'd be amazed. Some guys will just put an 80 there thinking they're going to pull out 20%, or I don't know what they're thinking sometimes, but they bomb it. And do you have no cal by any chance? You know what I'm saying? So, but just follow that decimal point, and that's the same for any table, because every table has the same exact icons there. Okay. So just make sure you follow that method. All right. Also too, for just going back on the AFR section itself, for the closed loop side, so this stuff here, we have to slow it way down for individuals, okay? If I'm on the banks, which a lot of you guys are on, okay, these are going to be the bank settings, because now we actually need to speed it up. So this would be 30%. So now that I'm going to go close loop on the banks, I actually want this gain to be faster. This is how fast the O2 correction actually, actually works. It's how fast it's going to look at, okay, my AFR is supposed to be on methanol 4.5 to 1. I'm reading 5. I got to add fuel. This is how fast it's going to operate and actually add in fuel.
So 10 on the CL gain if you're running IC rim.
If you're on the IC rim, yeah, for what you're doing, you don't want to have that gain any more than 10 if you're on the rims. If you're on the individual banks, you want to be around 30.
And then what about the CL max step, Rich?
Yeah, for the
10 or lower those two.
I usually make those about 5, -5 for the IC rims. You can speed those up a little bit, but the gain is the big one. That's how fast it actually adds to the track. 35 is fine. 35 is totally fine.
8, okay.
Yep.
And then 10.
Yep. Yep. Again, the reason why is because it's individually, it'll be too fast. The correction will just go like this because it's just too fast. You have to slow it down because we're only looking at the one hole, right? The bank's looking at 4 cylinders altogether. So we got to speed it up because now you're doing 4 injectors on that one cylinder. I'm sorry, on that one sensor. Okay. So that's going to be your default for something like that. And then what we'll do is we'll put the heater startup on. So that way you can actually see the bank injectors turn on. I gotta cycle the ignition for that, but you'll see the O2 sensors light off, and these guys appear. These are your bank sensors. Oh, there they go right there. So right now they're on. They're reading 11 lambda. Okay. So for example, again, if I right click over this, I can stuff any value I want inside there. The software defaults to lambda, okay, which is just the default. But if I come over here to left bank AFR secondary, okay, now I'm at 200 AFR. Because remember, all the AFRs, it's just a calculation, right? I actually put it over here for you. So if you actually look at, the AFR targets here, lambda times air fuel equals AFR. So 11, we were reading what? It's about 13 lambda right there times 14.69. That equals AFR. That's what that shows you up there. Okay. So it's just showing you 201 AFR, but it's completely false because we're just sitting in free air basically right now. That's why it's showing you the value. It ain't hurt anything. It's just basically reading, almost free air right there. So the NTK guys, you don't see this, but the Bosch guys do. So again, we don't turn it on because we don't want to hurt that sensor. It's just too much money. So, and especially when engines are cold with the methanol, you see them puking the water out. These sensors hate water. They have ceramic in there that's probably close to 1,000 degrees. If that ceramic cracks, you're done. Yeah, it's definitely a good idea to do that. So back in the day, that's where John actually provided a switch to actually turn them on once the engine was warmed up. Let that water, let all that condensation get out of there, then put the switch on, then actually read it. You know what I'm saying? Bosches aren't nearly susceptible to that, especially if you're on gas 85. You don't have the condensation. So that's why it doesn't hurt. But they're on right now. They're cooking. If you were to go feel those things, they'd be on. We don't turn all 8 on though, because 8 all at once is definitely a good draw. So the banks will be on though. So this is where now we could actually crank it up and watch it. And if it went pig fat, you'd see it right here because they're lit. As soon as you crank, it sees the air fuel. If it goes really lean, it goes 17, 18 to 1, then it comes back. That's how you adjust your cranking table. It'll tell you right away. Okay.
So is it the motor out there, does it have 10 O2s or is this just individual? It's got 8 and then it's averaging. Oh, it does have.
It does. Yeah, it has all of them. So that's why when I was over there on the individual table on this guy, we were in closed loop correction.
Yeah.
But you can see here now because
it's an actual reading from a sensor. It's not just taking the 4 on that bank and averaging it and telling you.
No. This is no. So when we go out there, you'll see an O2 per hole, and that's how we're correcting per hole.
Yeah.
Yep.
I'm saying the secondary ones, that's a completely different sensor.
Oh no, that's on the collector for that side.
Yeah, so it's not taking the 4 individuals.
No.
And averaging them and just telling them.
That's the real sensor.
Okay.
That's the real sensor. That's why it's on, it's hot.
Yeah.
It's reading it right now. So, but again, that's where it's just showing, it's 13 lambda because we're not an AFR. So if I was to come over here and choose AFR, you'd see it, you know. So keyboard here. All right, so it's crazy. It's almost lunchtime. We still haven't got past the top yet, right? It's amazing how fast it goes. All right, so everybody pretty much clear with the AFR. The only thing I want to say on the AFR is we do have a safety configuration in here as well. So if you have individuals, if that cylinder gets too lean, it'll cut that hole out for that hole. It'll hit the rev limiter for there. If you have the bank, it'll trigger the bank as well. So there are some AFR safeties you can turn on. Okay, and we fixed that one too that you guys identified. I talked to you guys about that. Yeah, about the right bank and left bank. That is fixed. Yeah, we fixed that. Yeah, that's that on this next software version. We took care of that. So the right bank and left bank were basically triggering both, causing the issue. So now they're fixed on that. But we can talk about that. But if you can set an AFR safety, there's that 31 in there to where if it does trigger, you can have it set to whatever ETM number you want, you know, and you can have the threshold be whatever you want AFR wise. You know, it's totally up to you. There's a hysteresis, give it a delay, give it 2 seconds before it actually turns on, okay? So you can program that in there as well. Totally up to you, okay? And the other thing is too with the AFR section is just make sure that you've got your positive and O2 correction tables configured, because if these tables aren't right, if you don't have anything in there, it doesn't matter how good closed loop is, it ain't gonna do anything, okay? So just make sure you've got RPM, you've got load, you can adjust this any way you want. You know, some guys will, I just do it all just for this engine, just made everything the same. But if you're in a wide open throttle and you want to give it a ton more, you can go up to 50%. So if I made this equal to 50, now I've got the max amount of fuel I can add under full load. Okay. It's up to you. You can totally do it however you want to do it. It's just, you know, it's how much. You just got to realize that during the run, if for some reason it starts getting a little lean or it shows a little lean, it's going to pump 50% fuel in there. You know what I'm saying? So if you get it somewhat close, you shouldn't have to have the corrections as nearly as big as this, you know? But it just depends on how you want to run your operation. I've had guys run it like this. They've had a fuel pump fail, sus fail, that goes to 50 and it saved them. You know what I'm saying? So it's just however you want to run it. Okay. But that's closed loop. You've got to program those tables. If you just trust the defaults or whatever is in there when you get it, it may not work right for your application. You know, same thing for this curve. Like right here, this is actually set for 30 pounds of boost, right? And zeros here. So the ellipse is sitting here because it's atmospheric pressure here. So this has to be tailored to meet that engine. You see what I'm saying? It's actually set for a 30 pound boost number on that curve. So you always want to make sure that these tables are set correctly. Okay. What's that?
Just add more and then back it down. Is that what?
Yeah,
It's better off starting high and low and then backing it.
Absolutely. Always walk it back. Always walk it back. Don't ever trust it. You know, I've done it in a bunch of cars, and especially on LSs, I'll start typically around 10 degrees total timing, and 10 degrees, it should be a total turd. I've had a few where 10 is like perfect. It doesn't make any sense. Well, it's because their timing just wasn't right in the engine. They thought they were 10, they really weren't. So always want to start soft, let it be a dog, and that way you'll know it's bad, and then you start working your way up. Just let it be a turd when you first get stuff going. It doesn't hurt at all. It just will verify that, you know, you're actually are only at 10 degrees or you're really foul kind of stuff, then walk it in. Don't ever assume anything doing this stuff, you know, don't ever do that. The other thing here, obviously the big one here is the ignition setting. So again, in this modifier section, when you first get an engine running, right there is going to be your baby, the test timing. So basically you set that for 30. All I want to simply say about this is you set it around 3,000 RPM. Do not set your timing at idle. It doesn't matter if you're a street car, you're a race car, rev it up. The reason being is because if you do it at idle, there's latency, there's time involved for everything to happen for the spark to get out there. Okay, if you rev it up to around 3,000, that time is gone, and that'll be the same as 10,000. Okay, so that's where you actually want to lock this thing down. Okay, so for example, on that LS, I have no way to move it around on the crank trigger. So all I would simply do is come over here and plug in an offset and the crank offset adjustment. And
So I
that,
can offset a little bit on the timing too, to get it, put it in, so if my timing's sitting at 20, I can pump it up to about 30, just on that right there.
oh, this is just a calibration. All we're saying is, because remember, the ECU doesn't even know anything about timing. It's putting out a number based on how you program it. So if you're at 3,000 RPM and you're supposed to be at 30 degrees, but you're reading 28, you can put 2 in here and that'll get everything to line up. That'll add 2 to what you're reading on the gun. So now you go to 3,000.
That's what I needed to know, because sometimes, you know, like when we reset things, we put the motor back together, it's not always perfect.
Exactly,
You know what I mean? It may be
exactly.
a degree or 2 off.
You always check that when it goes back.
Okay, that's what I need, because right.
Always, yeah. Just go to 3,000. If it's not at that test timing number, either move the crank trigger itself, right? Or you just edit this number right here, this offset angle number. So if you're low, you put a positive number. If you're reading too high, you put a negative number. Okay. And then in the crank wheel teeth here, 24 is what the LS is for. But in our world, you simply are going to have, if you're a distributor, you're going to have either a 4X or an 8X. And then if you're coil on plug, you can do these different patterns. Then obviously all the stocker, you know, LS, Coyote, modular, all that kind of stuff we can do. Okay. So for race car guys, most guys MST crank trigger is typically just going to be a 4X, but Dana's got a factory Coyote setup. No, he actually runs a coil on plug with 2 VR sensors. He's a little bit different. You're still 24X, but these are the crank wheel patterns that we have. Okay. Yeah, so you actually start out with a 45-degree offset angle.
I think -10.
Yep, and that's okay. That
I'm a little 15, you know, because
yeah.
I
So
tested at 15.
so your factory stock showdown combos, okay, that your number, okay, for most everybody it's 0. Yours is 45. So 45 is 0 to you. So
I came in at 11.
correct, exactly. That's the same as putting 4 here for me.
Now, what if I take the -10 out and just put it at 0, and would it could run better maybe a little?
No, your timing is gonna be off.
10%.
Yeah.
Okay, so, but right now, how about if I plus 5% into it and make it like,
All this is for is so that visually you're looking at the same thing as what's in your ECU.
because I'm sitting at like 29, 30 at idle, right there, dude.
I don't care about idle. I want 3,000 RPM. That's what we care about. The reason being is because when you're at 50 pounds of boost and everything else, I need to know that my timing isn't moving around. I'm stuck at that value, whatever I'm
When I'm
commanding.
at 30 on the gun, I do it to 3,000, I'm stuck right about 29, 30.
Then that's right. That's right.
And I'm 30 on the gun, you know what I mean?
That's exactly what should happen. But the biggest thing is a lot of guys will just go to idle. It's like, no, you gotta get it up, get some RPM going.
Bounces a little at the idle, that's why I was asking.
That's fine.
That's
We
why
don't
I was
care.
asking. On the idle, it bounces a little bit.
We don't, it could be 4 or 5 degrees off at idle. We don't care.
Yeah.
Let it be off there. We don't give a damn. We're idling. We don't care. Who cares? But when you're making power, we need to know exactly where we're commanding that timing at. That's why it's very important. And also too, again, when the engine starts speeding up, okay, sometimes there's some drift, there's some latency, there's some time. We're dealing it in microseconds. That's why we have a box here. Don't ever touch this, guys, but this is called inductive delay, okay? So that's set for 112 microseconds. And I put this up here, okay? And there is 1 million, in 1 second, there's 1 million microseconds. Okay, this is how much time we're dealing with here. So if you're coil on plug, you're 112. Okay, if you're like an MSD box, you put it at 10. Never touch the number. Other systems will mess with that number all the time. Don't touch it. What's that? Then leave it alone. You just have to leave it alone for now, because you can put it back to the base number. Again, your timing may move though, because the microsecond number is different. It's going to change the way the latency, the time is calculated. Okay, so if you have it this way and it's worked, you probably want to leave it alone. Unless you put it back to default number. And again, if you rev to 3,000, you're probably going to move and just put it back to where it needs to be to get it at that number. Okay. Because again, the ECU doesn't know timing. It doesn't know anything. It's depending on your eyeballs to tell you where to tell it where it is. When you're commanding 30, it doesn't know anything about 30. It's just saying, oh, you're telling it to be 30, so it just knows, okay, I'm seeing a cranking cam pattern. I'm going to output spark here. It doesn't.
I can literally press start in the car, and I can be outside the car. I hit it 3 times, the ignition off, let
Yep.
it go pressure, put ignition on, I won't even be in the car, I press start.
That's all you want. That's good. So that means your throttle blade's good, you get enough cranking fuel, it all adds up and you fire up. That's good. That's all you
Well,
want.
sometimes it'll jump the idle a little out of and drop down just a little, just, well, it does that every time, but just a little real quick and then down.
Yeah, could be a little extra fuel maybe going in there or something at some point. You don't really know. You get when you get in a big injectors like you have, nothing's perfect. You're dealing with small little stuff like this, it's hard to mess it up, you know. So that's my whole thing. I just want to be down in your head is 3,000 RPM, set it and forget it. Okay. And again, you just have to trust, you have to understand that the ECU doesn't know anything about that timing number. It just doesn't. It's depending all on you to set it. Okay. Because unfortunately, like the LS guys, especially, like, oh, I don't even have to check my timing. It just knows where it's at. No, it doesn't. It's depending on knock sensors, right? Because that's why those motors have knock sensors, because it actually will go off with +2, -2 out of the factory. They don't care. They're just depending on the knock sensors to help them if it starts knocking, because the ECU doesn't know either where that motor is. It's depending, it thinks it knows where it's at based on the cranking cam, but it ain't perfect. That's where, especially for you guys making horsepower, you've got to set that so that at 3,000, it's on that number and you're good.
I did. I tried to change it. I try to, because right now I'm on the crank trigger, I'm all the way down. So I try to bring it up a little bit, make it so it's not all the way down on it. So I had some
Correct.
space mess with it, you know what I mean? And then I
Yep.
fired up and it was off. And I didn't reset the computer on it, you know what I mean?
Yep.
To make it equal out to where I set it on the crank trigger.
Have to.
Yeah.
Yeah, you got it. And again, if you have to put a number in there, it's okay. But if you have like some insane huge number like 50 or negative, something's wrong. Something's really wrong. You've got it off a tooth, or there's just something really off at that point.
So every time you put the motor in it,
Absolutely.
if you just leave, like my setting, I leave at 49 and I check the timing at
Gotta check it.
and it's 15, you don't need to change anything.
Mm-mm.
If you backed it down to 45, it would be 11.
Correct.
Read round about.
Anytime motor comes apart, you have to check it. Anytime. I mean, the pros every day, they're checking every run. Stuff can move.
Oh yeah, because they're checking timing change.
Absolutely.
Timing,
Anything can move.
timing,
Anything can move.
something.
Yeah. So typically for us, we put a motor in, we're going to verify it. Yeah. But again, that's my whole thing, is that 3,000 minimum, just to take the amount of time out of it. And below 3,000, we don't care. And even for a street car, it's still good to know, because we know at 3,000, we're still going to have our number. But if we're below that, if we're off a degree or two, it doesn't really matter. It'll still work perfectly fine. We're just trying to make sure we get the latency out of it. We want that. We want to make sure that if the time is going to move a little bit, let it move. Because again, by the time the engine hits the sensor, electronically we get it in the ECU, we got to calculate it. We then got to send the spark out. There's time involved, right? That's the point. That's the point of that number, is saying, okay, what is that delay going to be to adjust? But in our world, you don't need to touch it. Just rev it up, stop it, calibrate it, done. Other manufacturers will really depend on that for whatever reason. What we do, we try to make it as easy as possible. Okay. So I deal with that quite a bit, to where I'll talk with somebody and they just put the motor in and they haven't even done that first step. I said, that's the first step you have to do, is verify the timing, especially with the LS guys. I mean, it'd be amazing to me. They don't even have timing pointers. I'm like, well, how are you going to verify timing? Well, it just knows where it's at. No, it doesn't. But it runs, but it's obviously close, it's okay, but it doesn't mean that it's right, So like, I mean, the factory LSs don't even have timing pointers on them. They just don't. I mean, that motor, I put one on that thing, but they don't even have timing pointers on them because they don't care. So anyways, test timing is the biggest thing here. The other big thing too is, for the coil on plug guys, is this table right here. We have a dwell time table. So if you're running our smart coils, if you're under max power, max power, you can run up to 10 milliseconds if you want under max. You don't really need to be ever. That's a lot of charging power. Okay. But if you're street car stuff, if you're idling, 4 milliseconds is a good number. I'm just giving you some generalities. Okay. 8 milliseconds, still a lot of firepower for 2,000, 2,500 horsepower, but I've got guys making 3,500 plus. And at that point, we crank some dwell on them just to make sure it's going to light off. Okay. So dwell, all we're simply doing is giving the actual coil, we're telling it to be able to charge that coil for X amount of time before it releases the energy. And we'll give you, like, for example, when you get your car running, we'll have a good number for you in there, just for a baseline number. But this is just a general table. Again, once you go in here, you should never have to worry about it. But this is a number to where, you never know. You may have some guy coming in here and doing something, and he may change it, and for better or for worse,
It gets hotter, right?
Oh yeah. Oh yeah. Big time. Yeah. So, and also too, with the smart coils, and I hate to pick on Steve here, but you gotta remember, if you're gonna crank on those things, they gotta have a spark plug on them. You gotta have plugged into something. Poor Steve.
I was like, hey, you dumbass.
Poor Steve. Yeah, he smoked. I mean, I think all of them, right?
Nope, I tested them and 2 of them were bad. So I
Ah.
got some extra.
Yeah, so if you don't have that issue coil grounded, it's gonna charge up with all that energy, but it's gonna melt itself.
That was
So-
a great learning.
Yeah. Well, if you come from distributor, you never think of it, right? Distributors don't do that, you know? Yeah, so you learn somehow, you learn somehow.
Then I'll just turn it, we're good, we're checking things, and also I say, hey.
Yeah,
Oh,
yeah.
oh yeah, I melted the plug right off. I was like,
Yeah, he actually melted it so bad the connector from the wire harness melted too. Yeah, it was a good one. It was a good one. He smoked it good. Yeah, but you'll never do that ever again though. But even with like test modes and stuff, I told these guys same thing. Get that spark plug on the cylinder head or something. If you want to test the coil, that's fine, but you've got to have it on something.
way too much energy to do.
Yeah, it's got to go somewhere. Otherwise, it'll just eat itself up, So again, once you're in this table two, it should be fine. You shouldn't have to worry about it. It's just set it and forget it. And most guys are going to be around 7 to 8 milliseconds up here, 3 to 4 milliseconds around at an idle. You know what I'm saying? So, and again, this table here, this is 20 volts and 8 volts, right? So for this engine out here, I'm literally going to stay right inside here. I'm not moving obviously very much at all, right? So that's all you really got to worry about there. Now, if somebody's running a CDI box or some sort of ignition box, and this table doesn't matter because the CDI box takes care of itself, right? We're not adjusting the dwell on the actual ignition coil. The CDI box takes care of itself. So like a CDI 600, it doesn't care about this. It doesn't matter. It's taking care of its own coil. It's actually, I don't know if you can actually run those not ground either. I don't think you can. I've never actually done that with those. But you can still do all the same testing. You can still hit the test mode, do all that kind of stuff. But this number, you can't overcharge, you can't undercharge because it just runs itself. Okay. But again, our stuff, I mean, there really is no reason to do anything else because we've made over 4,000 of the tire with our coils. $650 set of coils. I mean, you can't beat it. You know what I'm saying? So you just can't beat it at all. So that's all you got to worry about though is just making sure you don't have too much. But anything 8 and under is fine for a limited amount of time under wide open throttle is perfectly fine. That's fine for what you're doing. Perfectly fine. That's perfectly fine. So, that's the 2 big sections inside here. The other one, obviously, again, for a lot of street cars is the idle spark. That's how come you saw the time moving around. I love idle spark. To me, it just works really well. A lot of guys don't, especially race car, you don't have to run it. You can run whatever, lock it out, just keep it that number. It doesn't really matter. But for street car stuff, I love it. I use it all the time. And it just simply just moves spark around to maintain the target RPM of whatever you're looking for. But again, all these different modifiers, if we had the nitrous PWM spark retard on, we've got these generic spark curves, all this stuff can be turned on. And, like for these 2D tables, I can turn on X and Y axis data sources. This is all different stuff. Again, we can cover later on. It's just we don't have time to cover all this stuff. But all these different modifiers can be turned on inside this section. Okay. But all I really care about the most is test timing. Okay. Understanding that. That's going to be the big one. And then like if some guy, unfortunately, if they leave this enabled and they go to make a hit, at 50 pounds of boost, okay, this turns off, I believe, over 3,000 RPM. Oh, I'm sorry. It turns off over 30% TPS because we've got guys that have left this on by accident. Well, what if you got a boost application that doesn't want 30 degrees at whatever boost they're at? Oh, I left it on, you know what I'm saying? So I think over 25% TPS, it just turns off. Okay, but when you're done, obviously, you just want to make sure that you just go back in here and just disable it, and then it's done. That way it's not locked out anymore because it'll stay locked out until you actually disable it. Obviously, it's doing what it's supposed to do.
So with the 3-step and the half-step, so if the, does the half-step make it so the 3-step does not activate?
Yeah, remember, both those are on, the half steps on.
So if I got my two-step and my three-step wired together, same switch, so they're always getting pushed together, right?
Mhm.
So my three-step comes on at 3,000 RPM, my
Mhm.
half-step comes on at 6,000 RPM.
Mhm.
So as long as I'm under 6,000 RPM, my three-step, will work.
Correct. But remember, you have both those inputs on though. It's doing whatever the half step says to do.
But if the half-step if I haven't gotten to 6,000 yet, the half-step's not doing anything yet, right?
Correct.
Okay, but it will trigger the three-step if I'm underneath the half-step, because the half-step's not active.
No, 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 no. Remember, if those two inputs are on, it's only doing the half step. That's correct.
Doesn't matter if the half-step's on yet.
Doesn't matter.
Got it, okay.
It's that 12 volts are on both those pins.
Yeah.
Half step is triggered.
Yeah, even if you're underneath, the RPM is just not doing anything.
Correct.
Got it.
Yeah,
Okay.
exactly. Exactly.
Got it,
Yeah, it's still on.
got it.
Hey, I got a quick question, Ben.
Yes.
Is this the default dwell time table? Or is it
let
something
me
that
look.
Chris did? That's my dwell time table.
Yeah, it's probably something that Chris did. What is it, about 5? Yeah, that's, again, for what you're making horsepower wise, perfectly fine. And it's actually better to run them less. That way you're not running them as hard. As long as you're burning the fuel, that's all we care about.
So this table's fine.
Yeah, if for methanol guys, we'll have to crank more in there because they gotta burn way more fuel. You know what I'm saying? So that's the biggest thing. So for you on gas 85, you can run way less dwell and still burn everything. Okay.
Two-step dwell reduction help.
Yes. Yes, it does. Yeah. And again, that's simply for if you're on a rev limiter and you want to calm it down a little bit, that's what you'll want to do that for. Yeah, exactly. Now, you're running our coils, right?
Yeah.
Yeah, it'll help out a lot. Yeah.
Super smooth.
Yeah,
on the line.
exactly. It'll calm it down quite a bit. Don't take it down to nothing. Because then you'll just not have enough firepower. You know what I'm saying? But yeah, just take it down a millisecond, maybe 2, and just see what happens. You'll see it calm down for real because it's just all it's doing is taking the spark energy. If it's this much, just chopping it down. You're still sparking exact same time. You're still at the same timing. It's just reducing the ignition charge. Yeah. All right. So basically what we're going to do right now is, so we've got the O2 sensors on. We're going to crank it up, and now we're going to watch to see exactly what they do during cranking. Okay. So heater startup mode is good. I know. Sorry. Just leave it open.
Thank you.
Yeah. All right. So let's see what the old O2s do. And now that they're actually on and running, and we'll see how lean, fat, whatever they do. So we'll look for engine RPM. We'll hear it, obviously. There it goes. Perfect. So about 10. There it was. So that's how you know it's somewhat close. Okay, now we're clearing out, and we're gonna start leaning out. Okay, but that's where you should be on startup. You shouldn't be anywhere like around 13, 14, 15 to 1. That's just too lean. Okay. So when it fired off, you saw some 9s and 10s there real quick, but it cleared out real quick and then it went right up. So that's how the startup mode works. Okay. So very simple. So we're going to breeze through the individuals real quick. But again, for your race car guys, it's definitely good to know what all the individuals are set for. And what's really nice is if you come over to tuning and dyno views, they're actually grouped together. So you'll see here that 1, 3, 5, 7 are grouped together. 2, 4, 6, 8 are grouped together for a Chevy guy. Okay. Yeah, this is tuning and dyno views up here. And then all the individuals are just put together. Okay. So, go ahead, Steve.
Mine just goes to one screen on tuning and dyno.
Yeah. So down here are all the tables themselves.
Okay.
Yeah. So you're picking all those down there. Okay. So again, this is where you're going to edit and do anything individual. Typically a good ballpark of just when you're doing individuals is wherever the air is coming from, especially if you're boosted. If the air is coming from the front to the back, you usually want to add a little bit of fuel, take some spark out in the rear. If you've got a rear entry manifold and the air is coming in from the rear to the front, same thing. You'll add a little bit of fuel to the front because the air is going to go where the air wants to go, right? And those cylinders usually do more of the heavy lifting than others. So if you don't have any idea where to start from, just look at the motor and how it's actually laid out and work with it there. You know what I'm saying? As far as adding some fuel, taking some timing out. Okay. But this is all the individuals here. You got 2 for fuel and you got 2 for spark. So this is 1, 3, 5, 7 here. This is 2, 4, 6, 8. Okay. So again, you can fine tune these guys as much as you want. All right. Spark obviously is over here. Same thing for the spark. Okay. And the ellipse obviously is going to sit wherever you're at. So remember, these tables are always on too. Okay. So just something to know is that these tables are always hot. They're always going. All right. One thing we didn't look at is before we were on all 8, each individual closed loop. Now we're just back on the duals. So beyond on the dual sensor, we're within 0%, 1%. And then on the left bank, we're within 1% or so. Okay. So that's how you guys are. Dana, you're not, you're on the 802s. But for the bank to bank guys, so what we're doing is right now, we're fine tuning every one of these holes is getting that correction. Okay, so just remember that if you're on the bank to bank, if you're choosing a Chevy, you're on a Ford, we are correcting 0.2% all those holes.
Because you're close to.
Correct, exactly. Okay.
Do you have a target airflow ratio per cylinder anywhere?
Yeah, that's if you do the 802 setup,
Yeah.
you can actually offset each cylinder to be whatever target you want.
Okay.
Yeah. So for the cylinders that are doing heavy lifting, let's just say instead of it being 12.5, you want it to be 12.0. Right? If there are some cylinders that are always fat, you can make that one 13.0.
So the IFC tables override the BE table.
The individual fuel tables, yeah,
Target air fuel table.
it's not the target air fuel ratio. Well, yes. So in the individual, right here is a target O2 table. Okay, so you can per cylinder, if you're running an O2 sensor per cylinder, you can offset that target per cylinder.
So
If you're
you
running an
build
O2.
that
It'll offset it. So for example, okay, right here at this moment in time at 5067 and -4 inches, we're targeting 13.0. Well, you can actually build an offset per cylinder if you have the 802 configuration. You can actually go over here.
What do you mean by the 802?
So we have the O2 sensor per cylinder, like Dana's factory stock showdown stuff.
Yeah.
They have an O2 sensor per hole.
Right.
That's how we were in closed loop before on the engine.
Okay.
So they can actually plug in a target AFR offset.
Okay.
So they can run, if they know certain cylinders are doing more work, they can target down and be a little richer. Now that's in real time in closed loop, it'll correct per that actual target now. That's how that works. Yes.
Can you force an engine without the 802 sensors to put more fuel in, or?
Yeah, that's exactly what this table is.
But then if you run closed loop, will it keep the difference? I don't know. I'll let you talk.
Yeah, no. So what you're saying is if we're on this table, okay, so if we're on 1357, okay, and let's just say, so right now, let's go here. Okay, so if I'm on 1357 and obviously I'm in closed loop right now, right?
Yeah.
So if I was to plus 10 in this, okay, let's just add 10% more in that hole, okay? So now I just added 10% to cylinder number 1. Look at that. So now I'm starting to pull fuel out, right? Because I'm pouring fuel in that. It's taking out fuel everywhere on that bank.
Okay. Equally.
So
So it won't try and take more fuel out of that one that you told us with more fuel in.
No, I'm still adding 10% in that hole.
Yeah.
Now it just took out 2% to get me back to where I need to be. But I'm still adding 10% in that hole. Exactly.
Yeah. Got it.
Exactly.
So what's the difference between doing it this way and doing that other map?
Individual.
And this is individual.
This is individual. This is completely individual. So right now I just added 10% to cylinder 1. Now if I was to rev it up, I'd have no correction here.
Right.
So this is just right here at this moment in time.
So that's how you modify every cylinder. Get it.
Correct. So we're looking at the base fuel table. We go to the individuals and it says, oh, I also need to be adding 10% here. So this becomes a foundational value on top of the base fuel table.
But now is your correction table trying to correct this?
No, because remember, we're in the bank to bank mode now. So right now I'm correcting per bank.
Per cylinder. This is individual cylinder. too.
So if you had
Yep.
O2 sensors,
Well, you're
Mhm.
seeing it on the
10%
map,
more
it
in
would override
cylinder
that.
one.
Yep.
Yeah.
You would
I
add
think if you
10%
burn it,
in
it
this,
would override it.
and
I think
on your
that's what
target
you have.
air
If you
fuel
burn it, once you
ratio,
set it,
add
you burn
10%
it,
to
then
that,
it'll
and then the
graph.
closed
If you
loop-
wanted to.
Yeah, and so they have run closed loop, so
I
that
think
way,
it does, but what
it would-
does
the
is
closed
it
loop
does
correction will be
10%
less.
Yes.
but it would still be 10% more than the rest of the cylinder.
Exactly. So that's where, like Dana, for example, I'll show you some logs. When you're making a pull with the 802 deals, right? It's going to sweep through here, okay? And it'll show you on the log what it's doing correction-wise to get you there. So then theoretically, you'd add a very similar amount of correction, whether negative or positive, whatever, throughout the RPM range, so that the next time you make a pull, it's doing very little correction. Because mechanically, the sensor's telling you what the motor wants on that hole throughout the RPM range. So you then take that and you convert it and just say, okay, I'm going to fill in these boxes now with what the closed loop correction on that hole's doing, right? That's how we can cal a motor so fast, right? Because the correction tells you what to do in that hole.
And then you just change it over to what the correction is.
Exactly. So then once we plugged in the correction, okay, maybe adding 5 here and taking 10% out as we lean out or whatever, as we rev past peak torque, okay. Well, now the correction should be much less because you're already putting it in with this base table now. You see what I'm saying?
The correction you're only getting in closed loop. You have to be in closed loop to get the correction.
That's correct.
So
That's
you
correct.
basically
And you
trying
can
to-
run closed loop, idle.
Whenever you want,
full run.
whenever you want. Yep.
So you'll go through, you'll make your run, you'll look at you'll pull that graph, and then it's like, okay, these are where the numbers need to be plugged in.
Yep.
And then assuming that you're at the same altitude, same air density, same water.
Fuel
range,
pressure, injector flow.
it should theoretically be real close to
Exactly.
perfect.
Exactly.
And that info comes from graphing and logging.
Yeah. When you make a pull, you know, you just, so again,
You
if I-
record and then you replug it and then click on the bottom line, so to speak.
yep. So again, if you just press start here, okay, so the log will just start. And then now everything that's actually happening, obviously in real time is showing up here. So you'll see that all your values are moving. There's your spark advance number. There's obviously the injector gross pulse width number. It'll show you the corrections that's going on. You know, so you can just do a regular log on your laptop. You can record it to the SD card. You know, it just totally depends on however you want to do it. So right there, O2 correction left bank's pulling 1.6. We're adding 2.4. The left bank's where I added that 10% fuel, right? Okay. So right now we were very close, around 0% with the right bank. But what's probably happening is right now the air temperature sensor is probably getting a little warm because we're cooking. So naturally the VE calculation is, oh, I'm getting a little warmer, right? The air density is getting less. I'm pulling a little bit of fuel out, but the correction's saying, oh, now we're getting a little lean. I'm adding it back in. You see how that works? The VE calculation's always running, okay? So it's just doing its job. Now, if I was to come over here to, back to that individual tuning tab here and make this 0. Okay, make this 0. Okay, so now, here we go. Now it takes away, now we're actually getting pretty close to matching up with the other bank. Okay, but I'm only affecting that one cylinder though. Remember that. But it can still pull and close loop correction that entire bank.
If you're an active car, you lift the ring lance, it's running a little different than the cylinder. You come over here and clean it up real quick a little bit and run another pass in.
Yeah, that's where it's tough to tell people how fast I can cal a motor, because literally on the first sweep, like with Dana's motor, for example, once you make that pull and the closed loop correction per hole just throughout the RPM range tells you what it wants correction wise, you're good. Because if you just have an O2 and you're just tracking it per hole, okay, well now I got to figure, okay, I was targeting 12.5, I had 12.0, okay, but it's not giving you a percentage of what to do. It's telling you exactly what to do. So
my EGT does it, but not to that table.
EGTs really are more for just safety, to give you an idea where you are. It's just temperature. It's just temperature. They are a necessity, but they're not a good tuning tool like this.
So if one cylinder like constantly ran hotter than the rest, wouldn't want to use this to add fuel to that?
Oh yeah, absolutely. Yeah, that's the thing. Now, what's the reason why it's hotter though? Is it doing more work?
Right.
Right? Is it retarded on timing in that hole? I mean, there's a reason why it's making heat, right?
Yeah.
You know what I'm saying? So what is it? So yeah, if you just want to add some fuel to it and that calms it down, okay. You know what I'm saying? Because again, the intake manifold thing and the camshaft, the mechanical aspect of the engine is so weird. It's gonna pull wherever it wants to pull from. You know what I'm saying? So you never know. A lot of cylinders rob fuel from other holes and stuff. You know, it's just the way engines work. And this gets you again, I hate to keep going back to it, but when you have the data of having the holes, you know, all this data staring at you, you literally just figure it out so quick because now you can tell exactly what's happening.
Yeah, which one's cool?
Yeah, I mean, it's just your answers come just so fast, you know, because it just tells you exactly what's going on per hole. So it's like a cheat code, honestly. Because once you do it, it's like, oh, okay, and just plot a curve, and then that's the thing is more like on the dyno when I do this, it's not as good. You got the tracks where you want to do it because the track when you're banging gears, all this changes. Mechanical load of the gear will change the air-fuel ratio like you wouldn't believe. So that's why you can actually set up per gear individual fuel and spark tables. So like for our racer cars, like for Dana's type of combinations, I'll have a gear for every gear. I'll actually have individual fuel and spark tables per gear. It actually is that different mechanically with that gear leverage on it. It's
I
incredible.
mean, like when he dumps into higher gear on the big end, then he's gonna have a different fuel map on it.
Yep. Yep, exactly. And you'll have different individual fuel tables on it as well.
Lean out on the big end and make it real fast.
Rich. Rich ended up.
We're gonna have the gear table for first gear, second gear, and third
Don't
gear.
do me any bad.
Yeah, you can get after it. You can get after it first and second gear because you got the mechanical leverage to keep the motor happy. You jump it into high gear, now you gotta, you gotta take care of the old girl. You gotta give her some love. That's where you gotta make sure you got the fuel, you got the spark, because that's where the load's gonna come in. That's it.
That's why everybody hurts. On the big end.
One of the reasons, yeah, definitely one of the reasons. But you just want to make sure that if you're going to do the map per gear, that's the thing is we'll go over here shortly with the G meter, and the way the G meter just basically tells you what to do. It tells you, hey, I can get after it harder, or I'm spinning the tire, it's falling off soon. Is you know, why is my G meter falling off? I'm pulling too much retard on the traction control, all that type of stuff, you know. But you can literally get after it though harder in mechanically with the leverage because the gear is helping you. Especially with big tire cars, they can use a lot.
Okay.
Yeah. So it's
What about, not to like get all off point, but for, how do you look at like the nitrous and like a lot of times you'll have, you know, a 36 jet, a 34 jet, or a 35 jet. How do you determine what cylinder is going to get what jet, or do you just keep it across the board and then?
as far as running the nitrous per hole with these, they're going to tell you what the nitrous is doing per hole air-fuel ratio wise. So if you got too much jet and you're really lean on that bank, you want to take some out, put a smaller jet in, or you can add more fuel based on the individuals in that hole to bring it up.
Question right there.
Exactly.
So you can either pull some jet out of it or you can richen it up.
Exactly. Yeah. And you'll have full control over that hole individually wise with this. Same with the spark.
Okay.
Same with the spark. So that's the biggest thing is to give you that, you know, that adjustability per hole.
Is that because each cylinder and the intake runs a little bit different? So
Absolutely.
Like nitrous, it makes it a little bit different each cylinder.
Yeah, you know, you're spraying all that nitrous. Basically, it just goes in the manifold. It's just a suspension.
Yeah.
It's just sitting there. It's okay. So the intake valve opens up and it's going to pull on it. Well, everything's just basically suspended in air in the manifold. It's going to pull in whatever fuel and nitrous is there, right? And every manifold cam is going to work different on the engine. So when this tells you, hey, I'm at 14.0 in this hole, you know, okay, well, individually wise, I'm going to attack some fuel, maybe also take some jet out of that side also as well, you know, because that side also is probably doing more heavy lifting than others because you're going to have some other holes at 11.0, I guarantee it. There's holes that are doing less work than others. The ones that are running lean, you're probably going to be doing the most work on those because those are requiring the most fuel to be happy. And that'll tell you that. When we work with a guy by the name of Dan Cordier, he does all the individual cylinder pressure monitoring, and you wouldn't believe the world that opens up when you start doing that because you literally see the pressure curve and it literally tells you what cylinders are doing the heavy lifting because you actually see the pressure wave and it says, hey, here's the sex cylinder. I mean, literally there's no guesswork at all because the pressure wave will tell you, okay, here's how much, they actually can calculate how much horsepower each cylinder is making based on the pressure wave that they're actually seeing. It's ridiculous. So we've done a few projects with him and he's incredible because now we can literally per gear map, not the fuel, but the spark because we're seeing real-time detonation with his sensors. So when the piston's coming up, you can actually see, you'd be amazed how much knock you actually see. Even with motors, how are we knocking there? And you're knocking, like you're literally, but you can't tell, but motors will get hurt after a while. And then it finally raises it, oh, that's why we're hurting it. You know, we have a big block Chevy that a project we were working on last time, and big block Chevy, for whatever reason, it needed 9 degrees out of one hole. 9 freaking degrees on the big block Chevy. It was 36 was total. It ended up needing only, 27, 28. That was it. But why? That cylinder was doing the heavy lifting, and nobody knew. They kept hurting it. As soon as we saw it, like one of the first pulls, oh, there it is. We just saw it. So we came in here individual wise, pulled all the spark out, ran killer. You actually hear the pitch of the motor change when you set up all the individuals right, spark wise, because the motor is just so balanced. It's ridiculous.
You think that'll come down in price?
The 802s. But you can only do that with the 802s.
It's expensive. How much is it?
Yeah.
Sensors are like $6,000 a piece, aren't they?
Yeah, I know it's an investment if you buy them, but there are teams that will hire people to come in with their equipment and run the processes to do it, and you can basically rent as a service. So you're not having to buy it, but if you have the bucks,
Drill the heads.
yeah. But like on your motors, for example, the Coyotes, they got the DI, got a DI hole. You can just drill and tap that as your actual pressure input. But small block, Chevy, Hemi, anything that was never meant to actually have a hole in it, then yeah, you got to drill and tap the heads. But it's ridiculous though, the data that you can get out and actually, learn, because it's incredible how much information. So yeah, you want to talk about cheat code with the air fuel ratio per cylinder, you see this, then you couple that, because his is the spark. That's the biggest thing is, yeah, we can fine tune the fuel mixture per hole, but you don't necessarily know spark wise, where's the optimum spark, right? Because about 10 degrees after TDC is where almost every engine wants to actually fire at, right? So we're hitting, right now at 20 degrees. Well, theoretically, we should actually be lighting off around 9 or 10 after. Well, again, we don't necessarily know. We're looking at a time mark on a plug, but sometimes that doesn't necessarily mean anything, right? So that will literally, you cannot lie. There's no lying when you're looking at that data. It's incredible. You'll see the jaggedness. You'll see the actual pressure wave go, I don't like this. And then
I didn't do it to mine.
yeah, and then instantly you'll know, wow. So you'll just take it out and just take off, and there you go. It's incredible. So, but yeah, I just wanted to show on how the banks work. Maybe we can just do something here real quick. So over here, we've got the Chevy, the individual EGTs here, okay? So right now we're reading all the EGTs right here all at once. So if I was to come over, and let's just say we're hurt. So let's come over to fuel modifiers. Okay, EGT add fuel correction is enabled. I'm not going to press burn. If I forget about it, I'm going to keep going. So don't worry about that. So go over here. Let's go to the configuration.
6, that one you added the 10% fuel to? Did you take that back out?
It was 1 and I took it back out. All of them should be 0. So let's just say I'm going to add fuel if I'm over 500. Okay, and I'm going to add 10%. Okay. All right, I'm going to burn that. So now, number 5. Okay, I should have just triggered number 5. So let's just see if we actually are on. Oh, am I on Dyno mode or street mode? I forget. Let's go back and look. Here. No, I was in race mode. Let's do Dyno mode. Oh, there it goes. Just shut it off. So we triggered. Okay, and that's how it works. Okay, so it said, I don't like it, and I just shut the engine down. So if I come over here, save that. Come back in the log right here. Basically, I was rolling along. I hit the safety. Let's see here. Go up a little bit. Right there, EGT shutdown is active. Boom. So that's just an example of actually how it works. It didn't like it, so I actually shut that cylinder off, and the motor basically makes no power, so I couldn't even just run on the other cylinders. But that's exactly what it'll do. Yeah, exactly. So it basically said, nope, I'm done. And then it just shut itself off. But the flag will come on. It'll tell you why. You know what I'm saying? So at least you'll understand, okay. And it should have, let's see if we can see if it added the fuel. Let's see here. So I'm going to zoom in. So right here, the logger, guys, also, we don't have time to go over all this, but inside this wheel is where it has all your data logging stuff. And inside this question mark is where it'll tell you, you know, page up, page down, arrow up, arrow down, right here, rescale, graph, zoom in, zoom out. That's all your little shortcuts here for the logger, okay? So,
What happens if you get a red question mark, like by your AFR or your boost or something, up there on the top bar? You know, it says default AFR boost chassis, EGT, fuel flow. What happens if you get like a little red question mark up there?
there shouldn't be red question marks. That could be something it's seeing that it doesn't like potentially. But you'd have to, I'm not sure exactly what you mean. You'd have to send me a picture of that. I'm not sure about that. So I'd have to see that. So yeah, so let me go over here. Now, what I want to show you here too is rev limiter. If I right click over any of these, okay, so right now the system always defaults to one open window, okay? So right now we're just looking at one window. If I was to come here and start splitting it up into different screens, okay, so I'm going to right click over this rev limiter, right click, send to graph 2. Okay, so now I'm going to open up a second graph. Okay, and so now I'm going to populate this. So now I've got this data up here and then I've got this here. So I can start opening up different windows. So instead of having everything just clobber together all at once here, you can start opening up different viewing panes here. Okay, so you can see right here the rev limiter went active. Okay, so if a rev limiter turns on, do you guys remember what we're actually adjusting? It starts with an E. Remember that by any chance? We're actually adjusting. ETM. Yep, exactly. So if I come over here to the engine torque stage and I come over here to number 2, and let's just make this orange, okay? You'll see right there, it went to a 20, okay? Because that's what it's programmed to do, okay? So, and if I came back over here to this AFR parameters, it was right there, okay? So hit it, boom, shut off, okay, bye. And so it did its job. Now again, this motor at 20 can't even stay running. It's just, now if we're wide open throttle, I can guarantee it would be fine at 20. It'd be going, brrr, but that's wide open throttle. You know what I'm saying? And that's typically when you'll have these safeties in place, not idling. You know what I'm saying? That's why, like in the dyno mode, for example, if you were always on and you triggered it, right, it shut off. We don't want that. Okay. So that's just an example of how that works. Okay. The flag turns on, rev limiter turns on. You go from 31, right, which is full power. You go down to 20. So all your flags for that kind of stuff are all going to be right over here on this left-hand side. So basically all your inputs, your outputs, all right here, your warnings, your AFR safeties, EGT shutdown, all these different flags are all listed over here on this side. Okay, that's how that works.
How can you remove the NOS and the NOS from the top row? I know how to remove everything you're not using from the center row to clean it up. But like that NOS, I never use. It'd be nice if I could get rid of it.
Yeah, those are actually part of the default.
Okay, so you can't remove those.
Correct.
You can adjust your bottom, clean the bottom up to just 4 and get rid of all the Chevy stuff.
Yeah, there's a way. You got to go inside the actual data folder of the project itself. Yeah, but I would just leave it there. There isn't a clean way to get rid of those. So you just wouldn't use them.
And can you can you show us how to right click to graph 2 again?
Yeah. So
I only have graph 1.
exactly. So let's just say I want to look at pressure boost. Okay, for number 3, I come over the word and I just right click over the word, and then let's just say send to graph 3, and I just pick a color. Okay, I'll just pick peach. Okay, now it builds out graph number 3.
Maybe we have to update.
No, it should. It should. So if you right click over the word, it doesn't say send to graph, whatever.
We only have a send to graph 1.
Oh, are you guys do you guys have a full version by any chance?
I go to graph, it just was the BigStuff Gen4.
Okay, let's just look real quick. So, excuse me. So, oh, okay. So let me see here. Yeah, see, it's that because that's available with the full version. See how it says update registration?
Okay.
Well, hold on a second here. Oh, you know what it is probably? No, you have a full version. You probably just don't have the most recent version.
Oh, okay.
Yeah, so because
we're run the update.
yeah, so I don't know if you're on our Wi-Fi or not, but if you do that, just check for update, and then you'll have that.
Right here, and I got full version.
Yeah, you just have to open a data log though. You got to go over here and
Oh,
then
okay,
just
so we're
choose a
gonna go-
log, and now you'll have all your stuff open here.
Okay. that's
Exactly.
fine. Okay.
Yep, exactly.
Yeah.
Yeah, just update the software first, and then you should be able to see it.
That exclamation mark shows up if you like add something and then click over to a new tab, because you haven't saved it.
Okay. Oh, okay. So yeah, so if you've made an entry, and then it's probably
Yeah, go like a preset tab,
okay.
just click anything down below, click anything.
Okay.
So much.
Then switch the tab.
Okay.
Something else.
Oh yeah.
Engine
Okay,
management,
so
like you said.
Dane, are you talking about this right here, this exclamation point here? Is that what you're talking about right there, up there? It's the low. Okay, so what that is doing, Chris made a good point. All I did was I added something to this other than the default value. So it's just letting you know, hey, you've added a value to this data log. You're gonna want to save it when you exit or not. That's all that is. So I just simply added one. So like for the NOS, if I add this gear, okay, if I added this value here and then I go to the NOS program,
Oh.
see it pops up.
Okay.
So it's just saying, hey, you've added a value to the factory tab. Do you want to keep it or not? And you'll just say yes or no when you exit. That's all that is. Okay. All right, let me go back out there. And so I'm going to want to turn all this crap off. So I'm going to go to AFR, UGT configuration. Okay, so you see right here, the misfire. So here's a good example of just kind of blubbering up, by accident here. So I wanted to actually add fuel first. Well, when I set this to 500, the misfire went right to 300 because we activated on this. So remember, the procedure is I do this first. If that doesn't work, then I go here. But because I triggered this, it went right to that, and 300 was the misfire. So that's why I turned on the ETM and it killed the engine. I should have set this for maybe, like a 900 or something, had her rev it up, and then I would have triggered that. You know what I'm saying? So because it went right to 20 because we hit that, well, this was actually lower than that, and it just said I'm done. Okay. So, but this is an example of how it actually works. Okay. So I'll put this back to 1,000 race mode.
But race mode and run mode, right?
Race mode means that it only will run on the race timer. So idling, everything else, they don't care. Once the race timer starts, which we're going to talk about, that's the SR2 timer, then it'll actually look at this table. And then also it's going to wait this much time before it actually looks at it. So in this case, 2 seconds, right? You ain't going to burn it up 2 seconds before unless you got something really bad going on. So give it a little bit of time to get out there and then start looking at the table. That's how that works. Okay. So we'll turn that off. And then just to kind of clean things up a bit, we can come over here and just turn it off here like that. Okay. And we should be good there. Alex, you over there? You just go fire it up again for me. So you guys are pretty clear though on the individuals. Again, this is always going to work. This table is always going to be on. Alex, do me a favor. Turn off the ignition for about 10 seconds and then fire it back up. Just as I made all those changes. It never hurts to turn off the ignition and turn it back on. It's just what I just recommend doing is turning it off. Wait until your laptop obviously goes offline. That actually means the ECU actually shut down. Just a good idea every once in a while to do that and then fire it back up. Okay. But you guys are all clear on the individual tables, how these work. Okay. Makes sense. Just know they're always on for the most part, unless you're doing something to where you've got multiple maps, everything else, they're always going to be on. And you got to configure the accesses and stuff too. Okay. Just don't take any of this stuff for granted that it's going to work out of the box. Please don't. Because these are just factory cows. We don't know what you're trying to do. Okay. All right. So now we're running again. Okay. So, let's go back over here. Okay. So I think we're going to get into some fun stuff now, which is the traction control stuff. Once we're actually talking about the traction control, there's 2 different things that we can do here. Okay. Under the SR2 section. So SR2, okay, ETM. Obviously, you guys know what ETM stands for. SR2 in our world just refers to ignition timing. Okay, so if you were just you wanted to do stuff with ignition timing, it'll be the SR2 part. If you're going to start doing stuff with ETM, that means we're cutting ignition. That's the old 31 is full power. And as you start taking that number down, we start cutting the ignition. Okay. Now, if you don't want to ride any curves or anything as far as a dry shaft plot, engine RPM plot, most guys will just simply run a gear curve to leave. And the way you choose these curves is right here, for example, this is on curve number 1, okay? Now, if you guys are running one of our touchscreen dashes, do not listen to that. You guys have to remember, if you're running one of our touchscreen dashes, this number does not apply to you. The dash wins, okay? So you have to remember that. We have guys that'll make all these changes, all this stuff, right? And they'll say, oh, I want to do curve number 3. Well, they didn't touch the dash. Whatever's in the dash is what the ECU listens to.
I got 3 programs you put in for power rating.
Correct. So if the dash is plugged in, the dash wins. So that's how it works.
What did you give, you said?
Engine torque management. Okay. So you have to just remember that because, you know, unfortunately, if you don't change in the dash, it doesn't matter. It's going to be listening to that. And if you change it here, it doesn't matter. It's whatever the dash is calling for. Okay. Just got to remember that. In the SR2 section here, okay, you have a minimum TPS and a minimum RPM. This always works off the release of the 3-step. So your race timer will never start unless the 3-step has been released over these parameters. Okay, so you go above 2% here, you go above 1500, you hold the 3-step, you release, it's running. Okay, so whatever you guys have parameters wise here is how if you don't meet them, or if you're on the 2-step, it's never going to start. Okay. So we just want to make sure that we're actually on the 3-step. These are met, because if they're not met, your race timer is not going to start. Oh, Alex, I think we're running out of fuel again. 10% right there. It's getting there. Thank you. You can turn it off, Alex. Alex, just go and just turn it off for now, fill it up for gas, and we'll fire back up in a few minutes, okay? So, so again, it's funny. Every once in a while, this will happen to where the race timer doesn't start, and they never met this criteria for just for example. Okay. So what I recommend to most guys is if you go to your rev limiters, okay. Let's just talk about this. So we're going to keep SR2 up. We're going to go to our rev limiters. Okay. This is the one we care about, 3-step, right? We care about this one. So what I recommend doing is when you're leaving on that, set this to around, 2,500 and maybe 50% or something. And then, because we have to be above this value. Okay. So we got to be above this. So obviously if I'm leaving at 4,500 RPM or 4,000 RPM or whatever, I'm going to be way over the 2,500. Okay. That's going to clear it. So as soon as you release the 3-step, boom, we drop, the race timer starts. Okay. So everything in our world is based on that race timer going. So when the race timer starts, now anything that you've built to run off of it is going to work. So our boost controller, obviously the power management here, this right here, this gear curve, okay? These are the 9 different curves that you can work from for Spark Advance. You can see here that I can either take power out or I can add power in. Okay, big tire cars, a lot of times will actually shove power in. You gotta get the wheel speed up, right? It wants it. Small tire cars, for the most part, we'll just pull power out and then ramp it back in, okay? But these axes can be...
Put the donkey in it?
Whatever you want to do.
Take timing out at like 0.9, 1 second, pop back in at 1.4 and head out.
That's it. And you'll see here that every one of these curves, again, this is just an example, but number 1 is just pulling 2 degrees out everywhere, right? Okay, 4, 6 out. Each spark curve takes out more as you go down. So you can build all 9 individually however you want. All right. You can change that time axis as well. So right now it's set for 10 seconds. Okay, if you wanted to make that 5, make it 5. Right? So if I come over here and I made that 5, well, now I got something really bad here because I'm up to 9.6. Now I'm 5 here, right? So highlight, interpolate this guy. I just highlighted the row and I right click, okay? Come on. Highlight the row. Sorry, you don't right click. Come over here and hit that button. I don't know why that's funny. The squiggly line's not there. should be there.
Like, see, sometimes we pull timing to square the tire back out, you know, after we take off, we square it, we launch it so hard on the small tire, it actually brims it, you know, puts it on the rim almost, even at 12, 13.
Yeah.
But then we'll donkey it, take 2, 3 days out at like 09,
Yep.
1, and then bring it at 1.4, put, you know, right back in and then go from there.
Right. And
Get
then,
it to where it's square, that's the tire and go back normal again.
right. And the way that this curve works is it works off of whatever the spark table is calling for. Okay. So let's just say, for example, the spark table is 30 degrees everywhere, right? Because in our table up here under wide open throttle, we're 30 degrees, right? Well, it's going to work with that 30 to pull the timing out. This is a retard. Okay. So here's our base timing table. So whatever is in the base timing table is what this is going to apply. Okay. Now, this is where you kind of don't want to get too lost in the weeds, but if you're doing a dry shaft plot, if you're actually underneath the dry shaft plot, you could actually shove timing in. So you could have a first gear curve that's actually pulling power out. You could have a traction control serve that says, oh, I'm not at my target, I'm going to add power in. So everything is all maneuvering together, right, to end up at the ultimate timing number that you're going to be at. All right. And that's where you got to kind of keep track of everything that's going on. In the logger, it'll show you all the different ways it's pulling timing. You just have to remember everything that you're doing to actually, you know, work with that spark number itself. Okay. But this is what most guys will typically do here, is at least just do some sort of leaving curve of some sort, you know, and they'll just come out and again.
So if I burn it and then I go back and if it work on me, I can go back in and throw in the one before I burned right back in.
Yeah. If you load that calibration back in, yeah. Absolutely.
So I got to burn it to do it every time.
Every time.
Okay.
Yeah. And this is where I recommend, again, if it's always advisable to save the entire calibration, right? If I do a file and I do a save as, okay, if I save the entire calibration, or if you just simply save this window, you can now just use this window and just use this as your power management without having to load an entire calibration every time. Because you have to remember, you may have altered the fuel table, the spark table, maybe the boost controller. You may have done some other stuff in the entire cal. You're loading it in to basically take care of this, right? So you have to be very good notes-wise as far as, okay, I'm loading in a calibration from 3 weeks ago. Well, maybe you've trimmed some other stuff up since then, but all you wanted out of it was this curve. Okay, so just be cognizant of that, because that happens a lot. I work with a lot of guys and oh man, actually I took some timing out of the base table there. I had adjusted my fuel table. I had done some work with the boost controller. Well, he wiped all that out when he loaded it in older cal. Gotta remember that. Gotta remember that. Okay. So if you don't want to deal with that, I could just say I'm gonna just save this table. I can just go file and save. Now I can just, it's called an SR2 gear curves dialog. So I can just save this one table, right? And let's just say I want to call this, I'm going to call this Verona for whatever reason. I'm just calling it Verona. So then we call this here. This is what I want to use at Verona. Okay. So now I have a table that I've just saved. And now I can just load in that table into here if I want. And I won't affect anything else in the entire calibration.
That'll be the traction control for Verona.
It's yes, but it's just this window.
Just that window. Now, can you, if on that base right there, can you go back into it though and adjust on that and then lock it back in what you adjusted?
Sure.
So you go back into that program and adjust again.
Yeah.
Okay, gotcha.
Yeah,
You
it's.
you just gotta go to that
I,
race.
I just saved this window as Verona.
Okay.
Now I can start editing again, and I can save it as Verona 2.
Okay. So you keep the 1, see, make it 2, see if 2 works. If it don't, go back to 1.
Absolutely.
Gotcha.
Yeah, and that's the thing is if you remember to just save this table, you're not taking a chance of loading an older calibration where you've touched other stuff.
You just have to name it with and then write it down to make sure you don't screw it.
Yeah, so if I was to come over here, right? If I was to go file and go load, okay, it's an empty file name. So you don't know what it's called. But as a quick example, oh shoot, what's this thing called? Okay, if I go file and I go save, it tells you what this thing is called.
Gotcha.
Don't save it. Okay, I got to go look for SR2 Gear 1 Curves dialog. I got to look for that, right? But oh yeah, that's right. It was called Verona. So if I go file, load dialog, I'll open this up.
Well, if you're gonna save quite a few of these files, or you can just make your own folder.
Yeah,
Only save the SR2 curve.
absolutely.
In that folder, and then you have all your different curves.
Yeah, I mean, I got guys coming up to
Nothing else.
Yes, I have guys that I come off the dyno and I teach them. I say, do not touch anything inside this calibration. Just touch this table and that's it. This way, don't screw anything up that the engine guy's done on the dyno and everything that they've been tuned on. Because these guys will just go through, and unfortunately, they won't take it. They won't keep good notes, and they're loading in a cal that has a bunch of other stuff touched, and they really just care about this. So it's a clean way, like Chris said, if you keep track of, if you created a file folder, just create it called my gear curve folder. Now you can just simply just load in that table. And if you don't feel very confident per se as far as what you're doing inside here, if you learn to just say, okay, I'm just going to work with this one table, this way you're not affecting the fuel table, the spark table, you're not affecting anything else. All you're simply just loading in is these curves, and that's it. So you can't mess with the air-fuel ratio, the fuel tune-up, the spark, the crank reference angle, all that stuff. That all stays, you know? So it's a good way if you just want to simply focus, because this is what, you know, we're simply going to use this for the most part, and maybe we're going to change rev limiters if you're a drag race guy. These are going to be the two tables you're going to mess with the most. Everything else, the most part, once it's done, right? So if you don't keep track of it, though, maybe you had taken 10% fuel out up top. Maybe you had added a couple degrees timing in certain parts of the map. But if you didn't know that when you loaded it in the old cal, you're back to where it was before. You see what I'm saying? So it's your comfort level of what you want to do. And again, you don't hurt anything if you just go file, okay, save, and just save it as its own window. You can't hurt anything at all. And you can actually load this in while the engine's running too. It'll take it, write it, and then update, and you're good to go.
So those full lines are 4.85 seconds.
This is up to 5. So I changed it. This was 10, and I made it 5. So now instead of going out to 10 seconds, now we're just going out to 5. Yeah, so we just interpolated, okay? So again, all these different curves and tables can be edited and changed, you know, however you want. You know, for example, if I don't want to take anything out at 1/10 of a second, I can make that 0. And then if I want to make this, you know, if I want to edit this curve and say, okay, for the first second, I'm going to hold out 10. So equal to -10. Okay, now I'm 10 out, and then I'm going to interpolate everything back within, let's just say, 2 seconds. I don't know why my little slash isn't there, but if you hover over it, it'll say it. Okay, so now now everything's back, and then if I zeroed, come over here and equal 0 and make that 0. So now all the power's back in, right? So if I highlight it, you'll actually see it, even though it's kind of a little bit tough to see. If I highlight those, see those red right here? That's actually, but it's buried underneath the other dots. So what I can do is I can highlight everything else in here. Again, this is just example stuff. Equal to 0. Okay, and now I can see my curve pretty clean.
That's about.
Okay, so just zero everything out.
Okay.
I've got guys that literally just use one curve the entire time. They only just edit this one line.
How do I put it in, and how do I set it in then? Do you save it then? Just press save and it'll go in, and then it'll run it?
So right now everything's offline, right? So I'm editing an offline project. So the next time I turn on my engine, it's going to go, what the hell's going on here? Sorry, the next time I turn the ECU, it's going to say, what are we doing? Am I using what's in the controller, right? Or am I going to use this? So you need to decide, okay, well, I'm going to send over what's there, or I'm going to use what's there. You know what I'm saying? So it's really up to you on how you want to do it.
SRT on though. How do you turn it on though to make sure, like, what does it say race with no traction control?
Uh-huh.
And then I want to jump it on. How do I dump it on real quick?
So the SR2, if you come over here, SR2 selection,
Yeah,
it's enabled right there.
gotcha. Okay, now we got it. Okay.
Yep. So
All
if that's enabled, all those curves are all hot.
Okay.
Yeah.
If you have the dash, you can just select on your dash.
That's how you have to do it. You can't turn off or on. You can enable or disable here from the software. But if the SR2 is enabled, you have to choose the curve from your dash.
Yeah, so then you would just, it only affect the SR2.
Correct. Yeah. So we'll go out there in the dash in a little bit. You'll actually see where it'll say SR2 curve, and you'll choose 1 through 9.
Yeah, I've done that before. I didn't know what it was though.
That's what it is. That if you don't do that, you could change. You could have perfect curves and everything, but if you're not actually adjusting it there, you ain't doing anything.
Oh, my races.
That's what I'm saying. You got to do it from the dash. Yeah. So that's the boost control, the traction control, all has to be done from there once it's plugged in. If it's not plugged in, then we don't listen to it. Yeah.
Will knock
And it
out
doesn't
the
go
rest.
into effect
So
until the
it's nice you can knock out all those others, and you can check this.
Exactly. Exactly.
And then
Yep.
save that, and then knock out, and then you have different, so I can actually do what you did and erase all the ones on the bottom and go file to file for each one that I have, you know what I mean? And that way I'll
Absolutely.
know, so that, yeah, okay, gotcha now.
Yeah. So if I just get back
If
here,
you enable them, they're all 9 are enabled, right? You just have to tell the dash which one you want.
correct.
Correct, see,
Correct.
exactly.
But
Exactly.
To turn them off, you have to go into your
I got
laptop
3 in right now.
and into settings.
And disable it. That's correct. Yeah. So when you disable the SR2, you're doing 3 things. You're turning off your gear curve retard. When you leave, advance, again, you can add advance, whatever you want to do. You're killing the gear curve. You're also killing the traction control plots for dry shaft or engine. All that's turned off. It'll still read. Everything will still work. You're just power management's turned off.
So how is your new deal gonna affect this?
Good question. It's a good question. So it's going to be able to work without this stuff all turned on because we're going to be able to just monitor the acceleration of the drive shaft and work within parameters that we can program for actual ignition timing itself.
So we're gonna have to come back to California.
And yes, you can use both.
So how do okay, let's say I got the traction control on the dash, but I also have the power thing, so let's say I put power number 3 in. And then I gotta go over to the SRT, and then I gotta press in what I want for the traction control on the SRT to go with power number level 3.
No, once your dash is connected, it chooses the curve. So that's the thing here, okay? So remember, if this is on curve number 3 here, or whatever we have here,
Right, power curve 3.
if this is over here under number 3, okay? Okay, it doesn't matter what's
I'm
here.
talking about traction control, I'm talking about my power. I have 3 different power settings in my dash right now, 1, 2, and 3. You know what I mean? Where I can press different buttons for power because you got me on different boost levels for different.
That's the boost. This is traction control.
But can I turn on number 1 power on number 1? And if I set up this, will it go to that program that's in the number 1 with the power with the number 1? Now, if I go power number 2, will it go to number 2?
So this is your boost map. Again, if the dash is plugged in, this doesn't matter.
What I'm saying is, will it go with each power setting? Will that, if it's only for the number 1 setting on the power, or can it go to number 2 power setting, or can it go to number 3 power? We'll be able to work with all the different power settings.
I guess
1, when I write it out.
Yeah, I don't understand you by power settings.
Because you have my dash set up, I have each tune. I have 3 different tunes in the car right now.
Yes.
So if I set that traction control, could I use it on all 3 different tunes?
Yeah.
Okay, that's what I'm asking.
Yeah.
Because if it's working good and I say, oh, the car might want a little bit more power, put number 2 in with the same traction control setup.
Correct. Yes, it's completely independent.
Okay,
correct. You can choose either or.
Okay, so I can still go different power management levels.
Absolutely.
With the same traction control in it.
Absolutely. That's the whole thing. Because you may miss and it may need to get more out. You know what I'm saying?
Or if I miss it, I can do a different power level and see if it hits good with that one.
Exactly.
Change all those curves in it.
Exactly. That's the point. Is to just at the line, shit, the track just went to crap. Give me something to where I'm pulling more power out. And...
They commute together in it.
Exactly. So, but that's the biggest thing is guys will just forget about the fact that the dash wins, and they're like, and we'll look at the curves. I'm like, well, yeah, you wanted curve 3, but you're actually on curve 6 because the dash is plugged in, and that's why it was programmed for curve 6, and they did it here, right? And they're going, oh, I get it. So you just have to remember that.
If I'm on number 3 power and I want the traction control that I just set up, it'll go onto that program too for the power.
Yeah, however you program it here, it's going to listen to it.
Gotcha.
Yeah, whatever is programmed for that curve or that map, whatever you do, it's going to run it.
As long as I got that map on 1, 2, or 3, and then I put my other one that's my boost, whatever it is, they got a match. They both got a match, I guess, right?
No.
Okay.
No, that's what I'm saying. So like on the dash, let's just say you want to use burst control curve number 3.
Yes.
You can leave this one. It don't matter. It's using 3.
That's okay.
Dash wins. Dash wins.
Just for the boost setting and the SR2 setting, or is there something else that the dash overrides?
The only thing that you can actually ignore from the dash is over here on the rev limiters. If you actually go down to here, okay, you have a touchscreen dash rev limiter override. So when enabled, ignores the rev limiter settings from touchscreen dash. So that's the only thing to the dash will technically not listen to. Everything else it listens to. So it will literally only follow the dash. But if I enable that, then the actual rev limiter settings will only be listened to from here. Okay, and some guys are just stuck on just doing it with the laptop, totally fine. You know what I'm saying? But they have to do it here. So we always, as a default, send it out here enabled so that it listens to the software here. That's how we do it.
Is that just talking about the high rev limit, or is that, or can you adjust
All of them.
3-step, 2-step, and half-step also?
Yeah.
Okay.
Yeah, they're all on the dash, and you can see that. So again, this is the only one that you can ignore from that.
So the TSD enabled overrides the dash.
Correct. Yeah. So here, let me come over here and show this. So let's go back to graphing and logging. So right here.
So disabled, it listens to the dash, enabled, it doesn't.
Yeah. So right here where it says TSD, this, like you said, this stands for touchscreen dash. So these are different offsets that we can program in. Okay. But for example, if I went to my SR2, or is it desired, D for desired, right here. Okay. Desired boost map and desired SR2 map, that's going to be what's in the dash. Okay. So right here where it says SR2 map desired is number 2. Well, if I look at it over here, okay, this is actually showing number 3. Okay, because it's listening to the dash. The dash wins. So I was to go out there to the dash right now that's on the engine, you'll see it's programmed for number 2. So it doesn't matter what I have here in the calibration of the laptop talking. No, it's whatever is on the dash. Okay, so just remember that. Just that way. Okay, I know I want to use different gear curve. Okay, gotta go with the dash to set it. Okay, if I don't, you do it here. It's just going to do whatever one you're on. Okay, that's how that works. So the desired will always match up, okay, with whatever you have the dash on.
But when you're setting the graph, you're setting in the graph on the computer, it's just
Which one are you choosing?
which one you're choosing is being selected from there.
Exactly.
Okay.
Exactly. That's it. Exactly. So again, the whole point is just remember there's a hierarchy to stuff, right? The hierarchy, if the dash is plugged in, the dash wins. Dash is unplugged, then the laptop just uses whatever numbers in there. That's it. So we just had to make it so that it's not that it's not confusing, but something has to win. And that's how we just said, okay, the dash is plugged in. They just do it from the dash. Like we have guys that have race pack dashes, stare them in the face. They want to see that. Then they have our dash off to the side so they can actually control their power management. What's that? Oh, I see. Got it. Yeah. Well, I'm just saying guys still want to use that, which is totally fine. And then they can just use that to choose whatever curves they want to have. And that's where, again, what's really nice is, so for example here, if I go back down to where it says, okay, TSD gear 1 offset, okay, this is really cool. So for example here, let's just go back to our curve number 1. So if I come over to curve number 1, there's that curve that I plot in there, okay? One thing you're gonna wanna do too is as you build these out, so you see how it's set for 5 seconds, but we're actually coming off the end here. See how it's set for 3.5 as the time, okay? You can come over here to these 3 little dots and we can auto scale this. And what it'll do is it'll make it look better. It'll fit it in the scaling, okay? So if you remember to go up here to those 3 little dots, as you're going through these, just click auto scale. And then now it's at 5.76. And now you can actually see this a little bit better. You know what I'm saying? It just makes the resolution better for you. Okay. So if I was over there on the touchscreen dash, this is where you can really start picking out the small little details here. Okay. So right here where I say touchscreen dash gear 1 offset, right now it's set for 0. Okay. Well, let's just say you really like this curve, but you don't want it, you didn't build another curve to where you can, let's just say everything else is 0. Well, if I put a -2 in the gear 1 offset, I'm now taking 2 degrees off this entire curve. Okay, so you're same shape of the curve, same everything. I'm just pulling 2 degrees more. Okay, and that way at the land, the very last minute change, if you're not exactly 100% sure which curve you want to load in based on power management, you can say, you know what, the track just went to shit. I'll just pull 2 out of my curve that I have chosen. So it'll fire up, it'll go, it then pulls out 2 more. So as soon as I go to 0, where it was 0 is now -2, right? Where it was -2 is now -4. Whereas -10 is now -12. And then it just ramps it all in.
So how could you change that to number 2?
See, that's what I was at.
It's on the dash. It's you just choose.
But what I'm saying is, if I'm on my power number 2, you got 3 different tunes in my car. If I'm on number
For the
1,
boost controller,
for the boost control. But if I'm-
SR2 can do up to 9.
Okay, but the SR2, now, well, do I have to, if I go to my power setting 3, let's say, will this go with it? Or
Yes.
Or do I have to go to the computer and put the number 3 in there? That's what I'm saying.
Forget about the computer.
Okay, that's what I was asking.
Forget about the computer. Forget about the computer.
Because then you have the 2 different scales, you'd have to put a 3 in that and a 3 in that, you know what I mean? To make it-
Forget about the computer. Dash wins.
Well, but if I didn't have the dash, you'd have to go 3-3.
Exactly.
Gotcha, see, that's the
If
question.
you didn't have the dash, you'd be choosing the curves from the laptop.
Yes, that's what I'm asking. That's what my question was. Will it just automatically go over to the tune with me? And you
Yes.
said yes. Then he said, well, how does it do it? Because you have to go into both of the.
If
settings
you unplug the
and set.
dash, it listens to the laptop, whatever you have chosen there. You plug the dash in, it listens to the dash.
Okay.
But that's what's really nice about having that offset here in place for this Gear 1 retard, because again, maybe the track actually got pretty good. I want to put 2 in,
Do it, yeah.
right? So now this entire, now remember that 0 becomes positive 2, but you're putting 2 in everywhere.
To edit that, that's operated through the touch screen dash. for the
Yeah,
offset.
and we'll-
Oh, because
It's-
it says TSD.
Exactly. That's exactly why it says TSD. And the beautiful thing about this is you have it for the boost controller, you have it for the SR2 and ETM as well. Okay. So like, let's just say you have plotted a nice SR2 curve to ride. Okay. And you're used to riding it. I got guys that ride their traction control curves the entire way. I'm adding and pulling timing the whole way down. It works beautiful. Well, let's just say on the SR2, right, which is timing, I'm going to add a 300 RPM plus offset to that curve. So now, instead of them riding what they usually ride, that whole curve is just shifted up by 300, and now they're going to ride it higher. Okay, that's what these are for, is to provide an offset.
Make that last minute adjustment.
So if the track
Exactly.
comes around, you can be like, okay, I'm gonna pump a little.
Exactly.
Just, like, grab a little more.
Exactly.
So what's the difference of building 3 graphs with two additional or 2 less and just going to number 2?
Same thing.
Same thing.
Yeah, but again, if you don't want to build a curve, that's where you could. So for example, let's just do that real quick, Dana. That's a good idea. So to make this
You
real,
have to get into to do that.
Yeah.
Whereas if you built a curve with 2 plus and 2 minus that were identical, you could just go number 1, number 2, number 3, and then
Exactly.
if you wanted to change the timing, you wanted the traction got better, and you wanted to take timing out quicker.
yes,
Instead of taking timing out in 1 second, you could take it out in 3/4 of a second.
you'd have to have it on a different. Remember,
You could
this
do
is
number 5,
this
6,
is just an offset to whatever is on that curve, right?
Another
So
way of doing it without remapping it.
correct. So if I was to come over here and just highlight, okay, I'm going to left click and just hold this down and just highlight these numbers. Okay, I just highlighted from 0, -2. If I go Control C, now I'm going to go to spark curve number 2. Okay, I'm going to Control V. That's just copy paste. Okay, so now I've got 2 curves that are exactly the same thing. Okay, so now on that curve I just copied and pasted, I'm going to take 2 out. Okay, so now that curve is now taking out 2 more additional than number 1, right? But that would be the same thing as me applying the offset at the starting line. If I just put 2-degree offset, I just did the same exact thing to number 1. Or if you have one like that, you can just choose curve number 2. But you have to remember, okay, that if you choose curve number 2, everything follows that. Your dry shaft curve, your ETM curve, everything rides that number. So that's what's nice about it. You may actually want to keep that curve you're on because the engine plot and dry shaft plot, that curve is perfect. You just want to leave it a little bit more. That's where you just simply put this here a little higher, a little lower to now alter only that curve.
So you don't need a bunch of different curves. You could just mess with that, tweak it a little bit, and that's it.
Exactly.
Gotcha.
Yeah. Because you have to remember, if maybe if you're on curve number 2, okay, well, if I go to curve number 3, that's actually a hotter dry shaft engine plot that it's going to follow. You don't want that. I just want to leave with a little more power. That's where the offset's perfect.
Just bring a little in on the head.
Yeah, it just simply offsets whatever you have programmed in this. So that way you can still ride, you know, if you're a bracket guy, you may want to ride that. You may want to go a 905 or whatever every time, but you want to leave a little harder, you'll still ride your dry shaft or engine plot perfectly, but you can just leave a little harder or take a little power out of the curve. That's what the offsets are for.
But it rides the whole curve still.
Yep.
It rides the whole 5-second curve.
Exactly.
Adds and subtracts of the 5 seconds.
Yep. And again, the way the offsets work is once this time is up, that's out.
That's out.
Okay. Yes.
It says, gear 1, does that mean that when you shift into second gear, the offset's gone?
No,
Okay.
it's just based on time. It's just,
Yeah,
it's just gear 1 leaving.
yeah.
So I could be out in third gear.
Yeah.
It's just time, right? It's just what it's called.
Yeah.
Yeah. So again, this is where this is really powerful because this is where you can start picking the fly crap out of the pepper. You know what I'm saying? To where you can really make those small adjustments without having to get your mind all wrapped around, God, if I go to curve number 3, then what else am I also changing on the gear curve? I'm sorry, on the dry shaft plot, all kind of stuff, you know? If I just apply the gear 1 offset, then I'm good. You know what I'm saying? And now I'm only messing with the offset of this curve here, whatever I'm working with. Okay.
Instead of the whole graphs and everything.
Yeah, because again, what right now, well, with the next software update, it's going to be more. But as of now, which is going to be really nice, you only have, okay, see how it says dry shaft ETM curves 1, 2, or 3. This next update, we're going to have 9 total, but you only had 3 curves in this previous software version as far as writing a dry shaft plot, okay? So now you're going to have up to 9. So what most guys will do is, okay, for gear number, for number 1, I'm going to have a certain timing retard. I'm going to have a dry shaft plot to follow. Well, as you go down the numbers, you start altering the plots if you want, right? And that's where I'm just saying is if all your dry shaft plots are different, you want to keep that the same. You just want to leave the starting line a little harder or a little softer. Just apply the offset here. That way your traction control, power management wise, dry shaft, engine RPM, that all stays the same. You're not choosing different curves that potentially could offset stuff up or down.
That's what I was saying, because later drafts over on the graphs, you gotta start playing with too many different things.
Absolutely.
And then I could lose what I already got, and then I gotta go back and look through it again.
Just do that.
Okay, gotcha.
Just do that.
So what, the SR2, the gear 1 curves,
Uh-huh.
what does the drive shaft and ETM curves, there's only 3 and there's 9. You say they go together, correct?
No, so the way it works is right now, okay, you've got up to 9 different gear curves, okay? But we've only got 3 timing, we only have 3 dry shaft or engine plots you can follow. So gear curves 3 through 9 only work with the 3rd dry shaft curve, engine RPM
So
curve.
if you did want to be able to change how hard you leave, but keep all the rest of your curves the same, you could just start working off 3 through 9.
Yep.
And then those still would follow.
Correct. Yeah, it's number 3 of the dry shaft and ETM curve. Okay, number 3 just stays with 6 through 9 on the gear 1 curves. That's how it works. But on this next software update, you're gonna have 9 total. So you're gonna have 9 different dry shaft plots to choose from. It's way more. So but again, my whole point is you can kind of get lost in the weeds a lot of times, especially if you're making a last minute decision.
Yeah.
So if you know you're writing an existing dry shaft plot, you can leave that the same. But again, you could shove an offset in those too. You know what I'm saying? So if you know your curve, you like it, just apply some offsets to
So
it.
if you go -2 on the gear lead, but then you go +2 on the drive shaft, then the drive shaft should stay the same.
Well, the dry shaft's RPM.
Oh, right. Okay.
So you'd have 200 RPM, for example, whatever that is, or 100, whatever you want to do there. Yeah, but again, yeah, you could. You're giving it more, right? So you may want to up that a little bit more so you don't ride it as hard.
Yeah.
That's the point of the offsets, is to just give you some more adjustability off the starting line. And with the boost controller offset, if you have a 0 to 50 pound PSI target, whatever, that's just, again, plus or minus the CO2 target to it. That's how that works.
My
So-
CO2 target, I leave it at like a little above 50 right now.
Mhm.
Okay, and I know, but if I lower it, it'll lower my wastegate pressure with less boost, right?
Yep. And that's where you could put an offset in there to say, okay, add 5 pounds to it. It'll just add an offset to that curve.
How come mine says SR2 and that says TSD?
You just may have an older one. You just may have an older firmware possibly. The factory stock shut-on stuff's probably at an older firmware. Yeah, because the reason why is because NHRA, they're just we just don't have the we're on an older firmware version for them, and we just don't have the approved newer versions yet. So we're working on to get that done.
For the lock, RPM.
Yes, exactly. Yeah, I want to finish this and go that and get that one approved. That way I can have all these new features available. Yeah, exactly.
And then could you open the, one of the drive shaft curves?
Sure.
Oh no, sorry, go back to that menu you're on.
The gear curve?
Yeah, the gear, no, where it says like the gear one above that. Gear one, DS and ETM curves.
Yep.
So click on that. So this is what I learned from one of your videos. If you click on the jumbled mess down through that right there.
Yep.
That'll make that bigger.
Correct.
Shrink the other one.
Correct. Yes. Yeah. It's just we're cramming. Basically, we're grouping everything. So if you choose number one, this is all in number one.
I just see where screw up and right there.
Exactly. So
It's gonna be the line on it, just about.
yeah. So what we'll do is let's bring in a log. We're just on traction control. Let's just stay on traction control. So we're gonna come over here. We're gonna go open data log. I'm gonna throw a log on here that has a dry shaft sensor reading on it. Let's see here. Sort of this one up.
So I used to get things all the time, so I went and bought me a square D bender and started doing that.
All right, so let me go back up here. All right, so let's just focus. Let me turn a bunch of this crap off. So what we're going to focus on right now is we're going to focus on how to actually control power management wise from the dry shaft. Okay. So I'm just going to turn a bunch of this crap off that we don't have to see for now. We're literally just going to have engine RPM and dry shaft. And we're also going to incorporate the G meter, because G meter is very important. Let's see here. Turn this off. Race timer. I don't care about that. Okay, so where's my G meter? Okay, so down here where it says Excel. Okay, so it should be this Excel Z. All right. So Excel Z in this case, okay, if you look down here where it says accelerometers, okay, this is the built-in G meter. Now, depending on how that's actually mounted in the car, that may be, there's going to be certain values. I'm going to show you how to find out which one is your axis, okay? Because if the ECU is mounted like this in the car, it's going to be different from this and from this, right? So we have to calibrate it correctly, okay? So there is no magic to it. So what you do is inside the data logger here, we have smoothing functions, okay? And all the smoothing functions basically do is they apply a smoothing resistance to all that data. So the ECU, okay, in reality is picking up data this fast. Now, can we understand that? Absolutely not, okay? But the ECU is actually picking that up. Okay, that's how fast we sample stuff. So if I come over here to Excel Z, okay, I'm gonna hover over, I'm just gonna left click it. I'm going to apply a field smoothing number, okay? So Y, field smoothing. I'm just left clicking over it, this stuff. And then here's your number, 32. 32 is for your G meter. So I'm left clicking it again. I'm going to go smoothing factor, and I'm going to apply a smoothing factor of 32. Now we're actually going to have usable data to work with. Okay, 32. 32 is the number. That is the number. Trust me, that is the number. All right, so now let's zoom in on this, okay? So I'm gonna move this over here. Okay, so now you can see here, car's on the rev limiter, it launches. This red line, okay, goes right up here, boom, and sticks. Okay, that is the G meter at work. Okay, and you can see here that right here, the car initially launches, we lose a little bit of G right there, falls off, then it picks back up. That more than likely is timing retard being pulled out to launch and then coming back in. Power's come back in, okay? But that right there is your Bible. This guy reading this guy is basically what's going to tell you what to do power management wise. Okay, so that G meter is literally what tells you, am I going to just fall off as soon as I launch? Is my tire going to spin? All that type of stuff. Okay.
So I have to press open log, but I don't get it. I'm putting in a program and I'm not getting
If you open log, go pull one of your runs that you had out from one of your passes. So this line right down here in purple, okay, this is the dry shaft sensor right here. Okay, so you can see here how the dry shaft sensor is pretty much stuck. We can apply a little bit of smoothing to the dry shaft sensor as well. Maybe give that a smoothing factor of 10, just something else to smooth it out a little bit or whatever. Okay, but you're going to want to basically look at this in relation to the dry shaft. Okay, can you see it, Steve, or no?
I think he has any files that have any information.
Oh, okay.
Zero with each one we open.
Yeah, 'cause we got Dynos, poles and stuff like that on here. But
Yeah, you need one from a pass at the strat,
there you go.
at the strat. So look at your Excel values and find them, and then do the smoothing factor of 32 for each one of those. Okay. So now that we actually have a plot opened up here, okay, what you want to do is
Yeah, we gotta get
come over here to this table. We're going to go SR2. We're going to go desired dry shaft curves. Okay. So there's nothing on here that we can work with. Okay. See how the SR2 timer starts and our ellipse moves here though? Okay. So now race time is lining up here, but we have nothing here for the desired dry shaft curve. It's just set for 100. This is just our program here. So what we're going to do first off is we're going to come up here and go show XY data log plot. Okay, the x-axis field is going to be the race timer. Okay, x-axis field will be the SR2 timer, and the y-axis field is going to be RPM underscore TOS, transmission output speed sensor, right there. Okay, so now this is showing the dry shaft sensor in relation to the race time itself. Okay, so now we've actually got a plot of something to work with to build from a dry shaft reading. Okay, so all I did was do show XY data log plot, these three little dots right here, okay, on the SR2 desired dry shaft window. Show XY data log plot, X axis SR2 timer, and the Y is RPM toss. Okay, that's then going to bring in this dry shaft sensor. So you can see here again, got some scaling issues going on, right? Like I'm going off the chart here, this and that, right? So get in the habit of going up here to the three dots, auto scale. Now this one actually got, that one got really screwed up here because of the way it scaled that right there. I'm assuming it's because of the time. Boy, that's really funny right there. Huh. I don't know why I did that. I'm gonna check that actually.
You know, mine says EGTs where my dots are.
I shouldn't say GTs there. Here, let me close out this window. All right, let's try it one more time. Okay. Yeah, it rescaled that axis right there. Not sure why it did that. So let's come over here to set X axis maximum. So right here it's set for 6. I'm going to make it set for 10 to match up down here, okay? This is the X axis. This is the Y axis. Y is vertical. X is horizontal, okay? So I'm going to make this 10, okay? So now you can see the dry shaft curve flatten out, okay? So now We have no data to work with though. We just have a plot that's just in there, right? So how do I build a plot to work with this? All right. It's really simple. Just come over here, this purple line right here, fit curve to data. Right there. So all you're going to do is just left click on that. And what's going to happen is it's going to hug that line, not perfectly, but it's going to give you a good representation to go from. Okay. So left click that.
Where are you left clicking it?
Right here where it says this purple line. It's a purple line right here. Oh, it's funny. It's not actually loading it in there. Hold on. All right, let's go above it.
There's
That's weird.
table error or just dry shaft curves?
SR2 desired dry shaft curves.
Okay.
Yeah, that's typically what the default is. I wonder why I'm not bringing that down there. That's interesting. SR2 RPM toss. Huh. It's supposed to be fitting that curve down. That's interesting. Let me try the maximum again. See if that does it. No, that didn't do it. That's weird. Yeah, see, it's rescaling that to 8,300. I'm not sure why it's doing that. That's really weird.
Oh, no, got it.
I'm going to try to open this up in a different window. That's really weird. SR2, desired. Let's try this one more time. There it goes. I don't know why I did that up there, but I put it to a different window. And so basically what it's doing is it's kind of splitting the difference here, but it gives you something here to work from now. So basically it's building your curve. Obviously it's higher than this down here, okay? But this is basically these dots here, okay? These dots represent these boxes down here below, okay? So what you can do is come up here. I think it's because of how the scaling is over here. You know what it is, I think? Because see how it's got it from 10 to 5.68? I think that's why it's so messed up right there. So take these dots and you can drag them around out of your heart's content. Okay, so for example, see I got this dot over here at 0.19 seconds. Okay, that's this 466 right there. And then I got this dot up here. This is this 5685. So if I was to come over here and left click this guy and interpolate.
I just can't get that rainbow up there. I don't know what you're on. I can't.
I'll show you in a second. So now that I've got this curve built here, it's actually somewhat on top of it, right? That isn't too bad. So now if I really wanted to hug that curve, okay, I could highlight all these boxes, okay? And you'll see all these turn red, right? So let's subtract, just for example, I'm going to subtract 500. Okay, now I'm really on this curve. I'm actually, now the dry shaft's actually above it. You see that? Okay, but the dry shaft's actually above it right there. So here's where you could actually start fine tailoring stuff. So I'm going to just plus 200 back up here. Okay, so now I'm like flat on the curve right there. Okay. So let's just say, for example, again, all examples here, you want a 5-second eighth mile on this here, okay? Well, I can literally build a plot here within, I can build 3 different plots in about 20 seconds. If I just simply just copy this, okay, again, just simple Windows stuff, Control C, that puts it on the key, on the clipboard. I'm gonna go back to number 2. Okay, I'm gonna Control V that. So now I've just made number 2 the exact same thing, right, as number 1. I'm going to highlight number 3, Control V. Okay, so now literally every curve is the exact same thing. All right. So now let's just say I wanted to make number 2 hotter. Okay, I wanted to give it more room. I can highlight number 2, and again, this is just for example, but I'm going to add 300 to that curve, right? So now I just made a hotter tune up here than number one. Let's just say I went to this curve here and I added 300 to, what at 300? I'm gonna add 600 to this. Okay, boom. So now I've got 3 curves to work from right there. Okay, so now the dry shaft though is way down here, right? And now I look with that one, look how much room I have. I got a ton of room, right? So if you get out of the logger and you come back over here to this window, okay, this is the same exact window as this, but I can see it bigger here now. Okay, I can get out of the logger and I can get some more resolution that way. Okay, I'll show you in a second, Steve. So over here now, you now have 3 different plots that you can choose from. There's your original right down here on this curve number 1, right? But now this is where I can go into the dash and say, okay, I want curve number 2. I want some room. I want to go faster, right? I want to go to curve number 3, but I want to go really fast. I don't want to touch it at all. You know what I'm saying? Mm-hmm. But that's how you build the curve, and based off of this dry shaft data plot that we got right there.
So you're saying just plot 1 and then go zero out every one, then it's going to zero it out and put it right where it is, and then from there play with it a little bit.
Yeah.
Get 3 tunes real quick.
Exactly.
Gotcha.
Exactly.
You
It's just copy pasting.
Yeah, instead of making and doing it.
You can make the first one if you want,
Yeah.
and then just copy paste it, and then work from there. Build your
See
curve
how
from
you
there.
got the first down, but did you just do a tune that you had in it then, and then copied and pasted it?
No, we
Once
just.
you get the tune, what's driving it to change?
Oh yeah,
Where did
sorry,
you
that
get
was a
Where
log.
did you get the tune?
Yes, that was a log.
Okay, that's what I was.
That was a
asking.
log that had a dry shaft sensor.
Okay, gotcha.
Yeah, so that's where I was showing you.
Oh,
So what's that?
Is.
That's the dry shaft sensor.
Which is, yeah, TOS.
Exactly. So our TOS stands for transmission output speed sensor. So that's your dry shaft sensor.
You gotta give me a list of all the abbreviations.
It's actually in the back of every manual. They're all there. But you're right. I know we're acronym heavy here. Okay.
So you can also do the exact opposite of meaning, hey, we have this run, we know the track just went away. And instead of adding for a 100 tune up, we could deduct to slow a run down.
Exactly. So let's do that. So if I was to come back over.
Trans output speed sensor, you only have one on the drive shaft.
This is the dry shaft sensor. It's the same thing. It's just the acronym name for it. So all you would do here, right? Let's say number 1 is this. Well, let's just say on this guy here for number 2, you want to make that your one where the track went to shit.
Right. So instead of adding 300, we just subtract 300.
Exactly.
But because we added 300 already, we'd have to take 600 to go back to ground zero.
Exactly.
Which one are you?
Exactly.
Okay.
Yeah,
Got it.
that's it.
Yeah.
That's all it is. So that's, and again, if I was to come over here to my very first one, I'm pretty much riding that curve. You can see it right there. I'm pretty much right on top of it, right? But if you wanted to say, you know what, that actually, I got away with murder there. I was kind of close to spinning. Let's take 300 away from that one. So now I'm actually below it.
And you got a safe tune up. Yeah. So what you can almost do is tailor, you got a good run at, let's say, Sonoma. You got a good Sonoma. You go down to Bakersfield. Okay, we got a Bakersfield track.
Exactly.
Vega, all the variants. So basically, you start building your little databases.
Yep.
For these runs.
Yep.
And each track.
Yeah. And this is where, again, it's really powerful because if you get in the habit, obviously you want to save your calibration, but if you just save this window.
Correct. And then you're not changing your whole.
Exactly.
You're just changing this blip in the drive shaft.
Exactly.
Okay.
Exactly. That's how it works. And you have less cause for error if you do it this way. Because again, if you change some timing, if you change some fuel, if you did some other stuff.
All the time.
Exactly.
But the motor's happy in those parameters.
Exactly. Exactly. That's what I'm saying. If you realize this is your calibration or tune-up, just change this window. And name it, like you said, name it this track, name it whatever, and that's fine. Yeah. So he had a good question. He's like, well, what if we want to make this first one even lower? So we just made this one lower. You can see that this now curve number 1 basically is about 200 RPM below it. So now you could actually have a really ultra safe curve. Okay.
So track goes to shit.
Yes. Yeah.
Exactly.
Right.
Yeah, it's,
Okay.
guys need that.
Or let's do this. So I'm gonna hit the back button, right? Because I'm in here. So I'm gonna hit the back button. So now I'm back right on that curve, right? So I'm gonna close out this window. Okay, now see, this is the dry shaft RPM. Okay, at the very top of the run, I'm around 5,500 RPM. Okay, I'm dealing with thousands of RPM increment. Okay, so if I was to come over here and let's just say I went back to my touchscreen dash and that track got way better. Okay, I would put in a TSD SR2 dry shaft offset of, let's say, 300. So now I've just added 300 to that entire plot. Okay, it's the same thing as the first gear curve, right? I'm adding or subtracting some timing. Well, now I can add the same amount of RPM to the dry shaft. Just do it there. Without having to change the entire curve or go through all kind of stuff. Because remember, if you're changing curves 1 through 9, SR2E, it all moves with it.
So if you mess up, you
Right. What if you choose a curve where you didn't want that first gear timing curve that you actually wanted on the timing curve you were on, but you chose a different one for the dry shaft? You can just simply put a dry shaft offset in place, right, to go up over whatever dry shaft curve is here. Give it a couple hundred RPM is actually quite a bit. It's actually quite a bit of room.
the best way to check to make sure that you're getting contact. I know my dry shaft stuff works, but I'm just saying, what's the best way to check it?
Just watch the dry shaft sensor. If it's going up,
it's on a jack stand and spin it and see, make
sure.
That's what I'm asking.
Sure.
You can do it on the dry. Okay.
Yeah, that's fine. It'll just show mile an hour. It'll just show RPM. That's
Okay,
fine.
that's all.
Yeah.
Just to check it, see if anything, make sure everything's working right,
Right.
Ben, earlier, where you have your TSD ones, you had one that was a boost offset.
Mhm.
This one doesn't show it because this data log didn't have that option.
Yeah, that's actually brand new for this next.
We're trying to find it on.
It's not. Yeah, we actually just put this one in for the 6 software update. Like I said, we've done so much. Yeah, the TSD boost offset is new for this next software update coming out. That's why it was on the previous log. This log didn't have it.
I see.
Yes, exactly. Good. No, that's a good catch. So,
We're just trying to stay up to speed.
yeah, exactly. No, but that's where it's new. You're right. Exactly. Yeah, and exactly. That's the thing. You are going to see that. It was because that was the only one that wasn't shown there. I'm like, we got to put the boost offset, so we put that on there as well. So yes, you will see that. Okay, so not to fully blow your minds, but that's only a part of it. You've now created curves, right? So now that we've actually created a curve here, okay, well, what are we going to do with it? Right? That's the thing. We've created a curve. This can be a dry shaft plot, engine, but whatever. We've created curves that we want to work with, but you still have to modify a table to show how much power you're actually going to take out. Right? Because just because we've made this doesn't actually show how much power we're going to take out. All right? So what you've got to do is you've got to go.
Is there anywhere we turn on the drive shaft on the computer?
If the SR2 selection is enabled, it's on.
That's what
It's on. Those tables are hot. Okay. So if I come over to SR2, okay, right here, remember SR2 is timing, dry shaft error table. Okay. Okay. So inside here, okay, is basically what we're going to look at over time. Again, it's set up for weird because I set up here, but this is going out 10 seconds. And this is where we're going to figure out how much timing we're either adding or subtracting if I'm going over or under my curve. All right. So building the curve is one thing. Now you got to come in here and say, okay, based on going over it, I have to see how much power I'm going to allow it to take out or add in. Okay. So obviously each column here represents time. I can do this anywhere I want inside the run, right? I can make this however I want to build it. Okay. Now this is an older cal. So one thing you have to remember here is, okay, see here where it says SR2 dry shaft error RPM. This is actually going under the curve. I know it's kind of backwards, but this positive number here indicates if I was to come up here, this means I'm actually under my curve. Okay. If I was going over, I'm going down. Right. So basically, again, you guys know how to do this now. I want to rescale this. 1100 RPM above or below is too much. So let's make this 300. Hit those 2 arrows. I'm going to right click. 'em. I'm going to select interpolate. Okay, I'm gonna select -300 here. Okay, now I'm gonna interpolate. Okay, so now I'm 300 RPM over, 300 RPM under. Okay, I'm gonna apply the new X, Y. The Z is inside here. Okay, I'm gonna leave that unchanged. I'm gonna close it. So now my axis is updated, all right? So now what's gonna happen here is if I'm 43 RPM over my curve, I'm whacking out 10. Okay? If I'm 130 over, I'm pulling out 11. If I'm 170 over, I'm pulling out 12. If I'm 300 over, I'm gonna pull out 15 degrees. Okay? That's how that works. So the farther you go over the curve, the more power we're gonna pull out. And hopefully it's enough to work, you know. It just depends on the combination, the load that you have, how much power you're making, the tire you're on, the gear ratio, all that kind of stuff, you know. Sorry. Yeah, the SR2 and then dry shaft error table.
So is the positive on your y-axis is because I mean it's all at 0.
Yeah, so
Because
this
it's
is
going under it.
exactly.
So you don't need to do anything.
Well, no, you 100% could say, okay, you know what? For the first second, if I'm under my curve, I'm gonna give it 2. Okay.
Try and speed it up to get it to match.
Exactly. Yeah. So again, with the big tire cars especially, it's advisable because you know they need wheel speed to get that big floppy tire happy, right? So you'll pump that in there. And the good thing about doing this too is that let's just say, for example, you pulled out too much out of the first gear retard. You had a bunch being pulled out. Well, you're under the curve, and this was shoving 2 back in. Well, you'll know. You know what? I probably am pulling out too much retard out of my first gear curve. I could probably get away with less being pulled out there because it's trying to shove power back in here.
So does this come in before or after your first year retards?
This is all at the race timer. So once the SR2 timer starts, it looks at the curve and it rides this table. So again, if you're over or below your curve, okay, whatever you have plugged in here is what it's going to do.
You have to build the curve you did earlier, and then you have to do this based on the drive shaft.
Yep.
So you have to put runs on it.
Right. You got to have the data to work with. Sorry, this says 2. I know it's kind of hard to read there. That says 2 degrees. So again, this is where you can really get lost in the weeds without having enough data. You really can't guess on this. You got to have some drive shaft data runs. But then once you get the drive shaft data runs, you'll know, okay, here's where my car sits at on these ETs.
That's what I gotta do. I gotta log some things down and then go back through.
Yeah, without any logs to reference, you're not going to be able to do this.
That's never did. I was just flat-footed.
Yep. You got to have the logs. And then once
a little, give it more.
exactly.
That was tracking control.
Yeah. And that's the thing, you know, and again, you can fine tailor this table, you know, any way you want, you know, same thing. If maybe after, you know, 2.2 seconds, I don't want to have any, you know, power management at all. I want nothing, you know, you can make this do whatever you want to do.
Because I'll be honest, dude, the power we got in the car right now, I can't control. I'll be honest. I've never been able to not keep the tire from spinning. And I got it in the first setting you got. I mean, we're 1,400 horse, and we're going 495 O's and I'm uncontrollable. And I'm spinning all the way down and still going 5
We just got to take boost out of it.
You know what I mean? I'm literally driving the I'll show you the videos, dude. I'm literally like going across at the end like this on a no prep track sometimes.
Yeah.
Boom, boom.
Making horsepower is the name of the game in that case.
No, dude, but that's why I'm coming, because I need to manage it. I can't.
Exactly. This will help. This ain't the end all be all. Plus, you don't want to be 15 degrees retarded either the whole way going on the track. You'll cook the exhaust valves. They ain't the best for anyways, right? So this will help you get there, but you got to listen and be like, yeah, I don't want to be at 8 degrees, 7 degrees.
100. Crazy numbers.
It just depends, you know. I mean, again, it's just one of those things to where I can make this 300 RPM number. I can make this -1 down here if I want. You know, I can have it barely any power.
That's just pulling RPM out of the drive shaft. That's all that doing. For the drive shaft, when it's reading, it's just pulling the RPM down to what you want for the drive shaft.
Yeah, if I'm going over my target by 43 RPM, I'm going to start pulling 10 degrees of timing out.
Gosh.
Yeah.
Okay.
So it's all cumulative, you know. So you got to remember, if you have the roll race too, right? If you're looking at the front wheel speed, if this is spinning, that's also going to be pulling out timing also. right? So if you're spinning there, it's all going to just keep pulling timing out. You can go negative if you want, you know, I mean, totally do it. I've got cars that do it. Negative is fine as long as just quick blips in time. That'll just help you get through a really tough spot, you know. But that's how the SR2 timing is a function of all the curves and this table. And then again, in your logger, okay, right here, okay, in this log, for example, this in the SR2 sections where all this data lives. So right here, okay, so let's just look at this, okay. So watch this SR2 timer, okay, that's going to go from 0. Moving. Right there, okay? So 1/10 of a second I go hot, okay? And here's where my desired RPM comes in, the error comes in, my spark offset, and there's the gear curve right there activating. So at a 100th of a second, we're already pulling 2 degrees out, right? And then as I'm going down here, 1/10 of a second, okay? Dry shaft RPM is climbing. So that's why you see this error changing, because the dry shaft now is going up. Okay, but again, it's set for 10,000 desired dry shaft RPM. So I'm nowhere near it. I can't get hit. I can't hit it. I can't touch it. There is no time that can be added or subtracted because they've got the plot up so high, right? But this is more for example of showing what the timing's doing. So right there at a half second, we're still 2 degrees out. 6/10 for 2, we're still out. Okay, 1 degree. And you can just follow it the whole way down. You can also, you want to see this better. But again, if I right click on this and send to graph 2, okay, you can now see that in this log, for example, it's just 2 degrees out the entire way. So they actually have it out the entire way itself. There is no offset to this here. They've just got 2 degrees out, and that's just what they programmed. So we'll go through some other logs to show that differently. But once that race timer starts, however you guys have these tables programmed is exactly what it's going to do. Okay, you just got to remember that. So there is no small detail in here. It's all big, because if you have stuff where the dry shaft curve is set really low, or you have it set to take out a lot of timing, okay, it's going to do it based on what these things are calling for, okay? So far, right now, we've also just talked about ignition timing, okay? So now the other part is going to be the actual ignition cut, because over here, you've also got ETM curves. So what that means is you've got a spark curve that'll work with timing alone, but then after that, if you're still spinning or something's going on, you have an ETM cut also as well. So you actually have the ability to start dropping cylinders. So if I come over here, all right, ETM dry shaft curve. Oh man, what are we gonna do? It's easy. It's good old copy paste. So SR2. Okay, so right now, here's all my SR2 curves, right? I'm gonna highlight all this. Okay, I highlighted all the curves. Control C. I'm going to come over here to SR2. Now I'm on the ETM curves. This is the ignition cut, okay? I'm going to highlight everything here because I already got some stuff pre-built. Control V. So now my SR2 curve and ETM curves are exact same thing, okay? So remember, ETM is ignition cut, SR2 is timing. So let's just say, you know what? I don't want to have the SR2 and ETM be the exact same curve, because if they're the exact same curve, that means that they could be dropping timing and dropping cylinders at the same time. We don't want that per se, right? So let's just add 200 RPM to this. Okay. So now if I'm on curve number 1, I've now added 200 RPM. So 200 RPM below this, I'm going to start pulling timing. If the timing isn't enough, I'm going to start dropping cylinders. That's how this works. So timing isn't enough, forget it. I'm going to start dropping cylinders to freaking get my power back.
Does that hit? That's not using the 20, right? That we're using.
That is.
Okay.
It's
that same number for the.
It has its own table.
Okay.
Yep. So now what we'll do is, if I close this out, now we have another table that we're going to work with, okay? ETM dry shaft air table. So the SR2 dry shaft is ignition timing. I can add or subtract, right? Well, now if I start dropping cylinders, you have a table here to where you can configure this to be exactly what you want it to be. So remember, 31 is full power, right? So if I'm up here, if I'm 20, remember, it's a negative number, it means it's going over, okay? If I'm 20 over, I'm still 31. Uh-oh, I'm 40 over my curve. Now I'm going to 30s. 129. If I'm 240 over, I'm down to 26s. Doesn't take a lot of ETM to drop power. This does not have to be a very low number. We hopefully are going to go bing, 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 and just hit it. And just drop the holes a little bit to come back down. That's ultimately where we're going to be at. But that's where you fill in this table to be exactly what you want it to be. And this is where you got guys that are just saying they're riding the dots. This is what they're doing. Riding this. So between timing and this error table is where you're actually just controlling the car the whole way down. Yep. And I do that just because, you know, again, if you start dropping holes, what's going on, you know, type thing. But again, this is very nice to have, because once you start getting some dry shaft plots, we can build this, Steve. It's something 100% can ride. Yeah, we just need dry shaft curves to work with. And again, engine torque management.
That's your retard. I mean, not retard.
That's ignition cut.
Oh yeah, ignition. Yeah.
Yep. So SR2 is timing. That's why on this table, okay? That's why on this table there's only a negative column. You can't add in more than 31, right? You can't, like the SR2, I can add in timing, right? I can't add in more than 31. 30, you got full power the entire time. Maybe. The physics, unfortunately, don't allow it, you know? But that's where this curve, again, you don't have to have a very low number here. The goal is to ride it to where it just brings you back down and stays on it. Now, if you start hitting ETM, you got to remember too, closed loop turns off. You got to remember that too, because you're dropping cylinders. So if you're dropping cylinders, right, that means we're misfiring, which means we're sending oxygen right through the pipe. O2 sensor says, I'm seeing lean. It will just dump a bunch of fuel in. So don't be surprised if O2 correction turns off.
Is it smart enough to actually turn off, or is it?
Absolutely.
Oh, okay.
Yeah, it turns off. That's what I'm saying. I'll have guys, why my O2 correction turned off? Oh, it's 28.
Okay.
Yeah, you're riding.
Cuts ignition.
Yeah, you can't listen to that data. I mean,
Best of both worlds.
what's that?
Can't have both worlds.
No. I mean, you got raw oxygen going through it. It's we
Well,
can't.
I won't try and add more fuel. 'Cause
No.
It's turned off. Yeah.
Correct. It's gonna, once you're off of it though, it'll come back
Yeah.
on. It'll come back on. It's just once you're here though, you're misfiring. Exactly. Yep. And again, you have to remember too, if you're riding this stuff too, and a safety triggers, EGC safety triggers, it's going to a 20. Remember, everything's going to override stuff that on top of importance, right? So if you're misfiring cylinders while going down, but you drop a hole, that 20 is coming in for EGT safety, and then you're just going to stay at 20. But that flag will kick on saying, hey, your safety went on EGT wise, right? It's not this. It's the EGT flag turning on.
Will that increase exhaust temperatures?
What's that?
The ignition cut.
A little bit, because you're throwing raw fuel out there.
Okay.
Yeah, well, a little bit. It ain't gonna hurt it though.
Right.
Unless you're just riding it for 10 minutes. I mean,
This would set off your thermocouple safety.
if you set the thermocouple safety, it's turning off that hole, and you shouldn't be on enough to where it'll do anything really. It's just you're gonna feel it and just dump
No,
hopefully.
I'm just saying, if you start to cut ignition, will that then turn into shutting a hole off?
It could.
So if the temperature's set low enough.
Exactly.
Okay.
Exactly. It could.
Gotcha.
You just have to learn it.
Yeah.
Everything's different. Yep. But that's how these tables work, is the fact that whatever you have programmed in here, and so let's do this for example. So let's just say I'm on curve number 2. Okay, so this is going to group together my gear curve 1, dry shaft ETM curve together. So if I left click this is what I have programmed right now for my spark curve, gear curve 2. This is what I'm going to ride if I have 2 chosen in my dash, right? Now, if I come down here, okay, here's my curves. So look at that. I'm at 500 my dry shaft to leave and 700 my ETM. Remember how I built those two to be 200 RPM spread? So it shows up here as that. So you'll be able to see that my first curve it's going to hit, it's going to be timing based, and my second curve is going to be ETM based. Do you want to flip them around? Sure. You can drop cylinders first if you want. It don't matter. It's up to you. And again, this can also be done on the engine plot also. You don't have to be dry shaft based. You can do it on the engine plot too. So future software, at least not on this next one, you're going to have the ability to do both. I don't have it in there yet. But right now it's just one or the other. So this just also gives you a visual representation of what it's doing here to show, oh, I'm going to hit this curve first before this one. Okay. That's where it's like, you just have to remember the acronyms. SR2 is timing, ETM is ignition cut. You just got to remember that. Okay. Because when you're building the curves, and if you see your ETM number changing, why is my ETM number changing? Well, it'll tell you first here, if this error, okay, if this error right here is a negative number, that means you're going over your curve. The error will show it to you right there. I'll pull up a log that'll show that. But this error is going to be your Bible as far as what happens here. So remember, this SR2 dry shaft error, that's the same as whether it's timing or the ETM. But this is going to be the first one. This is going to be for timing only. But the ETM will kick in as well. But this is only going to show you just the timing based error curve right there. Okay, that's what that guy is. Because most guys typically will do timing first, then ETM on top of it. So, Doug, can you see that or no?
Yep.
Yeah. Okay. Okay. So the traction control is definitely its own beast. I mean, obviously, as you can tell, there's a lot here. We got some more cool stuff coming with it. I don't actually have everything that I can show you right now. But this advanced curve, real quick here, I can just show you here. Basically, when you enable this guy, we're gonna have it to where basically it's gonna monitor, okay, the acceleration rate of the dry shaft, and there's going to be some stuff going on in the background to where, okay, now we're actually going to have the ability to control timing based on the acceleration rate of what we're seeing. So it's almost in a way going to be all fully automatic. There is no curves necessary, because once the dry shaft rate starts to take off, it's then going to say, oh wow, I'm accelerating too hard, just pull much timing out. So it's going to be really cool. It's in testing so far, it's actually worked really well.
So it just picks up the drive shaft, picking up speed quicker
That's right.
than it should.
Exactly.
I figured out how to make the table, or you know how you made the line come up?
Yeah.
And you could do the graph, the three beside it. Now I can't figure out what I did again.
Okay.
Can you show me real quick?
Yeah. No problem. We'll get that. No problem.
To build the first line, you know how the first line came up and then you were able to build from that line?
Yeah. Here, let's look at it. Let's look at it. Where are we at here?
Who knows?
Go right here. Look, so here I got a program in it, but then now I want to lay down a graph.
Do you have a dry shaft reading on this? If there's no dry shaft sensor, we can't plot anything. You do? Okay. Okay.
But
So-
data log, I don't know which one. These
So
are
we
the
get-
ones that are on here right now.
Okay. So do you have anything labeled like track pass XYZ or whatever? Like, do you have anything on there? That's what we need.
On the old big stuff, we had all that stuff, not this one. 'cause
We
it's
need
all
it here.
new.
We
Okay,
need it here.
That's why it's not doing it then. Okay, all right.
Yeah, we need it here. Yeah.
Yeah, 'cause the
Once
old
you-
one had it all.
Yeah. Once you get that, then we can start building all this
Okay.
stuff. Yep. Yep. Pull it out of the EC and then
That's why I was
we
wondering,
get
I
it.
could see, I can come over here and go like this over here, and I can pull a program like this real quick. Let's say I pull this one real quick, put it in here, open, come over here, go over to SRT, come right here, go over to drive shaft error table, bam, and come in here like this, you know what I mean?
Right.
It should have that line that goes through, right?
No, because if you don't have any dry shaft data to work with, we can't plot anything.
Okay.
Got to get that in there.
Okay.
Yep. Yeah, we can do it for sure next time.
You need to clone about 80 or so, Benny.
Let's make it 20.
Yeah.
Yeah,
And then-
let's just do that.
So you know, on the G meter side.
Yeah, no, I mean that's the thing is, you know, when you're building these curves, that's the whole point is, well, number one is your dry shaft sticking, but number two is what's your G meter doing? So, you know, again, in this case where it's going up and down right here, you know, is that a function of, because it doesn't look like the actual tire's breaking loose too bad right there on the dry shaft, but you know, is that just the boost oscillating up and down? You know what I mean? But
What should we speed for what it looks like a good pass and a G.
As high as possible, as flat as possible. That's what you want. That's kind of oversimplifying it, but basically you want to accelerate as hard as possible right there, and you basically want to hold as long as you can. That actually really isn't too bad. It's not too bad at all. So again, like a pro mod will see 3.5 to 4. Okay, so this thing got up and went to about 1.6, 1.7. So this is not a pro mod, obviously. I'm showing you guys. Yeah, but that's what I'm saying. That's pro mods get after it really hard. I mean, they're going 9, 80, 60 foot, everything else. Everything else, it just really depends on the car, the tire, how much horsepower you're making. But ultimately, that curve, you want this to get as high as possible, as flat. So in this, for example, you definitely screaming to me, it wants more power. Whether it's leaving harder, whether it's leaving with more boost, you know what I'm saying? It looks like it just is begging for more power here. So that's what the G meter shows you. Obviously, if you go out there and the drive shaft spikes up, the G meter falls off, then,
So if you're at like a 1 flat 60 foot,
Hmm.
you should be 3.5.
you should be around 2.5 to 3, somewhere around there. Yes, at a minimum, somewhere around there. Yeah. And that's the thing. If you're not, okay, well, what's going on? But the 60 foot obviously will tell you if I'm at a 110, okay, I'm not going to be nearly as fast in the G meter. But the guys that are really getting after it are 3.5. That's
G meters where on it, on ground?
so you need to look at Excel X, Y, and Z. And again, however your ECU is oriented in the actual car, one of them is going to be that axis. So, but you got to remember, you got to apply a smoothing factor on that guy. If you guys remember, I did the smoothing factor, just 32. That is our Bible. So, and again, left click over it, field smoothing factor 32. Okay, for the G meter. Okay, that's what you want. Let me pull up another log here.
If you have your computer like at a slight angle in the car, that just gives you a funny reading, but it'll still give you the curve.
Yeah, it'll still work. It's not perfect,
You're not going to get that, which we were just talking about, your 60 foot too.
Yeah, it may not be down to 100th of a G, but the goal of accomplishing a G meter curve will be there. And ultimately, if I put more power in, you'll see it go up. If I take power out, you'll see it go down. It'll still work. It may not be optimal how it's mounted, but it'll still work. Yeah. So, let me see here. Let's see if I can curve here. All right. So, yeah. So here's an example right here of first gear curve, engine RPM. Let me get a G meter on this guy. So on this vehicle, it's not the same as the one I was just working with here. So, okay, and this is actually a good example. This is the one I wanted to show you. So right here, let me come over here, okay? You see how this G meter actually goes to negative 1.4? Okay, I'm gonna show this. Okay, you see right here how this G meter actually is going negative, going down, okay? That's very simple. It actually is a positive 1.4 right there. It's actually positive. It's actually not that bad of a curve. See, if you actually look at that, it actually holds it pretty good, okay? Now, this is a very easy fix, okay? It just shows, oh, I've got to set the accelerometer the opposite way, okay? So all you do, system, pressure sensor configuration, right here, accelerometer signs. Just switch them. Just switch all three. That's all you do. And now that next run will be positive. That's it. That's all you gotta do. Okay.
That's good, so it didn't have any drop off after the initial.
Right.
What it looked like on that graph too.
Yeah, exactly. So you can see here that it launched and it actually it keeps going up. Now right there, okay, so let's just talk about right here, right? So we picked up, now right here it fell off, but look, the engine RPM fell off too. Okay, so right there is basically where either, it ran out of power, it got a little fat, you know what I'm saying? But this is, yeah, this is the first gear retard curve right here. So you can just see here that, maybe at this point in time, it wanted more timing in or something, because it actually took some timing out. This is actually right here is 29 degrees of timing. And then over here, it actually went back down to 28. So it actually shoved some timing in there. So we were trying to probably get some power in there because we saw it falling off a little bit, right?
Second graph too, for the SR2 desired, that, also, those parameters also uploaded with this, data log that you pulled up.
Yes, this pulled up the dry shaft from this log. Yeah, so you can see there, okay,
About the table values.
The-
on the bottom.
these just stayed whatever's in the calibration.
Okay.
Yeah, so in this log, for example, this is way higher than the previous log. Yeah.
It's pretty cool knowing that you can just pull up the log and that automatically populates to what.
Yeah, if you have this SR2 timer RPM toss, it'll do it every time. Yep. So you can see here that right there, we had a crazy blip for whatever happened here on the dry shaft. You can see that crazy acceleration right here for whatever reason. And what's really interesting here is the G meter picked up along with it. Now,
Locked up converters.
well, if you look at this guy here, this is where it's a classic case of the guy wants to rev the engine out to the moon, but are you really making power up there? Right? Because as soon as he shifted, look at that, look how happy the G meter got and everything picked up. You know, a lot of guys they think RPM over time. I get it. It's definitely a good way, and sometimes a lot of these engines don't want to go that high. So if you go way up piles and you come back down and you accelerate more there, maybe it doesn't want to go as high. Maybe you want to shift a little sooner, right? Because if you're losing, if the G meter is flattening, you're not going as fast as you can be. And as soon as you shift, if it comes back in and starts hauling ass down here, G meter picks up, my dry shaft sensor picks up. You know what I'm saying? Now, this is a perfect example of, am I hooked up here? Well, that's what I'm saying. You're obviously running out of power, but but right here, can you tell if I'm actually hooked up right now? I mean, we're obviously looking at a log of a car right now, but do you think we're actually hooked up going on track? Are we doing any kind of spinning right now, do you think?
No, because if it was spinning, it'd go up and down more. wouldn't it?
Exactly. Right? The G meter is happy. Look at the G meter. Yeah.
I think it's hooking.
You're feeling that in your butt.
Yeah, you're hooking.
Right. So now if we shifted right here and maybe, you know, on the shift, something happened, well, the G meter would do what? It drop. It drop off. So this is where this data shows you it's totally happy. And then as soon as we shift again, the G meter holds nice and steady again. It's that red and it holds nice. And then it starts picking up again as you start accelerating. So again, you know, G meter is priceless, you know, the data that you can learn from when you start picking it apart. Exactly. And that's a great thing. It's built in. You guys got to use it, you know? And the gyro, remember, this thing's got gyro also. It's got side to side. So, you know, you can also measure lateral. If that thing starts getting out on you also, you can pop an output, pop a chute. That thing's getting sideways on you or something, you know? Use the built-in gyro feature. It's there for you guys, you know? But this is a good example of you know, to me, in some ways, I don't think this combination wanted this much RPM. You know, I mean, you may want to shift down here closer to 8,000 where it's still hauling ass. You know what I'm saying? It may not, and it may not drop RPM as far here too, because look, it was going down to 6,700. But the beautiful thing about shift points is most converters and combinations will actually come back down here no matter what. So if I was to shift at 8,000 for this combo, I'd probably still come back down to 6,700, but I would be at a higher G for longer. You know what I'm saying? I wouldn't be falling off. I'd probably pick up higher and go faster just by using that information right there. Now he wants to test all this stuff out. You got it all. It's all. There it is. There it is. So, yeah. So this is, again, this is a good representation of, now let's just see what the ETM is doing here. I want to see if we're writing ETM on this guy or not. Let's see here. So ETM torque stage. Okay, so right here, okay, when you're on the rev limiter, anytime we're rev limiting, okay, there's your ETM number. Blah, 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 we're banging on it, but this whole way down track, okay, we're on a 31. Okay, so that error was nothing. And right here also is the ETM error table that we're working with. Okay, so remember how we have the ETM error? If we go over, we start pulling out power. Remember, if that was a negative number and we had ETM values that went lower, we'd start knocking out spark. Okay, but our desired is 10,257. we're nowhere near a negative value, so we're going to be at full power. Okay. And then for the SR2, we're at 10,000, 3418. We're nowhere near pulling out any power. All right. Another good thing which you guys should do, especially with drag races, for the torque converter slip. This can show you if you're in the general ballpark of where you should be converter wise. So this actually wasn't too bad. You can see here that all the way out, we're almost basically 0% slip. I mean, it's going in overdrive on that car basically. That's pretty good right there. So, you know, that's also a good number to help dial in the application itself as far as drive shaft goes.
Is that a calculated?
Literally found
value?
out.
Yes,
So,
it's calculated. But that's pretty, I mean, I don't necessarily know if I trust it, but I mean, it's showing 0% slip. You can, it's basically saying it's locked up 1-1, and it could actually be a little bit overdriven too.
And that's on your converter slip?
Mm-hmm. Yeah, TCC slip, torque converter slip. So again, the SR2 section is definitely its own beast. There is something down here which we can get into a little more. It's called the roll race error curve, and if you guys have it, basically all it is we basically install a little connector on this side, and it's awesome because it looks at the front wheel speed versus the rear. So if the front, okay, and the rear start to deviate and you start to see more error, it just simply applies its own retard. So again, not only can you have a first gear retard when you leave, you're riding the curves as well, all the ignition cuts going on. But if this is also seeing spinning, you can also pull timing based off this as well, right? There's a ton of ways to power manage with the box.
What if you wheelie?
Right. If you wheelie, Nope.
Like, I know some boxes have a wheelie control setup.
yeah, we do. Yeah. So, but well, no, you can, and so
Boosted.
no, that's a great question though. So if you come over here, okay, and we do strip, you can set a delay so it won't look at it for 2, maybe 3 seconds. So I work with, you know, back of the track no prep guys that literally have nothing out there. So yeah, they will launch and do as best they can, wheels up, right? But then we'll say, you know what, in 3 seconds out, then enable the front to rear check, right? So now we're basically saying, okay, wait 3 seconds. But again, we can also do it so that out there in the custom port editor, I can say, you know what, I have to be going so fast. I have to have a certain amount of boost. I can do all those different conditions also to enable it. So you can configure any which way you want to actually come back on. But like, we did a lot of racing up in Reading for a few years, and with Frank, with Frank Harder, and we had this in place with all the power management stuff. And I mean, we literally had like negative timing going down that track sometimes, but he beat all the big tire cars that year. He did really good. And it was small tire. He was 2010 and a half versus big tire cars. And we had all this stuff in place and just rode everything and went down every time. Because it all stacks together. It all works together. You know, it all has its own operation, but everything works together to keep drilling the power down to keep you to where you have to go. You know what I'm saying? So this works really well. The only way that we can install it though is if we actually have this pigtail here, because we have to install this to actually have the inputs work correctly on the ECU. So if you don't have that installed above the SD card, then you don't have that available to you. So, but it works incredibly well. It works really, really good. So
We haven't even gone over shock sensor.
I told you, man, it's a lot. It's a lot of stuff in here. So yeah, and where we're gonna really totally geek out here is like on the advanced curves. This is what's coming next, is that you're gonna have all 9 different now. Because before we were stuck with just 3 of the plot curves. Now you're gonna have 9. So now we're gonna have a lot more to choose from. But again, this is where I still go back to the touchscreen dash offset, you know, to be able to just simply put an offset in there on that curve you have. You know, again, unless you got some really good notes as far as whatever number you're choosing, you can just simply apply an offset and just do whatever it is you want to do. Okay. All right. So as far as the logger goes, guys, too, when you're in your project, I just want to make sure you understand that when you're inside here, the data logs all stay in this folder. Okay. So everything in here, if you just follow the file structure, I get guys, hey, how do I send you a log? It's really simple. It's in your documents folder, Gen4 projects, ECU serial number, data logs. Everything is stored inside here. So if you ever want to send us a log, okay, everything just defaults inside that file. Okay. Alex, you there? You come here real quick. You just go fire it back up. So we're going to kind of jump ahead of this stuff right here real quick. I want to go into the data logger because the day is already flying by and I want to make sure you guys get this. So the first thing that she's actually do is, because we've been changing this stuff, it's going to go, what do you want to do? Right? So what's that? Yeah, exactly. So we'll have to figure out what we're going to do. We'll see if it's that much. All right, so are we going to send or are we going to use? What do you guys want to do? Use, okay. So before we just go through it real quick here, again, with the full version of it right here, it's showing you what's pissed off, right? Everything here in the yellow. Hey, we got 3 here in the project, right? But out there on the controller, I got this. Right? So it's blinking actually telling you what it's so pissed off about. Now we haven't sent or done anything. Right now it's just using what's in the ECU while it's running. We haven't done anything to it. I think everything we've done offline has not been sent. So if I went to the next page.
You said ECU's on the left and laptops on the right?
Yep. So right here, current BigStuff Gen4.
Laptop's on the left. So,
Correct.
the way it says BigCom in the top left corner.
Yeah, I just saw it now.
And it says BigCom there.
Yep.
So that's the laptop, that's the laptop. That's how I remember.
Exactly. Yeah.
It
And
says BigCom on the screen, then that's the laptop.
exactly. And then it says settings in BigStuff Gen4. And this is the controller settings here. So it lines up on the right column. But if you don't have this full version, you don't get all this stuff flipping you off telling, hey, what are we doing here? You know what I'm saying? You just get a little box and it just shows you that, hey, these sections have been changed, but it doesn't tell you exactly what's different.
That only comes up when you're plugged into the car, right? When you're plugged into the ECU.
Correct, because now we're going online with it. So now that we're going online with it, saying, hey, what the hell's going on here? We got this in your laptop. I got this in the ECU. What am I doing? Okay, so let's go to the next page here. We've got 7 pages, it's not too terrible. So what's the next page at? Oh, okay, it's the curves, all the curve stuff I had done, right? Yes, sir. Let me open this up. Sorry, bud.
Sorry about that.
No, you're good.
So that's there, that's showing you that's all pissed off. We'll go next here. All right. So again, more stuff it doesn't like on these curves here. So again, it'll tell you everything that is different. I'm just trying to see here. It doesn't tell you the best. We can show this was -12, that's 0. So
Scroll down, show.
yeah. So grab this. It'll take it down. It'll just show you even more stuff that's all different, you know. It's kind of condensed though. It's just saying, hey man, in these areas, all this stuff's different. What do we want to do here? Okay. So what I'm going to do is I'm going to use if I want to take the ECU data in, which one do I use? Controller. Yes, controller. So now I'm going to take controller. Okay.
Means you're erasing all that shit that you changed.
Exactly. So now we're going back to what's in it. Okay. Okay. Now this is important here. Okay. A restore point has been saved. So what that does is it actually saved what we had built before. So you actually didn't lose everything you just did. Okay. It actually created a restore point back to what we just actually wrote over. It's kind of cool. Okay. So there is a restore point now.
Sorry, can you show us how to get to that restore point?
Yep. So now, okay, now we're back on. Everything's normal.
So none of the changes took place, right?
That's correct. So now we just took everything back in, just erased everything over. So remember, how do I know if everything is synced up between the laptop, your computer, and the PC? Is this, right? If there's anything different, that will be red, right? So I took everything in, everything synced up, it's all gray. So now everything in my computer versus the ECU is all the same, okay?
So if something was changed and you missed it on the field, that would say burn.
Exactly. Now, the only difference to that, I'm going to show you guys so you don't get confused, but what's that? Right? is over here. If I go to the custom port editor, okay? Let me open this up. Come on, baby. All right. So, okay, I just simply chose something and then went turn red. This is a completely different section of it, of the ECU. It's really an advanced part. So if you just do something in here, even though we didn't do anything, change anything, it says, hey, what are we doing? This is a very advanced part. So you guys probably won't be here too often, but I've had guys call me this and say, no, if you just simply touch anything in here, it gives you this, okay? Even though you haven't changed anything, okay? It's a very sensitive area, I like to call it. And so don't sweat it. Just hit burn. Even if you didn't do anything, it'll sync up, close, and then you're back to normal, okay? I just wanted to show you that. But in general, if for some reason, if you do see that button red, okay, that means that there is something different, okay?
What's the restore point again?
Yeah, so let's go over here. So file, okay, right here where it says tune restore points.
Why are EDT so low on that one?
That's the hole I heard.
Oh,
I think that's the hole that I
that's it.
heard. Number 6, yes.
Safe it said.
2, 4, 6. Yeah, third one back, I think, is that one. Yeah. I think that's the hole right there. So file, tune, restore points. Okay. So now these are basically restore points that it actually shows of ones that it's actually saved of various times. So it'll tell you date and time. So typically it'll make a restore point when you're making a pretty big change so that you can always go back. So if you're not in the habit of actually saving quite often, it's nice again because the full version will actually do it for you.
But load it back up, or we'll let you view the change.
So right here, compare to current.
Okay.
So it'll go through and basically exactly. So again, that's what the full version of the software will give you, is when you compare it to the current, it'll go through the differences. Now there could be a lot of differences here. I just hit that. So, but that's how, when you pull that up there, it'll go through. This computer may be pissed off. That's a lot of data potentially it's going through right now.
So the tune restore points are the previous save or the previous map that you did
It's the previous.
before you went in, but before you started, it's the one.
There's nothing in there. It was the same. Nothing popped up. I'm sorry. What's that, Dana?
Technically, it's the one before you started.
Yeah. So it's automatically saving. So back on
You
July
select-
13th.
Select that top one, will
we
it
have
show
all
you that
changes.
7-page, think that same 7-page we just saw? If you compare to current?
Let's check it out. Settings before accepting controller values in difference report. I don't know if while it's running, it may get pissed off. I may have to do it offline.
But that top file, that's all the changes that we did after lunch
Mm-hmm.
that never got sent to the CU, right?
Correct. Yeah, that's what it should be. I think because we're running, it's all pissed off. Because I know offline, when we're offline, it works fine. I just think because we're online doing it, that's why it's all mad. But you're right though, Steve, it's got 10% in there. One thing before we get into the data logger, this guy right here, okay, engine state. So basically this guy right here under normal running conditions is going to be 4. All right. If you're accelerating or decelerating, closed loop is going to turn off. So go ahead and whack it a few times out there. Okay. So right now we're in closed loop. I think we're in closed loop right now because the VE calculation is warming up. So we're naturally pulling some fuel out here, and that's why it's actually shoving the fuel back in. So she's going to rev it. Watch this number and then watch the correction here. Okay. Yeah, it actually sounds pretty good out there. We'll go out there next. Okay, see that? Okay, see the state changing? Okay, closed loop turned off. It happened really quick. When we accelerate, we turn off closed loop. Okay, because it's depending on the acceleration enrichment tables to actually take care of that function. Then when we get back to number 4, that turns back on. Okay, so what'll happen is you have a noisy TPS sensor, and if you're going down the track, we'll get a call, hey, my closed loop's turning off and on, or it's not working. Okay. Well, this is going 4, 5, 6, 4, 5. It's changing all the time. So the closed loop's doing exactly what it's supposed to do. It's just that the TPS sensor itself is showing some movement. Okay. So if you ever do see this turning off and on, check that. So number 4 is normal running condition, and that's where it should be when it is normally running. Okay.
Is there a list of those in the directions?
Mhm.
Each engine state?
Mm-hmm.
Each state of it?
Yeah. So 4 running, 5 is acceleration enrichment, 6 is deceleration enrichment, and 7 is decel fuel cutoff. So for street car guys, if you're coming down to a deep vacuum coming off coming off an embankment or whatever, you can actually have the fuel turn off. That's state 7, and then there's no fuel injection at all. It's on decel fuel. Okay, you're in a deep enough vacuum to where there is no fuel being added because it's just coasting down. You slow down enough, and the fuel comes back on, and then you're back in state 4. Okay.
No 1, 2, 3.
No 1, 2, 3. For everything 4 is just a 4 and up. Okay. So I just wanted to show you that there, just on the screen, that's how that guy works. So, all right. So now we have 10% correction going on here right now. So what are we going to do now? Let's add a little bit of fuel. So if I go back to my tuning and dyno views, is it going to take a lot of fuel to get this thing back down, do you think? So I mean, I'm almost at my target. Let's go back up here. Do you guys remember how to actually? So right now I'm looking at lambda, right? If I want to make this AFR, just right click, base system IO, right bank AFR. Okay, 13.9, 13.8. So I want to be around 13.5, right? Which is why it's adding the fuel. So right click again, left click here, AFR. Okay, so now let's come over here. It's probably not going to take that much. So I'm going to simply add 2. Okay, now I've added 2. There it goes. And now we're coming down. So maybe one more to make it happy. But it's more than likely just as this warms up, it naturally just pulls fuel out of the actual cylinder itself based on VE. Okay. So it's doing as it's supposed to do. The guys that are in pro mod mode, they don't got to worry about this. So we'll go one more. Now we're within now a little bit of negative, right? So it doesn't take much. Okay.
What about 4, 4, 2?
Yeah. 4, 5, somewhere around there, that should be good. Because again, if a lot of guys are on alcohol, they're not running any kind of cooling systems. So you're trying to use some methanol to get the heat out of the engine too when you're idling. You know what I'm saying?
The only reason I rerun the water system is just to block same temperature.
Yeah, that's good. That's fine.
I run the old ice tank. I just circulate the water through there.
That's fine. Water's totally fine. Okay, so now we're back there. You can see the correction is good. Again, we'll see if it keeps creeping up there and if it slowly starts pulling it out. Okay. So other big thing that we got to worry about here is your data logger. So like I said, in this here, we're set up for advanced apply. When you see anything that says advanced, that means we're over there in the custom port editor applying how the logger starts, okay? Most guys are going to be here on application a 3-step if you're a race car guy. If you're a street car guy, you can set it up any which way you want, okay, to record every time. So application a 3-step, I hit the 3-step, I floor it, I'm going to record a log. The engine does not have to be running. Okay, it meets the criteria, right? The 3-step is true. I went above 15%. I'm going to log. Okay. If that's how yours is configured, then yes.
I've been playing with it in the garage, so it's just logging what we're doing lately in the garage, sitting there.
Exactly.
You're running the car, we're messing with the trans brake and the bump button.
Yep.
Remember?
Exactly.
So
exactly. Okay, so now if I come over here, how the logger works, it's very simple. So it's going to read a bunch of files. There's probably a lot on here. Okay. So anything here, okay, that says megabyte, okay, all these files here, these are all good files that are about 4.9. These are all data logs that I can look at here, okay? It's an 8 gigabyte card. So you can see here, we have nowhere near any type of limitation basically, okay? So the way that this works is again, this is an update in the next log. This is actually going to say SD card ready. The highest file is actually a check-in file. This is just ECU saying to the SD card, hey, SD card, are you cool? And then the SD card is saying, yes, I'm fine. That's all this file is, so ignore it, okay? Next update, it's going to say SD card ready to not cause the confusion. The next highest one is your latest log.
You have to be connected to the car to pull that up.
Because it's stored here. It's stored there. So this file right there is your newest log. So unfortunately, I wish I could put a time and date on these logs, but I can't have a time and date in the ECU. I tried. I can't do that. So what I recommend for race car guys at the very beginning of the day, just wipe everything out, start over fresh. As you do each pass, whatever you're doing, download them at that time. Then when you download in your laptop, it's going to record a date and time on that file. And that way you're keeping track of that if you're a race car guy, okay? If not, you're a street car guy, you can just get the files whenever you want, okay? But I've loaded gigabytes of data on this thing and it just stays. I mean, again, that's the good thing about having the card. It doesn't go away. It's on there indefinitely, okay? But basically, just to not cause any confusion, ignore the very highest one here for now. Our next update is going to show something so it's clear. This next one, this goes newest to oldest, okay? So the oldest file that we have on here is obviously going to be the very top one, which is this guy here, the 0. So as you just keep making files, it just keeps marching them back. Okay, so that's how you know which is your latest file to pick.
If you delete all those, does it start back at 3 zeros or is it?
Yep.
So you're saying just delete those every race and then start over again?
Yeah, so right now I'm just gonna hit Control A. Okay, so right now I can do Control A and select everything. I can just highlight a group, but basically if I want to get rid of these all at once, Control A, I can hit this red X and it's gonna say, hey, are you sure you want to delete all the following files? I'm gonna say yes. And now they're all gone. So now the card's wiped clean.
So where did you control A on this, controlling the name?
Exactly, because
That
I'm on.
comes from this, right?
Correct.
I
Well,
never knew that.
I'm online with ECU,
Okay.
so you can't do that. You can't
No,
act.
no, I know, but where did you learn to control A? Is that?
That's just basic Windows crap.
Oh.
Yeah, Control A is Windows stuff. Control All is what you're doing. Okay, just basic Windows stuff. So now there's nothing there, but if I was to hit refresh, okay, refresh the file list, okay, okay, there's my little check-in file. Okay, so again, we're making this say, instead of this just say a file name, it's going to say SD card ready to take the confusion out, because we have a process internally that's making sure that card works, because the number one thing as data guys, we want that data. So it'll say SD card not ready if there's something wrong, okay? Not that like there's everything. We never really have any problems with the cards ever. We had some problems in the very beginning, but for the most part, they're pretty bomb-proof. But that's just a file that'll let you know, hey, something's wrong, okay?
You gotta hit the restore or will it come back on if you key off?
What's that?
You said you gotta hit the little button there to get that to come back up.
Yeah, so
If you don't hit that button after clearing it and you shut the car off, come back on, will that automatically load that?
yes, yeah. So when you come into this process here, and if there's files there, SD card browser, it's going to start browsing for you automatically, and then it'll show you the files. So again, the biggest thing to just remember is that the highest one above that little guy for now is your latest one. And again, every time that criteria is met, okay, is when it's going to start that log. I'm sorry, over here in the replay config. So again, in this case, application at 3-step 50%, it's logging every time. Okay. Now, if you're doing a log, okay, if you're doing a log and you activate the process again, it ain't gonna listen. It finishes it first, and then it comes back through and looks for it again. So if during this 20 seconds you hit the 3-step again, hit 50%, it's not gonna start over. It's gonna finish the process, finish it, write the log, then it's looking again. Okay, just something to remember. Okay, just because I've had guys like multiply bump at the start and all that kind of stuff. I'm like, well, it started the recording when it was supposed to, and it's not going to finish until it's done. Okay, so again, for most street car guys, you can do that, but I'm sorry, for race car guys, if you want to do it, based on anything custom you can have the old school. Remember the DAE trigger wire, you have to flip that on with the old school Gen 3 box. You can have based off that if you want, but then again, you could have it based on RPM, manifold pressure, mile an hour if you're a street car guy. You know what I'm saying? It just all depends on how you want to do it. But every time, yeah, you just configure it. And again, for most race car guys, it's TPS, application of 3-step. And then, so again, that way, when you're actually on the brake or you're on your launch or whatever you're doing, you're seeing what's happening during that process.
What's the usual TPS then, 15%?
It could be anything, you know, it's just your personal preference. I've got guys to where they'll hit the trans brake and I got to give it quite a bit of throttle to back up. They don't want to start, right? So they'll make that 50, 75%. That way the log doesn't start too early every time. You know what I'm saying? Just depends on your application.
Is there a maximum time to log?
Yes and no, but I mean, it'll tell you. So if I come over here, so let's just say I make this 600 seconds, say it's 5 minutes. So
Okay.
5 minutes is the max. Okay.
Once it's logging, is there a way to tell it to stop? Or
Nope.
It's gotta run at 5 minutes?
It's going to go. And what'll actually happen is, so let's just say you have this set for 5 minutes. I'll put it back to 20. Okay. If you turn off the ignition, it's not going to be a valid file to look at.
Right.
Okay. So if you, for example, okay, it needs to complete. Okay. But what's going to happen here is, okay, let's just say you're a pro mod nitrous guy. You're going through the traps. You killed ignition. Don't worry about it. This is still going to go. So let's just say it's set for 5 minutes. It's staying on and you started a minute in, you turn off the ignition. Well, it's for 4 minutes. It's going to stay on and keep logging. So whatever this is set for, it'll actually keep the ECU alive.
I used to log in the pits in my car was parked 10 minutes. Sometimes I could turn it off and be logging it in.
Yep.
Come back to it.
Mhm.
20 minutes of logging? What the heck?
Yeah. And what'll actually happen is that you'll actually turn off the ignition, but if you actually leave your computer hooked up like this, you'll actually see the ECU staying online. It's like, why is the ECU staying online?
Well, that was not the big stuff. That was my other setup before. Like sometimes we'd be racing, I leave it on, forget, I go back.
Oh,
and
yeah.
Timed out.
Yeah, well,
and everything, so I left it on.
It's doing exactly what's told to do.
I just forget to turn it off afterwards. I'm going to shut it off and I just feel happy.
Exactly. But that's where, like, I've done a lot of offshore boat guy stuff, and like literally we'll set on advanced apply over like 20% throttle and we'll set it for 5 minutes and we'll just go out there and as soon as you wax the throttle again, it's recording for 5 minutes again. We're just recording a ton of data just to go out there and stuff. Then
Like road racing,
absolutely.
Oh, shit.
So like
Yeah.
a road racer, he could get it out of each turn when it hits the throttle, it turns
Sure.
RPM and it takes off and starts.
Mm-hmm.
Okay.
Yeah.
Wow, so you sit up for a certain time, slow down, and then get another 5-second freaking.
Absolutely. Yeah. Anytime that criteria is met, it starts.
Okay.
And as long as it's able to finish, it'll make it a good log. But if for some reason, if the main power was turned off, then the log's gone. Yeah, the log has to finish up, complete, set, looks again. Okay, I'm starting again, and it just starts. So
Crash and hit your cutoff switch, you're probably not getting.
exactly. And that's actually happened quite a few times. Where's my data? Sorry, man, it's not there. I'm glad you're alive. You know, it's like, hey, that's a good trade-off. You know, I want the data. Like, yeah, it's gone, man. Sorry.
So, the way I wired my car was that the big stuff is directly to the battery.
Yes,
But
good.
like the ignition and the cranking, all that is obviously off the power that goes to the cutoff switch.
Right.
So if they get the cutoff switch, the car dies, but the computer should still have the power, like just the 12 volts that it's plugged into at the battery, right?
Where are the main battery connections at the battery or
They're at the battery, not at the cutoff
Because
switch.
mine said battery too.
yeah, so if you're at the battery, technically if they hit the kill switch, the ECU can still stay on, but that's only if the ignition switch actually has
the
power.
switch is only on to where the power switch goes.
Yeah, if there's no power on the ignition, then the ECU is going to shut off.
Turn the ignition on to turn the ECU box on.
Correct.
But it'll continue logging. It'll just kill. them.
Correct.
Yeah,
Correct. Yeah, if you're doing a log,
yeah.
you turn off the ignition. If the log is still going, it keeps the ECU alive.
Yeah, because it's wired, power wise. Okay.
Yeah.
Exactly.
So
Yeah.
I should get the log if I crash.
Yes.
Okay.
You will get the log if you crash.
Excellent.
Yeah, we actually just
Do you have like a battery backup? Because because I know NHRA sees something that's going directly to the battery that's not on the cutoff switch is not gonna be happy with that.
So you can, it's up to you if you want to go to the battery, okay? But also if you put the ECU on the power side, the disconnect too, it's fine. So that way we disconnect the the power, then it'll lose main power to ECU as well. That'll work just fine too. We just want to be as close as we can to the battery. So if he's a streetcar guy, I want to go right to the battery. Sure. If you're an NHRA guy, you want to put it on right in the disconnect so that you lose power if you hit it. Sure, that'll be fine too. We just got to be as close as we can to it. That's all that it is. That's all that it is. So, but obviously with that way, it'll kill it. ECU loses main power, then it's done. Right. But if it was doing a log, then it loses the log. That's the only thing. And you'll see like funny numbers, like you'll see basically numbers that'll just show, you know, it'll show like 00K. Like it's just all, it can't finish properly, unfortunately. That's all that it is. But we actually just finished, so we had some guys that wanted the some actual shutdown delays. So now basically we've got like turbo timers and we have a bunch of stuff now to where you can actually keep the ECU alive for our next software update as well. You have to actually cut into the ignition. That 12-volt wire actually has to be separated because right now it's actually controlling the main relay. So there's a little bit of wiring for this, but if, for example, you pulled up and you wanted the engine to run for, 60 seconds, you'd pull up, turn off the ignition switch. It'll actually keep the engine running and then it'll shut down, in this case, after 60 seconds. Okay. But sorry, this is the shutdown delay. You'd have to come over here and click enabled. Okay. And now it'll actually keep the engine running for 60 seconds. But we put some safeties in there so that, only under 5% will it actually enter the process. And if you go above 5%, then we exit the shutdown processes. But if you need to move or do something, it's just, we had to put some safeties in there that in case, God forbid, something happened that, you were driving and you turned off the ignition by accident, what I'm saying, and the ECU wants to shut down. You know what I'm saying? So that's it's just basically for like, I had some turbo timer guys. I want turbo timer. Okay, no problem. So that's what we have this basically to cool the engine down when they pull up. That's what that's for. So we can turn that back off and disable that.
I thought that was like a 90s thing.
I got a few guys that want, I said, okay, no problem. We can put that in there. So that's all. It's okay. All right. So I think what we can do right now is, guys, let's go out there real quick. I want to actually show you some stuff out there. That way you're not sitting down here. Let's go out there for a minute. One of the things is here too is you can only have one laptop or one computer talking to the ECU at a time. Okay. So I'm actually going to disconnect from here. So come over here. I'm going to disconnect. All right. So now I'm not talking to that guy anymore. Okay. And sorry. So now for the recording, you're not going to see some stuff for a while, but it's okay. So what's that? It's got a battery charger on it. Yeah. So for all the big band stuff, like for what you have, again, this is basically what you're going to have. You're going to have an O2 sensor per hole.
I've already got the header built. Chris Hill, I bet we needed it.
Okay. Nice. Oh, awesome. Okay.
Ryan had me put the O2 sensor bug way down low.
Perfect. Okay. Well, that's the thing is that you're going to have with the O2 per hole now, you're seeing everything per hole. And then obviously you're going to have your bank collectors as well.
Right.
Okay. But again, everything you basically see here, it's just an LS, but guys that are making 4,000 horsepower, they're using the same exact coils. Okay. It works just fine. Okay. I want to show you guys a couple things here on the acceleration enrichment. All right. So here's a good example right now. Okay. I'm going to hook up this laptop and I'm going to connect up to it. It's going to be pissed, right? Because I've been doing all these changes inside the front. So what's it going to say? It's going to be like, okay, what do you want me to do, right? Because now I'm on a completely different laptop. So this can happen if you guys got tuners, if other people are looking at it, right? It's going to go, okay, what am I going to do? Now, this is a good example of, this is the base software. So you see how there's no yellow flashing? It's just giving you the box, right? Well, look at that's kind of tough. That's why you want to get the full version of the software. Okay, it just gives you that box. Yeah, it's just saying, hey man, we got 20 settings that are different here, but it's not telling you, it's just saying in these areas, right? So local settings is the PC, controller settings, right? Now it's going to say if you want graphic difference reports, you spend $100 to get the full version. Okay, on this laptop, I don't have the full version. So I'm just going to use the controller settings, okay? All right, so acceleration enrichment is a big one. And that's where when you whack the throttle, see me down, sit over here, okay? So it's really snappy, it's really happy, right? So if I come over here to this section, okay, and go accelerate rich TPS, these right here, you guys, if you guys just use it for acceleration enrichment, it's always going to work. If you just follow these curves right here, everything will work perfectly fine. In this accelerator pump curve, this has to be 0 in this box. It can never be anything else, okay? This is basically the cam profile. As you whack it, all we're simply doing is giving it a nice millisecond pump shot. This is the throttle blade opening, okay? So you'll actually see here as the throttle blade opens up, we give it a little bit of fuel, but then we actually peel the fuel out the more we actually open it up, okay? The air accelerates really fast on opening, but then the air slows down as we open up farther, okay? So what I'm going to do is I'm going to come over here. Now, there's no back button here, right? So I don't want to lose this. So it's the same thing if I open up the table itself. So transient fuel, okay, accelerator pump curve, okay? So this table, these are the same exact tables. I'm just looking at it in a tuning and dyno view. That's the table itself here, okay?
But where'd you go to get that other one? You went to accelerator pump curve, which one did you go to?
Yep, so fuel settings, transient fuel, and then it's listed right there.
Okay.
Okay? So I chose it. So now what I'm going to do is I'm going to piss it off really bad. So I'm going to come over here and I'm going to subtract out 3. Okay, I just took the curve down big time, all right? Isn't happy at all, right? So you can just play with your curves to learn what it likes, okay? And vice versa. I want to make this thing really mad. I'm just going to pump max. It's just way too rich. So again, that'll just basically show you where you want to go. Okay, so that's where I started from, okay? This is always going to look like this. If you guys just build a curve that follows this, you're never going to miss, okay? It'll always work. Just move it up and down. It'll always work, okay? For the other one here, okay, for this acceleration enrichment curve, again, it's the same thing. Just float this thing up and down. It'll work perfect every time. So accel pump position curve. Okay, again, I'm going to take this curve and I'm going to flatten it big time. I'm going to take it way down low. Now remember, this curve, this window, same exact as this. Same exact thing. Okay? I'm going to take this. I want to minus this by 60. Okay, so now I'm pulling out a shitload of fuel. Yeah, it's got the hiccup. It don't like it at all. So you can literally just sit in your car and just do this until you get it right. You know what I'm saying? It's all you got to do. So I'll put this back to where it was. Now it's happy. That's all you got to do. So once you figure out, now again, this is all dependent on the injector size, the fuel type, all that kind of stuff, right? But if you just come in here and just play with these curves, you'll nail it every time.
I think I got to play the curve a little bit.
Yeah, that's what I'm saying. It's just with these, the way that it is, it either wants to go up or down. I've done so many of these now. This is exactly how you want to
I've
look.
done the timing. I pumped the timing up a couple of degrees and I held down lock on the item.
Yeah, that's fine. I'm just saying, just for this here, it's just, you know, it just wants the way that the profile works out. It's always the happiest with this shape. Okay.
Is it gonna change much if there's like dual throttle bodies?
Yeah. Oh yeah. Yeah. That's what I'm saying. But you'll dial it in with this. I'm just saying, as far as how high you want to go up or down.
Right.
It's either going to be, because remember, these are just adders based off of the base fuel table. Okay. So the base fuel table is hunting around here. Okay. I'm idling off that. I mean, my corrections within about 0%. That's pretty good. Right. So there's nothing much to do there. You want to get this dialed in first. And then when you're done with that, you start working on the tip in stuff. Okay. And then based on whatever you need for your dual throttle bodies, you'll just go up or down with these curves.
Okay.
It literally is that simple.
What about the idle?
So the idle itself is simply getting let's talk about that. So basically when you're doing it, whenever you guys get an engine running, your TPS should always be around 0. Okay. So I'm going to turn this back on. And the first thing you always want to do is calibrate the TPS, but that's after you get the engine at the idle point you want. So you use the screw to move it around. And then once it's actually idling good, your throttle may be at 5 or 7 or 10% or whatever, okay? After that, where it's actually idling at a good number, you cal it. It's very simple. So you got to crack the throttle open a little bit more or play with idle spark, all that kind of stuff. But you got to zero out the throttle first. So all you do is 1001, 1002, 1003, 1001, 1001, 1002, 1003, and that's it. So that's the cowling of the actual TPS. That's all you have to do is just 313, and then it's cowled. And then what all you'll do is if you barely touch the throttle, see, I am just barely touching that throttle, and I'm already moving it a little bit. That's how you know you're cowled.
Mine's saying 1.1, 1 point right now.
Yeah, so you got to cowl it.
Okay.
Yeah.
That's why I say it idles great and everything's good, but like it had a little flat spot up, just a little on the hit, and then
Yep.
I put a little timing and it fixed it. But I didn't, maybe I could take the timing back out.
It'll get better if you play with this.
Maybe I could take the timing out.
That's why I like showing these tables, because literally you'll just go up or down and find that happy spot and just work with that shape. It'll work really well. But again, it's when you cal it, I mean, again, I'm so barely moving that throttle right there. And that's what you want, because you want to have even the littlest movement be registering. That way these tables work correctly. Because what'll happen is if you go out here and the throttle isn't registering yet, then all these tables don't do anything correctly. You want to see it as soon as the throttle is moving. Okay. And whenever you guys put a new firmware in the box, we actually wipe out the actual calibration. So firmware goes in, you got to go back and do it. But I mean, it takes 5 seconds, or 7 seconds or whatever. But you just got to make sure that you do that every once in a while. The car will always run. It'll just run not as good. You know what I'm saying? If you don't have the TPS cowled, but it'll still work really well. Okay.
Maybe that's what his is surgery stuff.
Yeah, it's possible. It's possible. Yeah. But with those motors, they're also very sensitive. You got a blow off valve. They got a big blower. It's a small cubic inch. There's a lot going on there. So it takes some time to get them dialed in, unfortunately. What's that on the?
When you change all the numbers, you want to do the whole at one time?
Yeah. So for example, once you get this shape here, this is a very small number. The max number, this is a raw. Remember we talked about the milliseconds before?
Mhm.
So if I come out here, this is a delta T, a delta of time of the TPS moving, okay? So the faster I move, it sees it, okay? And it applies it. See how it goes way out there sometimes? Right there, boom, boom. That's how fast I'm moving it. So it applies more accelerator pump in milliseconds. So remember how we idled around 2 milliseconds, okay? I'm applying a 7 millisecond pump shot if I open the throttle that fast, which is what the engine wants. So yeah, it's applying 7 milliseconds right away. Because when I crack this big old throttle body here, I got small injectors, right? So it's saying, oh man, I need to get a bunch of fuel in this thing to make it crisp, right? Now, if I had a really small throttle body, I probably wouldn't have as much added because I ain't moving as much air. But with this big old throttle body on there, it wants the fuel to go along with it. Okay, does that make sense? Yeah. So again, that's why this, if you get to learn these times, the millisecond, that you guys oh yeah, 2 milliseconds idle. That's almost 4 times as much fuel when you pump it. To make sure it's really crisp and happy. You know what I'm saying? So that, yeah, again, if you follow these curves, so like for example, if I was fine tuning this guy, I would come over here. Actually, I don't want to use that because again, there is no back button here, right? So I'm gonna go to fuel settings, transient fuel, accelerator pump curve. I'm gonna come over here and I'd actually start maybe sneaking it down. So right here where it's 7, I'd make this equal to 5, okay? And then I'd come over here instead of 1, I'd make this equal to 0.5. Okay, now what I'm gonna do is I'm gonna come over here and I'm gonna interpolate now between this. You see this big old hump? You see how we don't want that. We want to keep that same shape, right? So I've lowered that, I'm gonna interpolate. Okay, now I've got that shape back again. So you just want to keep this shape and you'll
less fuel in the injector.
exactly. So now I've got 5 milliseconds total and I'm starting out at a 0.5 millisecond down here. Okay.
Slow down the fuel reach going in.
Yeah, you'll trust me, you'll figure it out doing it this way. Yeah, and that's all you got to do. I've got some cars where literally, especially if they're big monster injectors with gas, I'm at 2 there. And I'm at like 0.1 here. Oops. Equals 0.1. So literally, I'm almost barely any accelerator pump at all. It's crazy, but it just doesn't want it. It doesn't want the acceleration enrichment. It doesn't need it. the base fuel table is almost enough, and that little bit of pump squirt's enough for it. But that's gas with big injectors, right? You don't need a lot of gas with big injectors to accomplish the goal. This is a big throttle body with really tiny injectors, so it wants a lot of that fuel up there when I whack it really hard, okay? But if you just play with those curves right there, you will get it back to where it needs to be, and then back button, and then I'm back where it needs to be right there. That's if I have the window open. Remember, if I was playing with that table over there, you know, you get in trouble. But again, if you get in the habit of also coming up here, file, save tune as, you know, base cal, before you start messing with it at all, you know, this way, okay, I've always got a base cal I can go back to. Like whenever I remote tune every day, whenever I start, I always save a cal no matter what. That way, in case I'm out in left field with this guy, I know nothing about, I can always load something back in. You know what I'm saying? So that's what you always want to do, is just save a base calibration. So now it's saved. But yeah, like I said, I know, again, every combo is different. The other thing is too, is this DTPS noise threshold, okay? What this value is here is, this is basically how, if you're going down the road, okay, here, watch, let me fire it up again. So let's fire it up. Okay. So the engine state is moving all around, right? Okay. So that's me moving the throttle around. I'm going like that. Okay. The engine state is changing. Now that number that I just showed you guys, okay, that number represents how fast it's going to allow that engine state to change. Okay. So 12 is the slowest amount of filtering I can do. Okay. So now I'm going to go wiggle that throttle back and forth and watch the engine state. Okay. It ain't going to change nearly as bad, but watch. See that? I'm moving it around. It's not nearly as, the engine state's not changing as hard. Okay. And that's what'll happen is, like with race car guys, if that thing's moving around a lot, we'll set that as slow as or soft as possible. That way it doesn't catch, because sometimes the car just vibrates so much where you're going down bumpy street roads, your foot's moving a lot. You know what I'm saying? So we don't want the engine state to be changing all the time. So we got to set it as soft as possible. So because what's happening is, every time it goes to a 5, it's doing an acceleration enrichment. It's doing an accel. It's going decel enrichment, like it's doing stuff, okay? So that value is used to set it. Now, if I go to a 1, sorry, 2 is the lowest. If I go to a 2, okay, so now watch it, how fast it reacts. I mean, it's all over the place. Yep. Yeah. So but it's doing exactly what it's supposed to do. It's just, I got on the most sensitive state possible.
You want them to stay within 4 foot.
Exactly. Especially for race car guys. We want to have the acceleration enrichment so that when you floor it, it goes up and everything's good, but we don't want it to be moving around. Okay. So that's why, you know, like the middle of the road, like that's why I typically leave these around 6, so that it basically will stay at that number. That's actually another way to look at it right there, 6. It's the same box. So 6 is a decent number because you're kind of in the middle. You know?
Check it, if your car wants a little, change it.
Yeah, so if you're going down the racetrack, okay, and you see that number changing, moving around, just adjust that noise threshold up a little bit, and that way it'll basically calm it down. You know what I'm saying? Because it's just doing exactly what it's supposed to do, but it's too sensitive.
Got it.
So yeah, so now it should be fast. Another thing is too, when you're doing the acceleration enrichment, okay? So again, I'm used to Lambda, sorry. So I'm gonna come over here, right click, base system AFR. Okay, so right now I'm reading about 13.0. I just put a bunch of fuel in it, okay? When you hit acceleration enrichment, okay, you shouldn't go pick fat. Pick fat means it's obviously a little too fat. You can see it on the O2s. Yeah, crazy. It goes through around 10, but it shouldn't hold 8 or 9 for a very long time. It's a quick little blip. That isn't going to hurt anything at all. I'm just showing you what to look for there on the O2 sensor. If you're on methanol, you see 3.8, 3.5, it don't matter. It's fine. Methanol is a whole nother deal. You just got to go until it sounds and feels real
I
good.
just tune my car by the coolness. That's how I tune it, by the engine temperature.
Yeah.
Make sure it's dry.
Yeah, it should feel crisp when you do it.
Like I could run it all day long, but he passes the pace at 180.
Exactly. Yeah. And again, if you play with these tables, I guarantee you it's going to feel really crisp. It just takes a little bit of time to get. And you'll grab it. It's just those two curves. That's all that it is. So also, if you're an automatic, it'll take a little more playing because you got to load. This thing's freewheeling right now too. Again, different parameters, right? Because it's freewheeling right now. So what I want to do now is I want to go over those offsets in the dash. I just want to see if we got, so we're gray, right? So if we're gray, there's nothing to be sunk up, right? Everything's good now, okay? I just want to make sure you saw that. I always like to just check it before I turn off the engine, because if you don't, next time you turn it back on, it's going to get pissed, right? So come over here. Always turn that off. So now I just want to make sure you guys are good on the offsets for the dash. So I know it's kind of small, but you should be able to see it from here. So basically, when it fires up, you've got a little settings icon here, okay? So if you click on the settings icon and you go over, let me get this brightness up. Okay, so if I come over here to, oops, settings. Okay, these were the offsets that I was talking to you guys about. Okay, so remember on that log I showed you was 2? It's because it was 2 here. Okay, so this is where you basically plot in, okay, which curve do I want? Okay, yeah, I want 3 now. Okay, remember, this wins. Okay, so remember we were talking about the offset. Okay, so this right here, this box, SR2 gear 1 offset. So if I put -2, I'm now 2 degrees off that curve, right? So basically, if I come over here and I come to, I think I chose curve 3. Now, again, it doesn't matter what this is, right? Because I'm on curve 3 inside the dash right there. See it? Okay. So then if I come over to SR2, sorry, right here. Okay. So right now I'm an SR2 ATM gear curve number 3, which is pulling out the 6 degrees, right? Well, I'm now pulling out 2 more. Exactly. Okay. Now, as soon as I hit 10 seconds, though, that offset goes away. Just remember that, because I have guys that, well, does it stay on? No. Whatever is in that time is when this is applied. As soon as that time is up, this goes away.
You have to reset it again.
Yeah. It's just part of it.
Or whatever.
Yeah, most guys will have a curve that comes back up to 0 anyways, you know, at a certain amount of time. But you have to remember that when you're at 0, it's still going to have that 2 in there. So you got to remember that it's pulling 2 out for however much time is in there.
So if you go to the line right now and you're like, ah, track's not good, I'm taking 2 out.
Yep.
Finish your run, get to the pits. 5 hours later, come back to the staging lanes.
Yep.
Is that -2 still in there?
Absolutely.
So you got to take that back out.
Absolutely.
For the next run.
Absolutely.
Okay.
Yeah. Yeah. So I'm just just making sure you guys understand that once that's in there, it's in there. And it's also going to hold it out the entire time. So for example, if I come over to curve number 3 and let's just say here, for example, I put.
You could zero that out though, and right, it will hold it the whole time. Though.
Nope. It's so right here at where it said 4.2, it now is going to be -2 because you're putting that offset on that curve. Remember, it's going to apply. This doesn't care about the time. It just knows, oh, I got to put an offset of 2 in this curve. Yep. So whatever this is set for time-wise, now it's going to be -2 inside here instead of -8. It goes from -8 to -2 because we put that -2 offset here. Okay. But again, this is to fine tune. If you don't want to choose a whole nother curve, you just got to remember that, you know. So if you want to get that detailed, then what you do is you don't obviously make this 10 seconds. You make this 2 seconds. If you just care about for the first 2 seconds of the run, that way at 2 seconds, that offset goes away. You see what I'm saying? If you're racing 8th mile, we're going 450s. Okay, well, I'm only going to have the first gear curve set up for maybe a second and a half. That way, if I pump an offset in there after 1.5, that offset's gone.
So that's losing that 2 seconds after 1.5.
So
Exactly.
you pull up the line, you see everybody in front of you spinning all of a sudden, like,
Yep.
okay, take out for a second, pull something, let rip that.
Exactly. But remember, all that time stuff's set in here. This is just applying the offset.
Be on the dash real quick and plug it in, put number 3 on the dash real quick and put it in and be done.
Correct. But again, if
It'd be running off this though.
yes,
Gotcha.
yes, you just have to make sure that, again, this offset's going to hold to however long the time axis is for.
Okay.
That's what I'm just trying to say. So if you have this thing set for 10 seconds, but you're making a 5-second run, it's going to have 2 out the entire run. That's what I'm trying to say. You have to remember that. Okay.
Does that work on the dash too?
Yeah.
Older dash.
Same thing. Same thing. Yeah. So the other one that I was just going to say too is for the SR2 ETM offset here. Okay. So remember, this is the dry shaft curve, right? So if I wanted to come in here and go 500 positive, okay, now I'm going to be 500 positive of my curve, whatever one I'm on. So now it would get it up high out of the way, right? Now, basically, you probably aren't going to touch if you're going 500 RPM. That's a lot. But, you know, same thing. I could come in here and I could say, you know what? I'm going to go negative 500. I could absolutely just clobber it, right? Because now I'm targeting an offset of 500 below whatever my plot is to ride, you know? And then depending on how much the air table is set up for, it may be pulling out 15 degrees total time and to get you down. It's all depending on how you do it. Okay. So it's, again, you got the power. It's right here. You just got to remember on the back end, okay, if I'm putting a 500 RPM negative offset here, what am I actually, how much am I actually going to kill this curve right now? You know what I'm saying? What if your curve was really high? You had to get it down that low to get to where it was safe. You know, what if you really had something high to work with? You may have to go negative 500. You know what I'm saying? So you got to have some wherewithal when you're doing it. Just punching in some random numbers probably aren't going to get you very far. Okay. The other thing is too is, you're not done yet. Once you actually press this, I've had a couple guys mess this up. When you're done, okay, you got to save it, go back out to this arrow, save it again. When you're, now it's actually written to the ECU. Just because you've actually entered the numbers, it doesn't mean it takes it. Okay.
Save it on the dash.
It's done. Yes. So now the ECU has taken it. Okay. And now we're good. So now let's come over here. So now I'm going to start a log and let's see what the offsets are. So let's come over here. We're going to start a log. Okay, let's come over here. So let's go down to our touchscreen dash offset and look. See that? So now we're 2 out. Okay, we're negative 500.
Yep.
So it tells you, hey, this is what I'm getting from the dash. Okay. And it's the same thing for the desired SR2. So let's go back up here. So right here, desired is 3. My boost map is 1. So obviously if I come back to this here, it'll all match up because I'm on number 3. Okay. So I've had some guys, well, I punched in the dash. I'm like, no, you didn't. You didn't save it right. They'll just come over here, turn off the ignition thinking they did that part enough to save it. You got to save it twice, go back out. That's how we write it down. Okay. But it actually really does work really well. I mean, I race with a lot of guys and we'll come in here and we do a lot of this stuff really, you know, we do it all the time. You just got to remember the base maps you're working with when you're applying these offsets, what ultimately is going to happen. You know what I'm saying? And it's so dependent on the amount of error that's obviously programmed over here in this error table. You know what I'm saying? Based on the amount of timing and everything you're doing here. You know, it's however you have this curve set up. If you have this thing basically pulling, you know, -2 or something, or something, you know, not that much, it ain't going to do that much. You know what I'm saying? So you just got to be careful of that. But
Can you go back to the other screen real quick?
which screen? Which screen? Yes. Right there.
Under what?
That means I'm going over.
Okay.
Yeah. Under, over, higher, under. I don't know why I mean you wrote it that way. I have no idea why. I think he did it just to mess with people. I swear to God. But yeah, if you're under the curve, you're going to see the ellipse will go up here. Okay. You'll see it on the run. It'll go up here. Okay. If you're over the curve, it's going to go down here. So it'll show you where it's riding through. And again, in the log, it's going to show you, hey, over here, right here, SR2 dry, so it'll show a negative or a positive value, whatever you're riding through that curve, whatever it is, it's going to show you right there. So, yeah, Yeah, exactly. And again, that's why if you have it, remember, whatever you're applying negative here, you know what I'm saying, or offsetting here, that's what it's going to do to those curves that you're working with. Okay. So, but again, the biggest thing I can just harp on this guy here is just after you make the change here, whether it's the boost control curve or whatever it is you're doing, okay, you just got to make sure you just save it twice. Okay. Once you save it twice and you're back out to your base default screen, now it's actually saved.
If you don't save it, it'll stay there for the one.
No,
As soon as you back out, it's gone.
it doesn't save it. So you can make those changes here on that
If you
screen.
save it, you should-
Right. So for example, if I just make this number 1, okay, and save it, okay, go back. Oh, sorry. Hold on. Yeah. See, I'm just so used to doing it. So if I come over here, offsets, let's just make this number 2. Okay. And I shut that down, and ain't going to save it.
You gotta go back out.
Back out, and then save it. Then it'll actually keep the data. That's the thing. So we've had guys, again, just make the change there, and it doesn't take. It just doesn't take because they haven't gone through the whole process yet.
Good, right?
Yes. Yeah, exactly. Exactly. Yeah. So here, let me actually show you that here. So right now there actually is no prime shot because of how hot it is, but I want you to actually hear it, what it actually sounds like. So if you come over here to the startup section, the fuel pump prime shot, you'll see here that it's zeroed out. It really doesn't actually like much fuel when it's warmed up. Okay. So we're going to make this, going to give it quite a bit. We're going to put it for 0.2 of a second. Okay. So that's really high. So what you want to listen for is listen for the, and you'll hear the injectors. Basically, as soon as the ignition fires off, they're going to open, and you'll hear just a loud click. That's them all shutting. So the pump will prime, and then you'll hear these things all shut. Hear that? That was it. That's 0.2 of a second. So now it's going to be pissed. It's because it's gas and it's just watch. Yeah. It wasn't too bad. It wasn't too bad. See, it was really fat when it started up though. But again, for you methanol guys, so right now it's going to do it every time. So listen. Hear that? That was it right there. So now if you do it again, it's probably going to start loading up. You know what I'm saying? But
A couple times I'll have water flowing up.
yeah, exactly. Yes. Not too bad. Not too bad. Yeah, so it's clearing out. And again, that's the residual fuel from the prime. But it don't take much though. Again, that's 0.2 of a second. I mean, you know, millisecond wise, that's almost 200 milliseconds. That's a lot of time to hold that fuel injector open. So, but it works really well. Like I said, I got the blower cars now where you don't have to squeeze the fuel in anymore. We just prime that and lights right off. But a lot of guys like to have it thrown in there because it cools the rotors. You know what I'm saying? But on startup, they just feel better knowing there's some methanol in there when the rotors are turning to kind of cool them down. But really, as soon as it fires up, though, the methanol is spraying in there, though.
If they're Teflon rotor, it don't matter anyway.
Yeah, that's what I'm saying. So, but it works really well. So, guys, it's almost 4 o'clock. You guys been here all day. You guys good? I mean, I can keep going for as long as you guys can. You know, it's totally up to you guys. If you guys want to stay, there's definitely more to talk about. But
I just need to figure out that when I talk about my screen, I need to know the pin number.
yeah, so let's do that. So here, let's just talk about that real quick. So over here, okay, under the system pin configuration, okay, right here, okay, boost kick. So we're gonna call this Steve Scramble. Okay, so now we've called it Steve Scramble. Okay,
And that's the pin right here.
header 2 pin
Gotcha.
B1.
All right, then what do I set it to on, I put it into the bump on the bump side?
Yep. So what you do is here. Okay, so now we wrote that. The name's done. So now when you come over here to the boost CO2, you're gonna have boost parameters, and so whenever you press the scramble, it's gonna apply 5 more pounds of CO2.
But it will, I can do it off the bump button though, right?
Yeah, because remember that's a 12 volt.
Yeah, that's what I'm saying. After I'm in second, you know. Right?
Yeah.
Okay.
Yeah, the bump will work fine. It's not going to apply anything. Remember, we only output the bump when the 3-step is on,
Got
and
you.
it sees that too.
Here.
Yeah, so if the 3-step's not on, you're just pressing that.
Okay.
yeah, it's not, the ECU's not gonna pulse because the 3-step's not on as
You got
well.
the Niche, the old school, how we had the race pack, the leash, the big stuff, we had everything, the MSD boxes. I mean, we had
Right.
so much crap going on before. You remember with the big stuff we did, what we wanted to do.
Right,
And now we're
exactly.
just on all one box.
Exactly.
Everything's one box.
Yeah, that's all that you need to be. So yeah, so that will basically do that. And for like guys that are NA or guys that are nitrous, guys that are supercharged, we can do anything you want. You know, we can have a button where it adds timing. You know what I'm saying? We can have a button that adds nitrous. I mean, we just got to know what you guys want. We can program any output to do anything that you want based on input changing, all that kind of stuff.
Like, Jim, you can throw a little nitrous on.
Absolutely. Absolutely. Whatever you want to do. Yeah, exactly. We actually had a guy that just put a 300 shot on, and we just simply added some fuel, took some spark out with some custom tables, and it works great, you know? And what's nice about, you know, just doing all the custom stuff is that we have, so really? No way, huh? Wow, that's crazy. So over here on the stage 1, because again, we're doing a dry shot, we actually had an active delay of almost a full second before the nitrous actually worked properly, because by the time he hit the button, remember, if you pull the timing and the fuel add in real quick, then the motor's going to fall over before the nitrous gets there. So his nitrous took over a second to get there. So we ended up actually putting a 1 second delay. So it just took off and went, because any sooner than that, it killed the motor. It was doing what it's supposed to, right? We were adding fuel, taking out timing. It just takes that long to get there. Yeah, even with it purged up to the solenoid, when you hit it, it just 1001. Then it finally hits. I don't know. This is a street car. The guy he wanted a 300 shot. Okay, it put down almost 300 more to the tire. Yeah, which is fine. But we just had to. That's what these delays are for, though, is to fine tune stuff like that. You know, so it just, for whatever reason, though, it took a second to get everything to meet properly, so the nitrous and everything took off fine. You know what I'm saying? But that's the advantage, you know, of having all this stuff in here, is just doing that. And
you just want to go back to the settings, right?
What's that?
To get back into where it said the pin number.
Oh, yeah. So here, let me just turn this back off. Put this here. So system pin configuration.
Right there. Okay, got
That's that guy right there. And again, so here, let's do this. So let's start a log. Okay, let's start a new log. So we've got our Steve Scramble input now. What's that? Yes. Yeah, it's coming soon. Trust me, I can't wait either to have it out there.
Say Steve Scramble on it.
Yeah. Yeah. It sure will. So right there, Steve Scramble off on. So
Sorry, why does some go alphabetical and then it starts over again?
because we put all the physical inputs are stuck in this section
Okay.
still. Yeah. So all the inputs and outputs, they still are going to stay over here. So that stays. Everything else is still alphabetical. So anytime he presses that button, whether you're scrambling it or you're bumping, that will go on.
Okay.
That will show on. So, but yeah, it's just long overdue to be able to do the custom naming finally, you know. But yeah, it'll work
now
fine
we know.
that way. Yeah, exactly. So
So with dual throttle bodies, am I gonna have 2 TPF sensors?
no, one,
One.
just
So
one.
one's gonna be blocked off,
Yes.
and then,
Yeah, one's gonna be blocked off. You'll
Okay.
just use one.
okay.
My other question: shift points for my solenoid shifter.
Mm-hmm.
Where does it go
Oh,
in?
sure. Yeah.
How'd you
So,
turn it on? I
yep.
seen it had solenoid on it. I seen where it said solenoid on it.
okay. So right here, system operating configuration. Okay. So all we're going to do here is, okay, this is a great example of right here. This is grayed out. All that simply means is in the pin configuration, something is overriding this. Okay. So this is simply says, hey, you can't use this right now. So come over here to system, pin configuration. Okay. And we're going to turn on the auto shift, which is down here. Okay. See here where it says AS.
Yeah.
I'm turning that on. Okay.
I got it turned on this.
So let's call Steve
Oh.
auto shift. All right. Exactly. So now we got Steve auto shift going on. Okay. So now you're going to see here, this is all exposed. Sorry about the garbled up numbers, but you have a 2-speed, right?
Yeah.
Okay. So 2-speed. Okay. So now we're going to say first gear RPM to turn on. Let's just say 8,000 RPM. You can put a drop in there if you want, maybe 200 or so. And then that's it. That's all you got to do.
Then they'll grab at 6. They'll go with grab at about 7,800.
8,000. As soon as it hits 8,000, the output's going to output. Yeah. Now, mechanically, it may take, if you want to shift to 8,000, you may have to start at 6. You never know sometimes, especially with the 400s. The 400s are really touchy, but with the Glide, it's usually right away.
I seen there was a page that had it said a solenoid on it or the other.
Yeah, that was so
through a air system, right? So
you
you can have it either on solenoid or air, right?
you can do it either way.
But where's that configuration? I've seen that.
It's still the same pin. So the pin itself is still the same. So it's still header 2 pin P2. So it's a ground output. So whether you're gonna, we can control a MAC valve directly if that's what you're saying. You don't have to have a relay that we're controlling. But if you have it like an actual electric shift or electric solenoid,
Yeah.
we got to hit a relay.
Yeah, I have an electric solenoid.
So you have to hit a relay then, which then controls that.
Yeah.
So this ground trigger will control your relay. Yep.
About 40 amp.
Yeah. So just hook that up to this pin
It's already done.
and you're done.
I did. It's already done.
Yeah.
I didn't turn it on, and I was going to test it on the jack to make sure it shifts. I was going to lower the shift points real low.
Right. So you just got to start the SR2 timer.
Okay.
That's the thing. This only works off the race timer. So
Okay.
you've got to lower all your stuff down.
To test it on the jacks.
Yeah. And it's really easy to
Okay,
do.
no, just said,
Yep.
yeah. That's why I was wondering, like, because I wanted to test the shifter, make sure it shifts.
If you have a turbo 400, you're gonna end up with
3. So let's just show you. It's the same process. Okay. So 3 here. Okay. Let's just say 8,200. Now what we also have here is, okay, we have a shift delay. So what that means here is that when you go from the 1-2, okay, let's just say it dropped. Now we have to go down 200 RPM. So that means here is that I have to see 7,800 or below in order to reset for the next gear. If you don't see that, we ain't going to shift. Okay. We need to see that.
At least 200.
Yeah. And we have to have at least a half second delay. The reason why we do this is because for a really loose converter, some guy may say, you know what? I want this to be a 25 RPM delay or something just dumb. Okay. So that means at 79, 75, I'm going to reset because the converter's so loose and it's going to look for 8,000. But we put this delay in there because you'll be at 8,000 right away again, right? Because the converter's so loose. So that's what the delay is for. Okay, so I've got guys that'll actually have this out to a second 1001 before, because we're already at the next gear to shift right away because the converter's so loose. But if your converter is actually somewhat tight, if it drops 700 RPM, you're fine. You're gold. It's just for guys that have real loose converters. So I'll typically set this for about 200. You know, most guys, a half second is plenty. You can take that down next to nothing if you want. We go to 700, we reset. Now the next time it sees 8,000, pushes out again. That's how that works.
They keep his RPM the same the whole time.
Well, it just depends.
A little 200s maybe on it.
It just depends. That's the whole point of you got to get down below that threshold to then get down, and then it then looks. If you don't go below this, it won't reset to look for the next gear.
Okay.
That's how that works. You got to reset.
Okay.
Yeah. Now there's other ways to do it. If you don't want to run it off this, if you don't want to have we can actually use the shift light to control stuff. You know, and just simply output a pulse every time it sees the gear. That'll work fine as well. So there's different ways to do it. Yeah, you can do it either way. Yeah, either way is fine. If you're not using the shift light, you can use it for the shifter as well.
I just want to stop driving it one-handed and put 2 hands on the wheel.
Yeah, exactly. It will, especially with a Glide, it's just one output. It's a piece of cake.
Going this, like your truck. I'm about to put one of those balls on it.
Exactly. Yeah. So this shift light right here, basically, we actually look at the gears. So it's right here, it's set for 2,500. So every time I was whacking it, the shift light was just turning on every time. But you can set up for multiple gears so that if you're actually growing through the gears, it'll calculate the gears and actually give you a different shift light for it. So you can have up to 5 different lights if you want. So it calculates the gear that you're in and says, okay, I'm in second gear 2,800, I'm a third. So it'll know where you're at to give you the correct shift light output for it. So that's how that works. In race mode, though, we just simply say, you know what? Okay, how much RPM drop and we actually give you an adjustable pulse time. That's why some guys like the shift light, because the auto shifter just goes and it's going to hold until it resets.
Is it the same pin though for the shift light parameters?
No,
Pin,
it's a
right?
different pin. And this also sends out 12 volts.
Gotcha.
So some guys like the shift light because you can actually adjust the time, because this is just simply a pulse. That's all this is. It's a completely different operation. So we basically can pulse it out for as much time and then it just drops. Whereas the auto shifter, it's going to hold until you reset. It's two different strategies. Okay. Most guys will use the auto shift because you have enough converter drop. A lot of guys will just simply use this if their converter is very loose or there's barely any RPM drop. That's how this works, because this is going to shift out, hold for 0.6 of a second. As soon as it sees that next one, it's going to go. But you may are within that 0.6 of a second window, you may already be at 2800. So we didn't have that pulse time. It may already be trying to shift again. So it holds it, then it looks for it again. Whereas this one, the auto shift, it's holding until it resets. Glide's a piece of cake though. Glide either way will work because you're just going one gear. You know what I'm saying? For 3 speeds, for 5 speeds, that's when you got to figure out how the training is going to work the best with it.
Gotcha.
Yeah. So, but either way will work fine. But yeah, this is a different pin on the shift light. So, but no, that's a really good question though. So, and then it should be let's go, if we go back and start another log, it should be a new one now for Steve for his auto shift. So let's just go see that real quick here.
I got too many questions. I'm sorry.
No, there it is. Steve's auto shift right there. Boom.
Oh, wow.
Yeah. So you'll have it there. Now, this is obviously log into the laptop too. This is also going to save all these names on the SD card. So when you pull it out of the SD card, it's going to come up that way as well. Yeah. And then if you mail this file to somebody else, it's going to keep those names there too. So that way, in case it sends it to somebody else, it's not going to just keep the factory names. So yeah, it's crazy. I mean, it's been all day. We haven't talked about E85 or extra stuff, which I'm sure want to go into you with, but basically just real quick on these generic sections here, this is where we have some other built-in safeties. We've got these generic PWM curves. None of this stuff can get turned on unless you're over here in the custom port editor section right here. E85 is awesome. You have to have a flex fuel sensor in order to use any of this stuff here. If you don't have any flex, if you don't have a flex fuel sensor, don't even worry about any of this stuff. Okay. If you got a flex fuel sensor, then that's how we run the flex fuel, the gas. You're on 85, right, Chris? Yeah. So he'll have a sensor, and then all these are basically a bunch of different correction curves depending on how much E85 you have in your system. Okay. But out of the box, we actually come pretty correct. Like that's actually our default E85 adder, and it's barely anything at all. We do most of the calculation in the background. So you literally have to add manually anything extra to the amount of E85 you have, which is kind of cool. Other systems, you got to do all these different tables and all this to dial it in. It's basically just done for you for the most part.
I guess we're going to tune it on 91 and then tune it on 5.
Oof. Yeah.
And then it takes those two tunes.
Really?
Decides what the percentages are between that.
Oof. Yeah. We don't do that. We don't do that.
100%.
Oh, okay.
Yeah. We don't do that. Thank God. It's a lot easier. Nitrous stuff, just real quick here. If you this is the progressive. If you turn on the progressive, then you can have basically a nitrous progressive shot, and you just got to just simply fine tune duty cycle,
Really
fuel,
good everything.
yeah, fuel
I
correction.
used to run those progressive controllers back in the day and all that crap.
Exactly. Yeah. No, it's
with pins going in the relays.
yeah.
The relay pins where you pin them
Mm-hmm.
for time
Mhm.
pins on relays.
Yep.
How we start.
Yeah. It's this is a simple setup where it'll add the fuel, it'll pull out the spark if you want, but it just give a solid state relay and a solenoid, and we're away and going. That's all that it is.
Your nitrous on this one.
Yeah. So he's going to be on, I'm sure, a stage system, right? So just bringing in stages.
Yeah.
Yeah. So when you enable your nitrous here, you're going to basically come over here and
You're
you're
gonna
going to,
put out like 3 stages. He's running 3 stages. Where's the 3 stages on?
Third one's gonna be like a scramble button.
Okay.
so that'll actually be custom then.
Yeah.
That'll be custom.
And
Yeah.
then the other two are gonna be pretty much,
You taking off with a 250 and then a 500.
Take
Top
off-
sportsman guy.
take off 2 300s.
There you go.
Yeah.
Bring it on. Bring it all in. Yeah.
Give it all I've got,
Yeah. Why not? But this is, so when you come into your stage setup here, basically you set it, we can have the 6 stages if you want, but advanced, race, and internal timer trigger. You got some basics here for TPS and RPM to activate everything. But then once all this stuff is true, so you'll be totally different. We haven't even got into the actual alpha N, and because you'll actually be on a pounds per hour. You want to leave all measure efficiency. So pounds per hour is where basically we don't look at the speed, the actual density of the air at all. It's throttle position and RPM. That's all that it is. It's very simple because you make no vacuum at all in that engine. Okay. So no vacuum means we can't use volumetric efficiency. So you'd be in pounds per hour, and then we'll have a base table for you. And then as your nitrous comes on, you'll have these advanced tables here that'll basically add the additional nitrous pound per hour per stage. And then you're going to have an absolute number here. So whatever the numbers are here in these different stages is going to be your number. So other areas will be a retard. Whatever we have programmed in when your second kick comes in, that's your number. So that's how that works. So we add in the fuel, we pull out the timing as each stage comes in, and then you're good to go.
The generators just automatically.
Oh, you got it.
No, if he's on, remember, if he's on the big bands, I'm sorry, the rim modules with the 802s, it'll still self-correct. Yeah. So when he's on both stages and everything, you'll be able to go into your individuals and plot it because it'll tell you correction-wise what it wants on both kits. Yeah. So
That's what Brian was saying, because
Yeah.
you're gonna be amazed.
yeah, yeah, it's just awesome technology. It's just, I've actually had those routers that have gone almost 260 miles an hour too. They're just regular Netgear routers. Yeah, Rob Campese now, he's our fastest guy that I know so far. He's been almost over 260 with our regular router. It's hysterical. Yeah, it hauls ass and it's fine. All the tires shake and all the magneto noise and stuff, and it works perfectly fine, you know?
Oh, he's on Magneto?
Yeah, he's on a magneto. Yeah, he's been a magneto forever, you know? So he's not even coil unplugged yet. He will at some point though, I think, but he's still a magneto guy. But yeah, when you start bringing your kits in, you know, again, it'll just still be in closed loop, and you know, like you saw earlier. And actually, what I can show you here is,
So if he brings in his kits, will it keep the AFR that he wants with
Yeah.
the nitrous on?
yeah, yeah. I mean, it's
200 trophies we could build right now for nitrous pistons.
yeah, I know. There's
Oh, I asked him, dude, I used to pull motors apart. The rods look like S's. I'm not bullshit you. We scored 600 in the little small block. We didn't care. They'll come back after racing. Rod be like that. Okay, we can do one more pass. See where it goes.
Yeah, you know, it's one of the things to where, you know, the fuel is just so easy to do, you know. I couldn't do it when I was in there, but when the O2 correction kicks in, yeah, so it's pretty fat, all that pump shot going on. So there's your O2 correction. So again, it's trying to pull the fuel out. So in that section of the map, it's really fat. So I'll show you here. I just want you to see the table work differently now when I pull out all this fuel. So I'm going to intentionally take out a lot of fuel and really fuck it up right now. I'm going to take out 30 numbers. This is stupid, but we're just going to watch it work in action.
Die on its feet.
Yeah. Well, we're going to see. So it's got 30 numbers out. So it's adding 10. But you can see here that it did exactly what it's supposed to do, right? I took out 30 numbers. So every cylinder was adding, you know, 10%. So let's add back in 10. So let's just take out 20. Let's just say minus 10. Still wants fuel out. It still wants fuel out. But again, this is where it's just, when you're going down the track, it'll just keep doing its whole thing, you know? And subtract 5. I always want to find that magic spot where it's kind of adding and subtracting in all the cylinders. Yeah, exactly. So there we go. So some cylinders are adding, some are subtracting, you know? It shows you what it's doing. Well, look at the target. They're all at 13.5. So you can see that number 5's adding 10, number 7 subtracting 10. But look at the 2, 4, 6, 8 side. They're all pretty dialed. Yeah. Yeah, but it works. It works really well. That works really good. So I'll put this back where it was. Well, it can pull up So if I go to the negative here, remember, I got to allow them to be pulling out up to 10. So 10% is the maximum either way. What's that?
It doesn't need it, it doesn't.
Correct. Yeah, exactly. So again, it's like, we're pulling out 6 here, 2 here, 6. That one's almost perfect, right? That one's a fatty. That one's real lean. That one's pulling out 4. That one's pulling out 2.
Cylinder table, go.
Yeah,
Cylinder 7, you can take 4 out.
right.
Or add 4.
Yep. Yeah, I can't show you in this computer, but on the auto tune, it actually does auto tune in the individuals too. It's auto tune.
You said it'll drop the auto tune though after so much, right? Go into your program, right?
So the auto tune is only available on the laptop. It's not available on the EC. So you'd have to actually have the laptop in the car to be able to do it. But I wouldn't do the auto tune for the individuals, but it'll at least tell you what it would do. It's kind of cool, but it's on that PC because it's the fully licensed version. This one is not a fully licensed version. I don't have it on this one.
Okay.
But I mean, again, it's pretty cool how it can just pretty much nail the target though, individually. And it's again, because the CAN bus is 100 megabit, it can do it. That's the only reason why.
But that's pretty much what you do, but leave 10 out in the whole table.
Yes.
In the correction table, and then go into the individual cylinder table, and then add
Exactly.
that back in, because that was running at 10.
Yeah. Yeah. And for the methanol guys, you really should watch EGTs. Like the hot cylinders add fuel in individuals, cold cylinders take a little bit out, that's the whole point of it, is to be able to fine tune each hole. Obviously if what we're doing here, the O2s are great, but if you got EGTs, anything individual you can fine tune, you should use it. You know what I'm saying? For sure. And don't take huge steps. It's baby steps.
But he'll do the corrections off the EGTs too though, right?
No, there's no corrections. It's just simply there for you to figure out.
Got it.
Temperature is just too broad to do anything
That
with.
just tells you where you need to be then.
Yes,
Not correcting it, tells you where you want to go.
exactly. Yeah. But you'll get your stuff so dialed in so quick. Obviously when you're full throttle, you're going to want to look at this and just fine tune each hole. That's what you're going to want to do. But again, don't take massive steps, 2-3% at a time, because we're dealing with, individual cylinders. We're not dealing with an entire fuel map. You know what I'm saying? So you're going to want to deal with the individual itself. But you can see here, we're trying to target 13.5, and these are reading a little bit different because the individuals read a little bit different than the duals. That's an average, right, of this entire bank. And we're also way downstream also. This is nice and hot right off the cylinder itself.
Yeah, mine are all like 10 inches down.
Right. And
I try to get them all 10 inches, where some of yours are down by the collector. Yours aren't all.
no, not at all. Not at all. But they're still going to have a better chance of reading than down at the collector. It'll still be a better signal down there.
So don't pay attention to my thing.
No.
Unless I add something to the collector.
Exactly. Yeah, exactly. But
So. So when does it won't, if the table overrides the correction chart, right?
Mhm.
Because if you put where that cylinder had 10 out and you added 2 or 3 in, that the correction table is not going to try to take it back out.
oh yeah, it will. Yeah, because so you have to remember if that cylinder was calling for let's just say 2% fuel over the entire run. If you add back in 10%, it's then going to be pulling out fuel more than likely because you've added too much into that hole.
So the tables fight each other.
Yeah, exactly.
So ultimately, you want the correction table as low as you can get it, right?
Right, exactly.
Because if you put 0 to 0, what would happen to all that when you're running an engine?
It's not going to correct anything. It's at 0.
It's just going to run.
Mm-hmm.
So what happens if you put the correction tables to 0 and then you ran the individual fuel tables?
Yeah, it's
You could
gonna
do that too.
absolutely. That's the goal is to not have as much correction as possible.
No,
Correct. But that's impossible though, because it's 60 degrees outside at 100 degrees outside, everything's going to change. You know what I'm saying? So it's impossible to be perfect all the time. Don't worry about it. Even if you're within 5%, that's still totally close. Yeah. Again, don't ever try to be 0. That's just ridiculous. But if you're within 5% or so, you're fine. It's not that much of a change. And it's still perfectly fine to do that.
So why don't you just run it in closed loop all the time? Why do you run it in open loop?
It's
Most people
up to
run it
you.
in open loop, don't they? like 4,000, then it goes to closed loop above that.
Correct. Yeah, because the reason being is because again, when you're idling, when you're down low, there's a lot of variables, especially race car stuff. You can leave that all just literally on the same base table, no matter the air conditioning, it should be fine. But when you get above that, what if your fuel pump starts taking a shit? What if you start having an injector plug up? What if some mechanical starts going south? It can save you. You know, that's the point. But you can also
Could just tune it closed loop and then put open loop on them.
Correct.
And just keep closing.
exactly. And that's what a lot of guys do. So a lot of guys, let's just say your launch RPM was 4,000, they'll turn on to 5,000 and above. And just have it that way. Because you really can't hurt the motor below that, right? We care about where you're gonna hurt the motor. That's when you're making full power. Obviously,
And the control taken.
And closed loop is just what's in
Exactly.
the computer, what's it been all.
yeah, whatever those tables are set up for, closed loop wise, is what it's gonna do. Yeah, you want to be. I mean, like again, I don't see a reason to go out of it per se. I mean, here's the thing: if you get a false positive, it starts drowning in motor. Okay, you lost the race, but you know, at least it's working, doing its job. You know what I'm saying? But what if you really actually did lose something and it saved the motor?
And you leave it out.
Well, again,
Open loop don't want crap.
oh, exactly. Open loop is just
Whatever you put in.
That's exactly
it's
it.
trying to run whatever AFR.
exactly.
And that could be donated to the aluminum gods.
Yeah, exactly. That's where you got to be careful. Exactly where you got to be careful. So, but again, even if you're in closed loop, you can still make it so that my negative correction, you know, I can make this 0. So it can't even pull anything out. You know what I'm saying? You can make it so it just only adds fuel and that's it. So that way, in case for some reason sun goes haywire, it thinks it's running rich, it don't matter.
If it's leaning out, it's still not. Well, I guess it would shut off.
Well, if it's leaning out,
If it's running below, if it's running above the table, it won't pull any fuel out. If it's leaning itself out, it's not gonna pull 10 more pounds.
it's whatever you program it to.
Well,
Yeah.
Though two sensors going bad, you might think it's rich. and
Exactly.
Not.
Yeah, luckily for the most part, I mean, even on like the individuals, when they just go bad, they just go bad for some reason. It's not like I haven't actually seen them sway one way or the other, you know, thank goodness. So not saying it can't,
Yeah.
you know, but
Like you said, if you just set it so that it can't pull fuel above 5,000 RPM, 4,000 RPM, whatever,
Mhm.
then it shouldn't be a problem
well, but look,
in closed loop.
correct,
Yeah.
correct, exactly. Yeah. So in closed loop right now,
3% rich, because it won't correct back.
exactly.
But
Who cares?
Because in open loop, it doesn't even use these corrections.
Exactly. It's just riding whatever fuel tables you have. Yeah.
Running on the
Yep.
AFR.
Yep.
or the-
And that's where, you know, sometimes, especially your brat guy, if you're trying to chase numbers down to a thousandth of a second, sometimes the enrichment can slow you down a little bit, you know, just because it's putting some fuel in there. I didn't want that much fuel. And you slow it down when you're trying to be within 1,000. So that's where a lot of guys sometimes will turn it off because that way there's no enrichment possible. They're just riding off their curve and that's it. You know what I'm saying? But you can still set up some safeties to where if you're going lean, a little limiter, like there's stuff you can set up to do that, you know? So it just really depends on what you're comfortable with, you know? But closed loop can definitely save your behind. It's definitely something's going south, especially like the most common thing is just a fuel pump going bad. Like I had a guy just the other day where it was a 16 injector alcohol deal. And I'm looking at his V numbers. I said, man, these numbers are just so high. Something is just wrong here. We had no sensors on the engine. He got a DA harness, some fuel pressure. Well, his fuel pressure was at 35 pounds. And I said, are you kidding me? I said, you're supposed, it was, you know, a big, you know, methanol motor. I said, you got to be at 90-pound base. Well, that's why, you know, the fuel pressure is the 35 pounds, a big block Chevy with twins on it. And we needed some fuel. So yeah. Yeah. So we pumped the fuel 90 pounds. Boom. Now the V numbers came in. The injector goes pulse numbers made sense again. Cause I was pumping so much pulse. I said, there's something wrong here. I shouldn't be tugging on these injectors this much to get the air fuel ratio right. And I knew it based off of that number. I said, okay. And that's as soon as I saw fuel pressure, I said, well, there you go. I'm just glad it was an easy fix. You know, at least it was something simple. We could adjust, crank to 90 and everything fell into place, you know? So, but that's where, again, if you learn what your engine wants, especially on that injector goes pulse with number, you know what I'm saying? It's just you'll just know what to look for with all your logs and everything there. But like I said, just generality speaking, you know, something between 1 and 20 milliseconds is typically where you're going to be around. Okay. So it's just how it works out with all these combos. Trust me. I know. I do quite a bit of them. So
Sensors massive, but that is.
you know, that's a good question. It really depends on how much lead's in them, and it's not just the lead too; it's the other additives that they put them in also. I mean, it really just depends. I've got nitrous cars, you know, like what you're going to build, where they'll go multiple seasons. I've had one callback, but then some on the boosted side. I think really more of it's a function of heat for whatever reason. If you start getting up there around that 1800 degree, 2000 degree range, like that's where they really just start. They just can't keep up. I mean, they are a stock sensor after all. They're not necessarily meant for what we're doing to them, you know. But you know, we don't really have a lot of them go bad, thank goodness, you know. And that's another thing too. We only have a Bosch 49 and the NTK. We only have 2 sensors. That's it. So
The smartest, like they're.
yeah, I got a problem with them. I think they're good. I actually talked to the guy a little bit ago. You know, they're great sensors. I'm just saying for the O2 sensors. Yeah, no, they're good. No, they're good stuff. Yeah, and again, that's where with that expansion module, we're gonna have all those 0 to 5s available now. You know, you're gonna be able to add a lot more inputs available into it. You know, which is cool. Which is again that more stuff you can program and play with. So what's that? The O2 sensor itself? Well, that's the thing is really like when these sensors start going bad for the Bosch, they'll either go to 9.5 or nothing. So they'll actually show really fat. You know what I'm saying? I'll see 9.5 or I'll see like 20 to 1. They basically just kind of go one way or the other for whatever reason. That's what these. But with you though, you'll actually see the there's a calibration process for you. So you can actually calibrate yours and actually just in case you've never done it before. Yeah, exactly. So that's over here in this section here where you can perform that calibration. You really shouldn't have to do it too often though. It's maybe once a year thing, you know. You shouldn't have to do it unless it starts. What's that? Do you really? Oh, oh. Yeah, there you go. That'll work.
Calibrate the Bosch ones then, for those, where like that was like the NTKs, like their kits, first instruction was.
You know, we really don't have to because of the fuel type, the 85, they really don't drift.
Yeah.
They really don't move. So that's a good thing.
Yeah, for sure.
But when we're dealing with the horsepower setups that these guys are making, and a lot of times if the porcelain can crack if the moisture gets on them, then yeah, that can be an issue, you know. So that's why there is a cal process. Plus, those are so expensive.
Yeah.
You got to have some way. Right.
We should have kept pull the sensor out, calibrate, put it back.
Yeah, we just so again the way that the system is set up, it just knows what to look for.
Yeah.
And again, if it bombs out, it's going to go one way or the other basically, and that's it. And if you start seeing that, also too, there is a one thing is here with the Bosch. You want to see it real quick. There's something called a NERST value. So here, so for example, I'm gonna go to the SD card browser here. Oh, I didn't get. Oh, you know why? I had it set up for this. Okay, so here, let's do this real quick. I had it set up for the 3-step. So let's go to advanced apply. So what I'm gonna do is I'm gonna set the logger real quick, okay? I'm gonna go over here to advanced apply, custom port error. So advanced apply means that I'm gonna listen to whatever's set up here, okay? So basically every time I go above 10%, I'm gonna burn a log to the card. Okay, that's how this works. So close this up, turn that off. Anytime you make a change like that, you wanna reset the ECU. It takes those changes and boots them up. Okay, so now we're gonna go on. Fire up. See, it went fat. Our prime shot. See, I didn't like the prime shot there. See that? That's why I kept it in. I knew it was gonna do that. It's like, really fat. All right, so. All right, so now it's recording a log. Okay, now I'm going to shut it off. Okay, so now it's staying alive because of the 20 seconds in there for the log. See how it's still moving stuff? Now, as soon as the log is done burning, it's going to shut off. So you can actually see it actually happen. So what'll happen is the log will finish up. Okay, now it's going to shut down. Okay, that's the same thing as if you're going through the traps with your top sportsman car nitrous and you hit the ignition off because you want to kill for the nitrous stuff. The ECU is still going to stay alive to record. Okay, that's how that works. Okay. So now I'm going to come over here, put it back on. we'll get the log, and then this is actually going to show how to actually check the calibration of the sensors. It's not a calibration, it's basically just to see if the heater's working correctly. Okay, so there's our log right there, right? So the highest one is that little check-in file. We're making sure that we're good. So I'm going to download it. Okay, coming pretty fast.
You ever in the laptop?
Yeah, all the time. I do that mainly. This is, but for the race car stuff, you got here, and for the for these calibration values, they're actually only held in the replay. That's why I did that. Okay, so I'm just gonna go test log 1. Okay, I want to view it. Okay, so now here, there's Steve Scramble again. So now what I'm going to look for is the nursed values. So NER. So you see these guys right here, these nursed. Okay, those nurse values are for the Bosches, and basically they should all be around 300. So if you actually ever want to know if these guys sensors are going bad for you, they should be around 300. If that's 0, 2000, then the sensor's toast. Okay, and that's how you know. So, and also too, if that hole is not correcting, that's why. We have a verification check to say, okay, are we around the amount of resistance we should be seeing for that heater? Yes, then correct. If we don't see the correct amount of resistance across that heater, then we're not going to allow that cylinder to correct. It may still read, but if that is not reading correctly on the resistance for the heater, then we're not going to go into closed loop for that hole. But that's how you know. So it's not a calibration, but it's at least a check to know. You know what I'm saying? So, but that's only available on the replay itself. But it's a good question though to know, is there anything we can do for that? You know, but luckily for the most part, we don't really actually have too many failures of those. Yeah, no, we don't, but you know, luckily. So
Can you get the alcohol once you?
what's that?
Doesn't it give you the nurse
Oh,
value
yeah.
running?
No, it's for, well, it's usually only on the replay. Maybe I added them for this software update. Maybe I did add them. Now, see,
How much is
oh yeah, there it is. There it
Those
is.
2 sensors for alcohol, what are they, about 4 now?
No, they're like 700.
Okay, I don't know. I just give you the
Yeah.
money.
Yeah, that's $700.
Dude, I tell you, I actually started thinking, you know what? I started telling my wife that there are her packages and that was coming in.
So
I was telling her, I'm ordering all this stuff for you.
a funny story about Steve real quick is when he bought everything, it was probably like $5,000 worth of stuff, whatever.
$8,000.
Yeah, $8,000.
We did everything to make it right.
Yeah, and I actually sent it to the wrong address, and so we got. Anyways, long story short, yeah,
Middle of nowhere in the desert,
yeah,
2-acre lot, and the guy puts my brand new box in the front of the thing by the fence out by the street. Huh?
yeah, it was
Like,
crazy.
I go, dude, you guys delivered it to the wrong house. Well,
Yeah.
that's my house in Arizona.
I said, "What are you talking about?"
Where Germans at right now? I said, no.
It was a total mix-up on shipping, and you had a friend there.
Yeah.
Somehow we got
So you
so
looked up
lucky.
At Google, and it came up, I think there.
Yeah,
It's for shipping. It came up there.
Yeah.
Instead of my address over in Dana or Mission Viejo.
right. But I think we called the owner of that house. We like looked
you
up his.
talked to him.
Yeah, I talked to him personally, but you had already got to him.
You had looked up his phone number behind it.
I was trying to chase that box down. We're talking, this ain't Holly over here, man. That's $8,000's a lot of money. You know what I'm saying? I said, hey, we got to find that box, you know?
I said, dude, it's so big. He'll get it to me and he'll send it right over.
But we got lucky. It was, the guy was totally cool.
The whole system, the whole big stuff. The whole set sitting in front of us. This is Whitman, Arizona, you know, tweakers all over. running
Yeah.
out there. I mean, I'm lucky you got it.
We got so lucky.
Put on a 1979 Pinto. out
We
there.
got lucky. We really did. We really did. But no, you're right. Actually, yeah, so I'm just starting a regular log, and there they are. So you see right there, they're reading about 2000. So that is correct. Yeah. Sorry. For some reason I thought they were on the log, but no, you're 100% correct. They're right there. So again, it's reading 2000. Now the engine's not running, so that's okay. That's what they're supposed to read. You know what I'm saying? Yep. So we'll start it. Okay, we'll start it. There they go. So again, that's where they should be about. Yep, that's exactly where they should be. So it's something to go off of. It's not a perfect check, but if you open up the resistance, the heater, then obviously it's toast. That's how that works. So yeah, that, and again, that's just a straight up computer log. There's the other two right there. So yeah, good call. Good call, Dana. Yeah.
So that's how you can tell if they're good to the open sensor.
Yeah, it's not necessarily a fail safe because again, the sensor can actually still read if the heater's toast, because all that is measuring the resistance of the heater. Because if you just sit with this thing on, like if we go to the default startup mode for the banks, if the motor's cold, you'll feel the O2 sensors hot. So if that heater takes a dump, they won't get hot. Yeah, so correct. And that's the thing. It'll show a nurse value of like 0 or 2000. I've seen when the heaters actually go bad. You know what I'm saying? So it's just more of a check. It's not the perfect check, because once they get hot enough, they can technically read something. But if that heater ain't going, you know, again, like your guys' sensors are going to push almost, I think almost 1500 degrees. I mean, yeah, your sensor, if you actually look at it inside, is glowing red. Yeah, it's very hot. And that's actually why, if methanol guys, when you get too cold, that sensor will shut off, because it's you're literally throwing so much methanol at it, it actually shuts the sensor off. It actually bombs out and it flatlines because it's just so cold. Yeah, and that's also how you know you're running really rich, because you're so rich, the O2 sensor is turning off. Everything should be showing rich, and you start leaning it up, and then it starts staying alive. You know, so. But we got blower guys that will, part of their power management process is keeping the motor really fueled up. You got fuel coming out, turns the O2 sensor off. Then when the fuel comes back out, they magically turn back on, because now it's getting hot enough out there in the exhaust. You know.
They don't spin tires on that.
Yeah, power management includes throwing a bunch of fuel at it, right, to calm it down. It's timing, but it's also just flooding it out to kill the power a little bit too, especially when the track's really bad. You know what I'm saying? So. That's all part of it there. So, but yeah, just real quick here on the boost control section here for the guys that are running boost controllers, there's a couple things here. We have a boost cut safety. So you can simply say, okay, if I hit 10 pounds, for example, I'm going to hit a rev limiter there. For this next feature, we're actually going to put a time delay in it, as well as the custom port editor. So you can actually have this thing turn on any way you want. Right now, it's just a generic number. If I hit 10 pounds at any time for this example, I'm going to hit the rev limiter. Okay, that's how that works. Also for, go ahead.
I think we're 50 right now.
Yeah, you're probably up there pretty high, things to make sure that you don't clip it. You know, again, false pauses are bad, right?
I think that's at 50 right now, 41.
Yeah, so again, just so you understand here, it'll turn on at 10, hysteresis is 2. So that means below 8, it's going to fire back up. Okay, so remember, the hysteresis is the differential. Okay. No, that's the same thing. So good question. So let me come over here, disable this. So Chris is asking because he's got the street-based boost controller. So CO2 is disabled, but the boost GN, that's our street one right here. So that's the street boost controller, and you'll see it right there. You can turn it on right there and do it. Yeah, so you can do it right there too. That's for the street. But for the boost controller for the street, we actually have a MAC valve that we actually control the bottom port of the wastegate, and there's a duty cycle table, which is this guy right here. So basically, we're controlling the duty cycle of a MAC valve based on the actual desired amount of boost. So we're actually fluctuating the boost going to the bottom.